Hello, everyone. Welcome to our annual career fair hosted by the Engineering Academy and the Engineering Academy Booster Club. Starting off, please give a warm welcome to our keynote speaker, Ms. Faith Malton. Faith is a motivational speaker who has expertise in adaptability and resiliency. She's a natural-born engineer and will share with us how to engineer ourselves in order to achieve our own dreams. So without further ado, Faith, take it away.
Thank you. Thank you guys for having me. So my name is Faith. I also go by Fifi, and I'm 24 years old. I graduated from the University of Houston with a Bachelor's of Science degree in civil engineering and a minor in energy and sustainability. Today, I work at a civil engineering firm here in Houston, all working from home, and I work as an entry-level engineer designing sites for hospitals, higher education, and other public spaces like stadiums. Writing this speech was really difficult for me. There's so much that I'd like to talk to you about what I've learned in life growing up, and just overall things I wish I would have known. But today, we're going to stick to business and talk about your future, because what you're going to do with your life is one of the biggest questions you will ask yourself. You have more power to create your dreams than you think. I know I didn't realize how much power I had at your age. One of the objectives I was given for this keynote speech was to encourage you all to pursue a path similar to mine. And I could stand here and tell you about how exciting working in STEM is, and it is. I built a backdrop for people's lives to take place in, which is truly incredible. And whether it's in civil engineering or mechanical or electrical, we as engineers have our fingers in the pie of the future. But I can't tell you to follow the same path as me, because I don't know you. I don't know what's right for you. And sometimes I'm not even sure if I made the right decision. What I would like to talk to you about today is the power of mindset, which has more control over your life than any career path you could choose. You may not be able to see on camera, but I have one arm. Here's my cliff. That's what I call it. It's like a drop off. And you can call me the one-arm wonder, the human unicorn, tripod iPod, one-arm bandit. You may be asking yourself what happened. Was it a shark attack, a plane crash? Nothing that exciting. It's actually called shoulder disarticulation. Basically, I was born with a little bird wing that had all of the components of an arm, but it wasn't really an arm. And to my disappointment, they didn't keep it for me, not even in a little jar like you get when your tonsils are removed. But the doctors, they told my mom, she's only as handicapped as you make her. So my mom raised me to be fiercely independent. She raised me as if there was nothing wrong with me and that I could do everything that a kid with two arms could do. But when I went out into public, people treated me like I was from outer space. I can't count the amount of times I have had someone come up to me and say, "I'm so sorry," or "God bless you," or "Your life must be so difficult." And my whole life, people have stared at me. Imagine being smack dab in the middle of your awkward years, which for me, when I was in high school, I was still in my awkward years. You're dealing with acne, you have social stresses, right? Friend drama, middle school dances, terrible bangs, and then on top of it, you're the kid with one arm. Nobody knows what to do with you. They're so afraid of offending you that they avoid you altogether. That's what middle school was like for me in high school. And I'll never stop being someone with one arm. I can't control that. I can't spontaneously regenerate my arm like a lizard can with its tail, right? But I do have control over how having one arm affects me. Here are my one-arm lessons for you. I have 4. The first, the power of language. I would often focus on how my situation stunk, especially during high school. My world shifted when I began to ask myself, how does having one arm serve me? How can I turn this into a gift? Herein lies the power of language. Instead of lamenting over my situation, which I very well could do because it's not easy, I focus on how having one arm benefits me, and I focus on what I do have. Instead of describing myself as missing an arm, I say I have one arm. Words, especially the ones that we speak to ourselves, shape our character. This is because our words turns into thoughts, and our thoughts turn into our feelings, and our feelings turn into our attitude, and then our attitude builds our character. It all begins with your words. What are you saying to yourself? Lesson number 2, control the things you can and bless that which you can't. There is nothing I can do to change the fact that I have one arm, and likely there's nothing that you can do to change the hardships in your life that you have experienced. Rather than resenting the hand that I've been dealt or the lack thereof, right? I bless having one arm because it's taught me truths that few discover, or at least few at the age of 24. And I'm deeply grateful for that. It's allowed my life to be deeply enriched and has allowed me to connect with people who I wouldn't have been able to connect with had I had 2 arms. So I want to encourage you to thank your hardships for what they've taught you. When you go through difficulties, you learn how much you can handle. Anything you've experienced up until this point, you've survived. You're still here. You're still going. And confidence is built by overcoming challenges. So control the things you can and bless that which you can't. Number 3, it's not personal. I used to get angry when people would stare at me or whisper as I walked by. It was a relief when I finally learned that people's reactions to me are not about me. Their reaction to me is simply an outward communication of their own internal reality. In other words, their reaction was not a testament to who I was, only them. How they have been taught to think and act through what their culture and family has taught them, which they have no control over. And here's the really interesting part that I figured out only a few years ago. My response to other people's reaction of me was a reflection of what I thought about myself. I'll repeat. My reaction to other people's reaction of me was a reflection of what I thought about myself. For example, I was giving a presentation at one of my schools about life with one arm, and I was talking about the importance of keeping in mind one's facial expressions and how much you're staring at somebody who is physically disabled. One of my teachers stood up during the middle of my presentation, and she said, "I never want you to interpret people's reactions to you in this way again. When I saw you, I stared at you, but not because you have one arm, but because you have gorgeous hair." See, my interpretation of someone else's reaction to me having what I thought was one arm was actually my insecurity about having one arm. It was creating a story to affirm itself, when that wasn't the truth at all. She was staring at me because of my hair, not because of my arm. My belief about myself was being mirrored back to me. Remember, life isn't personal. If you're having a strong response to someone's treatment of you, make sure that you aren't making a story up about the situation. Lesson number 4, the power of responsibility. Sorry guys, if you can hear my cat, I have a cat and he's saying hello. Number 4, the power of responsibility. My life changed when I began to believe that I have one arm for a reason. When I took responsibility for how I thought of myself with one arm, I gained the ability to respond rather than to react to the situation. The word responsibility is really interesting. It's response ability, the ability to respond. I can change how having one arm affects my life, how it affects the world, my esteem, all by taking responsibility for how I think of myself with one arm. Taking responsibility shifts you from being a victim to being a creator. And that's where your power is. Your beliefs about yourself will either empower you or disempower you. And the stories you tell yourself shape you and mold your reality. In high school, for example, I told myself I was simply bad at math and couldn't do it. If you ask my friends in high school, they would say Fifi was terrible at math. She couldn't get it together. And sophomore year, actually, in high school, I almost failed geometry. And then when I got to college, I had to retake algebra and trigonometry my first year because my grades were so low in math. But during my first year in college, I started telling myself a different story, that I could do it if I put in effort, that I just needed to learn and to work hard, that my skills in math weren't a product of my nature, they were a product of the work that I was putting in. And then I followed through with action and I worked my tail feathers off. That first semester in college, for the first time in my life, I got all A's. The biggest disability you can have in this life is a negative and a poor mindset. So my question to you is, what stories are you telling yourself? What beliefs about yourself are you creating? Or what beliefs about your life? What's possible for you? What are you creating for yourself? How could you be disabling yourself? Again, my intention here with this speech is not to tell you what to do. It's not to tell you what to believe. I want to connect with you and I want to save you time. Time is more valuable than money. It's more valuable than a car. It's the only resource that you truly do have, and you don't have an infinite amount of it. Our accomplishments, achievements, our legacy is what we represent for others. And the quality of your life depends on the quality of your relationships. And that most importantly includes the relationship you have with yourself. Because your worst heartbreak won't be your first love who got away. It won't be your parents' divorce or falling out with a best friend. Your worst heartbreak will be the ways you reject yourself and you keep yourself from achieving your highest potential. When you speak down to yourself, when you tell yourself you can't, when you limit what you're capable of, that's what will break your heart. In any relationship, you have to spend time getting to know the person, their ins and their outs, all of their ticks, their shadows, and most importantly, their fears and their passions. This is why spending time getting to know yourself is incredibly important. Not only do you owe it to yourself, but you need it to live a happy, fulfilling life, and you need it to choose your career. Choosing a career in STEM is an excellent choice in pursuing a meaningful life because what you can produce in STEM can directly impact the quality of people's lives, it can impact the planet, and it can impact the future of all species. I want to ask you to really meditate on what you want to create in this life and let me be the person to give you full permission to dream big because there are infinite possibilities for your life. I wanted to be an engineer because I wanted to create a better future for the planet and for our society. And I also wanted to make the world more accessible for people who are like me, people who are missing a leg or who are in wheelchairs. What in your community do you want to make better? What problems would you like to solve? What could be improved in your life and how do you do it? Asking these types of questions is the spirit of engineering. I'd like to leave you with a quick summary of what I spoke to you about today. We covered a lot. Number one, the way that you talk to yourself matters. You always have you. That's the number one person you'll always have. Number two, thank your hardships for teaching what you are capable of. And number three, life isn't personal. And last one, number four, your power lies in your ability to take responsibility for your life. Thank you all for listening and for giving me the opportunity to speak. I truly wish you the best on your journey. You're just beginning. You have so much ahead of you, and you can truly do anything you want. You just have to believe in yourself. That's the secret. That's all I have for you.
Thank you so much, Faith, for that really inspiring talk. I feel very motivated now. Thank you so much for all your words. So now we are going to have a Q&A. So anybody who has your questions ready, please put them in the chat and they'll go directly to me and I will read them out loud for you. So I'll give you all a couple minutes to do that. So starting off, okay, we have one. So what exactly do you do at your job?
At my job, I work on the foundation of a site. So I grade the site, meaning I design the elevations of the site to make sure it doesn't flood. And I route the utilities to the site. So I make sure a building gets water service, make sure that the sanitary service is connected with the city, and I make sure that the architect's design is built correctly. It's built according to code. It's built with the right mathematics. That's civil engineers. You don't design buildings as much as you take an architect's designs and then you build them.
Okay, so here's another question. Do you have any advice on motivation daily, and how can you keep yourself going when everything goes against you?
That's a great question. One of the, I listen to a lot of motivational speakers, and one of the tricks that has really helped me is flipping the script. So for example, if I'm having a hard time and I'm saying, man, you know, this situation really stinks, or this is really hurting me, I flip it and I say, what good can come out of this? Or even if it's just small, like, for example, if I'm in traffic, for example, and I can't get to my destination, I say, well, at least I can listen to a good song, or well, at least I can do this. Like, what at the very least can you find joy in the situation? And it might be something as simple as, well, at least I took a shower today. You know, so and then it's those small things and then building those on top of each other that will keep you going. But just find one thing that is a plus in your day. And then if you can get into that thought stream of positivity, then other thoughts will start to be magnetized to you. Does that make sense?
Yes, definitely. I think that definitely makes a lot of sense that you have to find the little things that are good throughout your day so you can keep going when things are not going your way.
Yeah.
And so, for you, another question is, were there any particular hardships when you were applying? And if so, how did you overcome them? Applying to jobs, sorry.
Applying to jobs. One of the hardships that I had was selling myself. When you're applying to jobs and you're going through interviews, you have to sell yourself. And like I told you, I'm not good at math. I'm really not. I really struggle hard, and I had to work incredibly hard, and really sacrificed friends, family, everything in college just to make it work. And so I struggled going into interviews and applying for jobs, feeling like I would be the wrong pick for them, feeling like I wouldn't be, that they would be better off picking somebody else because I knew that engineering didn't come naturally to me. And how I overcame that was leaning into the skills that I did have that most other engineering applicants don't. Sometimes personal skills will take you farther in life than technical skills. It's not all about technicality. And in engineering, especially in civil, you work hard. If you can outwork somebody, that sometimes is valued more by a company than what you know. Because once you get into a company, they'll give you resources to learn, but they want to see what kind of person are you? What kind of work ethic do you have? So if you can really lean into those when you're interviewing, if you know that your technical skills aren't the best, then that's going to help you in your application process.
So I think we have time for one last question. So here's a more theoretical question. So if you could choose to either go back through your life with your second arm or continue your current life with the knowledge you have gained, which would you choose?
I would continue with my life. Hand down, I would continue with my life. I love having one arm. It's not easy. The most difficult part of having one arm is people, dealing with people. But once you figure out how to do things with one arm, you know how to do it, and that's it. It's just staying focused and really having a good relationship with yourself. But that goes for everybody, right? I mean, we're all facing challenges. We all have things that people judge us for. And the narrative, the story that we tell ourselves, how we talk to ourselves, that's what's really going to drive you in your life, no matter what happens to you.
I totally agree, 100%. Thank you so much for all your kind words, your motivational words. And a lot of people have put in the chat that they are very inspired by your speech and they wish you the best. And thank you so much for opening up to all of us about how you were able to overcome people's words and things like that. And so, thank you so much again, Faith, for coming to speak to our students. It was definitely a pleasure.
Thank you, guys. Best of
Thank
luck.
you. So now we would like to welcome our next speaker, Mrs. Wood. She is the director for the Microsoft Technology Center in Houston, and prior to joining Microsoft, she worked at Accenture for 10 years, leading business transformation projects for large organizations in the energy and chemical industry. So Mrs. Wood, please go ahead.
Thank you. I appreciate the welcome. Good morning. Can you see my screen or no?
No, we cannot see your screen right now. Okay, yes, we can see it now.
You can see it now? Okay, just a second. Okay, how about now?
Yes, it's perfect.
Okay. Awesome. Good morning, everyone. Thank you for the warm welcome. My name is Muge Wood. I'm with Microsoft. I lead Microsoft's Technology Center here in Houston. I am really excited to join you this morning for a number of reasons. Number one is that I am passionate about technology and the opportunities that it presents for everybody. Secondly, I have two sons. One graduated from Elkins Engineering Academy, and the second one is about to graduate. So we have tremendous memories at Elkins High School and really appreciate all the support of teachers, staff, and students. So I would like to share a little bit about my background, my career journey, and then go into details day in the life of in my job, and welcome your questions. I will also touch upon some of the emerging technologies that we are seeing that may be of interest to you. I am originally from Turkey. I was born and raised in Turkey. I got my Bachelor's of Science degree in electrical engineering from Turkey. And then I came to the US in 91. So it has been some time ago, 30 years ago, to get my master's degree from Lehigh University in Bethlehem, Pennsylvania. So I had the desire to have the engineering background and combine it with business acumen for technical leadership roles. In terms of my family, my husband, Brad, he works for ExxonMobil. Michael, the tall one here, he is a senior at Elkins. He's about to graduate this year, going to A&M Business School. And Matthew in orange graduated last year from Elkins, and he's currently at UT Austin for chemical engineering discipline. We have been in Houston for a long, long time with our jobs and absolutely love it. So as was mentioned in my introduction, I started my career at Accenture in 1994. I worked at Accenture for about 10 years, and my job was to help companies in the chemicals and energy industry design business processes to achieve efficiencies. So I did projects, as an example, with ExxonMobil Chemical to help design their processes at a new polypropylene plant. They started in Baton Rouge. So a lot of work around systems integration type of effort. It was a fantastic experience. It has given me a lot of breadth in terms of working with different companies. I worked with ExxonMobil Chemical, Dow Chemical, Celanese Chemical, and it really helped me build the consulting acumen. It helped me build how to approach a business problem holistically and solve it with technology while accounting for the change management aspect of what people need to achieve. After that 10-year career, I have transitioned over to Microsoft here in Houston. This was 16 years ago, so it has been a while, my career with Microsoft. And the whole time I've been in Houston with Microsoft and assumed different technical sales leadership roles to help our enterprise customers leverage Microsoft platform capabilities in a variety of ways. My current job as the Technology Center Director is really about helping our customers experience what's possible with Microsoft Cloud Services. So when I say Microsoft Cloud Services, we are talking about Azure, Microsoft 365, and Dynamics service capabilities, and they are all under the umbrella of Microsoft Cloud Services. A little bit of a personal note, I love to travel. I find that travel is a great refresher for perspective, energizer. I like to travel internationally when possible. Like I said, I have passion for science, technology, and math, and the possibilities that it presents for the youth as well as for everyone. I try to work out whenever I can, and I also love history. I work with Women's Energy Network of Houston. It's a group of female professionals in the energy industry. They put on a lot of great events to learn from and present at, and I'm also working with Greater Houston Partnership, which is really equivalent, you can think of it as a Chamber of Commerce type of thing, and we are working to attract tech talent to Houston. So Houston is a very diverse and great place for companies to come and start their businesses. We have seen the influx of technology companies coming to Texas, and Houston is well positioned with the talent here with Rice University, University of Houston, to attract the talent. So we are doing some great work there. Let me go a little bit about my current job. So Microsoft Technology Center, MTC for short, it is an investment that Microsoft makes for customers to come and experience what's possible, as I mentioned, with Microsoft Cloud Services. We have 15 technology centers in US. So you can imagine all the major cities. We have one in Dallas, Atlanta, New York City, Chicago, and so on. And we have 50 globally. So What you see in the picture here is the envisioning center setting within the Microsoft Technology Center, where our customers come in and see what's possible with cloud services. In this instance, you see the individual here doing the presentation is wearing an augmented reality device called HoloLens, and talking through how it can be used for business process simulation. So, Microsoft Technology Centers is a combination of facility, the architects that we have on our teams to walk our customers through possibilities, and the processes we use. With the pandemic, we had to orient as well to delivering engagements virtually. So we host a lot of architecture design sessions, hackathons, where we do a lot of whiteboarding to help customers architect solutions that help their businesses. And we also host hackathons where our customers build applications using Microsoft Platform Services with guidance from our architects. Energy industry is at the heart of what we do, but we also work pretty closely with the City of Houston and Medical Center as well. I want to call out some experiences that are emerging and of interest to our customers and what we see in the industry. On the left-hand side is Microsoft's augmented reality device called HoloLens 2. This is an all-in-one compute device that allows people to do simulations, training, and remote operations management. And this has become even more popular in the pandemic era because a lot of us want to be able to do things remotely. And this is a great device that combines the virtual and physical worlds for that simulation to happen. And this is also the notion behind digital twins in terms of replicating physical worlds to be able to do simulation, whether that's a refinery, a plant, International Space Station. Possibilities are really endless. On the right-hand side, I wanted to mention a brand new capability that we announced last month. It's called Microsoft Mesh. The notion here is we envision a hybrid work to be here to stay. So it becomes incredibly important to be able to be inclusive with the attendees in a particular meeting. So this capability really creates avatars for people to interact with each other in the virtual world while simulating presence of physical experience. So it's a lot more immersive collaboration experience, and we are really excited about that to change the way that meetings can take place and connections can take place. The last one I will mention is the digital twins concept. So what we see in the energy industry and beyond this, there is so much data that is generated every second. And many organizations want to make sense of that data. They want to be able to understand real time the state of operations. They want to be able to predict what may happen next, so they are more prepared. And they also want to be able to do a lot of that virtually. So the digital twins concept allow us to do that, where you can build replicas of the physical world and interact with it in a very immersive fashion. So you can run simulations, you can run training, and a technician can go on site but get remote guidance from those who may not be on site. So the exciting thing, in summary, about the technologies that we are seeing is they continue to enable and empower the way that we work, we live. We have seen a transformation profoundly in the healthcare industry, in education. I know my kids included, you all have adapted amazingly to doing a lot of things virtually. So we are looking for emerging technologies to continue to enable that, while recognizing that that will also be returned to physical world, but hybrid element is going to be there for a long time. So I love my job. It's very different every day as we work with customers. We also work with the community. As an example, NASA is a great partner to us. So it's a very dynamic day every day, and you know, change is always there. But one thing I can say is, you know, I am never bored, and that's a very good thing. So I'll pause and see if you guys have any questions for me.
I have a couple questions in the chat. Would you like to answer them now or after you are done presenting?
No, I can answer them now. My presentation is officially over, so let's just turn it over to Q&A. I can definitely answer them now.
Okay, sounds great. So we have one question. What is the application process for Microsoft like, or what did you experience? And what are some credentials that they feel like are very important to have?
Yeah, that's a great question. So Microsoft has a lot of open positions every day, and we hire externally as well as internally. One great way I would recommend is just to get a feel for what is out there. Please go look at Microsoft.com/careers, and you are going to see a lot of different jobs there. In terms of credentials, the critical success factor to working at Microsoft, and I think as well as any other technology company, that could be AWS, Google, Facebook, and so on, is to demonstrate that passion for technology and ability to learn. So at Microsoft, we call it growth mindset. Really being passionate about investing in ourselves to be able to learn and grow, because what we know today is not going to be relevant in a couple weeks. The cloud services and the pace by which technology is changing really requires that mindset. So we are looking for individuals who are passionate about technology, passionate about learning, and self-motivated to learn. That's one thing. In terms of specific skills, we see tremendous growth with cloud services because it allows customers to build agile processes cheaper, more securely, and faster. So I would strongly encourage looking into certifications for Microsoft Azure and particularly Power Platform. If you have passionate about security, cyber security, that's a timeless topic. So we are really looking for individuals who demonstrate that passion in technology. They have taken steps to learn. They have taken steps to get certified. And those are the kinds of things we are looking for. And of course, being able to work with others, being able to collaborate, because the challenges that we take on to help our customers, it really multidiscipline. It requires many people to come together so that ability to collaborate, communicate, and learn are really, really vital, I think, at Microsoft as well as any other workplace.
Yes, so our next question is, what can a high school student do to land an internship at a company like Microsoft, or just get in touch with them per se?
Yes, good question. So Microsoft accepts college interns. They organize experiences time to time for high school students, but the internship program is particularly designed for the college students, and it is run from Seattle, which is the headquarters of the company centrally, and they open up the internship application process throughout the year. So if you go to Microsoft.com and search on internships, you are going to find some information on that. The other thing I'll say is, even if even if, and this is a more technical audience here, you guys are interested in engineering, but there are a lot of different jobs within Microsoft that are technical, you know, designing solutions, programming solutions, being able to articulate the value of those solutions to customers. But there are also other jobs like legal, HR, finance. So it's a very broad set of opportunities that are out there, and we do want to make sure that we are very committed to diversity and to an inclusive work environment. So we are looking for individuals that have a variety of experiences, and sometimes it could be a college degree, but sometimes it could be an individual without college degree who may have had fantastic work experience building applications. So I would encourage looking and applying, even if something doesn't look exactly fitting. Microsoft will look at that. So the best way to start is Microsoft.com careers, and a lot of the internships are run out of Seattle for summers for college students.
Awesome. So our next question is, where do you think your industry, or specifically what you deal with on a daily basis, will go in the future?
Yeah, that's a great question. You know, everything is really about data and use of data to empower individuals to make smarter decisions and how to enable that collaboration. So as I mentioned, with some of the emerging technologies, we are making investments to make sure the insights that can be gained from data can be shared globally and equally with people. So what we see is data is at the heart of everything. So as an example, we talk about sustainability, how to protect Earth's precious resources, how to contain CO2 emissions, wastewater treatment. And in order to track many of these elements, you need to be able to master analytics and be able to make sense of the data and share with others globally. So we really see a continued demand for Microsoft Cloud services and cloud services in general, and being able to process vast amount of information to create actionable insight for a variety of industries. And we also see the need, like I mentioned before, to bring technology to environments that are going to be hybrid. So when we return to office, let's say it's fall time season, there will be more people who will join our collaboration virtually than ever before. So technologies and means by which we can connect individuals and make them feel included in meetings and collaboration will be really important, and that's where Microsoft is continuing to invest.
Awesome. So I think we have time for about one more question. So our question is, what do you recommend using for the technology produced by Microsoft, or what do you feel like is the best for somebody of our age?
Which technology to use?
Yes.
Yes. Okay, so I have two suggestions. One is Microsoft Teams. I know you are using it in your learning. Probably we will continue to invest in Microsoft Teams to have more applications embedded in Teams. So it is more than a video conferencing experience. It's more a place by which business processes are executed. That's one. The second one that I would really recommend is Microsoft Power Platform. So Microsoft Power Platform is a low-code, no-code service that allows people to build applications very easily without writing code. It's more configuration-based. And our customers really appreciate and use it very heavily because you can build applications very quickly while connecting to existing systems. And we have workshops called Application in a Day or Dashboard in a Day, where our customers virtually come and learn how to build an application in a day, how to build a dashboard in a day by leveraging Microsoft Power Platform. And I can follow up this conversation with links to those virtual training sessions. I would highly recommend, if you find time, especially over the summer, to join some of those virtual workshops, because if you put on your resume or your experience that you built a Power App, that you completed an application in a day workshop, you are getting experienced in Power Platform, it will really help you stand out, because we have such big demand for that kind of service that allows customers to realize value quickly without extensive coding. And there is extensive coding for different purposes, but if you want to achieve something quickly, I would really recommend paying attention to Microsoft Power Platform.
That's definitely very helpful advice and something new that I actually have never heard of before. So thank you so much, Mrs. Wood, for coming to speak to our students. It was a pleasure listening to your talk, and I'm sure our students definitely learned a lot.
Thank you for hosting.
Thank you so much.
Thank you. Bye-bye.
Bye. So for our next speaker, we have Ms. Tricia Thibodeaux, and Ms. Thibodeaux is Fluor's Executive Director of Global Health, Safety, and Environmental, HSE. She has been with them for 27 years and is responsible for driving consistent implementation of Fluor's HSE programs and strategies and overseeing global HSE operations. Ms. Thibodeaux has held diverse roles in engineering, procurement, construction, project management, and operations. Please take it away, Ms. Thibodeaux.
All right, well, thank you so much. Let me go ahead and share my screen here. All right, can you see that okay?
Yes, perfect.
All right, well, thanks so much for having me at Virtual Career Day. We were supposed to do it live last year, so hopefully next year we'll be able to be in person. We're hoping for that. As she said, I am with Fluor. I'll go over quickly of what Fluor does, because a lot of people don't know. I'll show you a quick video and then talk to you specifically about construction, because we are an engineering, procurement, and construction company. She already introduced me, so thank you for that. I am right now the Global Director of HSE, so that's Health, Safety, and Environmental. I have a mechanical engineering degree from LSU, and I'm a professional engineer in both Texas and Louisiana, and also a project management professional, which is a different credential. I have been with Fluor for quite a while. I actually interned with them when I was in college and then came back and worked for them after I graduated. So those summer internships, once you get into college, are a great thing. I do have a varied experience. So I spent a lot of time in engineering itself and mechanical engineering, but then also branched out into procurement and construction, project controls and project management, and now HSE, which is health, safety, and environmental. So you can imagine a lot of my year has been focused on COVID-19 and keeping all of our people safe, no matter where they're working around the world. So Fluor is located in Dallas. Our headquarters are in Dallas, but we have quite a large facility right here in Sugar Land. And we're one of the biggest employers in Sugar Land, right on the corner of Highway 59 and Highway 6. But a lot of people don't know what we do in that big silver building. So lots of engineers in there for sure. Basically what we do is we design and build capital efficient facilities. So what does that mean? I'll talk to you a little bit more. We have three business groups, one focused on energy solutions, one on urban solutions, and one on mission solutions, which I'll talk to you about in the next slide. We've been around for over 100 years and we work globally. So we have over 40,000 employees globally. So this is a closer look at some of the projects that we work on. So in energy solutions, that's mainly what we do in our Sugar Land office. It's mostly hydrocarbons, a lot of refineries, chemical work, pipelines, things like this. We also do a lot of work on small modular nuclear reactors, which is a new technology that we've developed. In our urban solutions group, we do a lot of work on advanced technologies and life sciences, and this includes biotechnology, it includes pharmaceuticals, it includes food and beverage. As an example, we're working for Frito-Lay right there in Rosenberg. I didn't even know Frito-Lay had a plant in Rosenberg, but we're helping them kit out a new line for more chips. We always need more chips. So we also work in infrastructure. So lots of roads and bridges, railways as well. We work on mines, mining and metals. So lots of mines all over the world in copper, in gold, in lots of different metals. And then for our mission solutions, that's really focused on our US government group. So we help with defense. I know there's been a lot of talk in the news about us leaving Afghanistan this year, and they're targeting September 11th. Well, Fluor has a lot of employees that are there supporting the Army. So we help them with everything that the Army doesn't do. We help them set up where they live. We help them set up defenses. We take care of their, all those daily things like laundry and feeding them. Lots of troops out there, and we support them. We do work in intelligence, but I can't tell you about that. We also do work in nuclear remediation. So lots of environmental cleanup in the US going on as a result of all of the nuclear work that we've done in the past. So a big, broad range of projects that we help our clients with. For us, we can do one of these solutions, or we can do them all, depending on what the client needs. So anything from design to engineering, procurement, fabrication, construction, and then helping the clients start up. So whenever the clients are doing these great big projects, they don't keep enough engineers on staff to be able to do them. So they hire somebody like us who has lots of engineers to help them do all of this kind of a work. But I know you're going to talk a lot about engineering today, so I thought I would focus on the construction piece of it because you may not hear about that from other speakers. So I'll show you a very quick video, and I'm hoping that it's going to work. That'll show you a few examples of some of the projects that we've done in the past. It's only about a minute long. All right, so that was just a really fast look at all of the different types of projects that we work on. We do work all over the world. I personally have been all over the world with Fluor. So I've been to Europe, to Asia, to South America, all over the US and Canada. So it's been a fantastic career and been able to do things I never thought that I would be able to do when certainly when I was in high school, never thought about this. So I wanted to talk quickly about construction profession, because this is a big piece of what we do. Nearly half of what will be the built environment in 2030 doesn't exist yet. So just think about that. And who's going to build all these projects? We're talking about hospitals, power plants, bridges, schools, museums, factories, refineries, all of these things, highways. And so who's going to build that? So we're going to need a lot more construction professionals. So including engineers, of course, that's a big part of it, but also a lot of our construction professionals. And as an engineer working in the construction industry, you'll also work with a lot of these craftspeople, heavy equipment operators, welders, electricians, to help bring the projects together. So you need engineers to design them, but you also need the people with the skill set to build them, and that's really important. So with construction, there really are two different pathways that you can take. So lots of different options. So you can go through university degree. Of course, you can get an engineering degree. It's a great degree for construction, and work your way up to maybe being a project manager, a senior manager, like what I'm doing now. There's also another pathway where you can go to a community or technical college and you can get a degree in something like welding or being an electrician, and you can go through that way. So lots of different ways to move up in the construction career path. For education requirements, of course, a high school degree is important. Again, you can go to community college, you can go to a university to get a Bachelor of Science degree. There is a degree in construction management or in construction engineering, besides the other engineering degrees that we hire at Fluor, like civil engineers, mechanical engineers, electrical engineers, chemical engineers, environmental engineers, and of course, construction engineers. So lots of different, I'm sure I missed some in there as well, but we hire a big variety of people. It takes a huge team to build these projects, and lots of different skill sets coming together. So as far as training requirements, you'll need 1 to 5 years of classroom and on-the-job training. So it's a combination. Special certifications are sometimes required, and many companies offer career-specific training courses that support continuing education. So we're never done learning. Even after we finish college, we're never done learning. We keep learning all the time. So here I listed just a few options, and all of these are in Sugar Land. So of course, in high school, you have the Fort Bend ISD Technical Education Center. You guys are going through the Engineering Academy, which is amazing. I think it's awesome. Wharton County Junior College has a manufacturing and welding technology degree. That's a 2-year degree. And then University of Houston has their construction management degree right here in Sugar Land. This is where they send their people to do construction management degrees in their Department of Technology, which is fantastic. Also, many employers like Fluor offer entry-level craft training. So trainees receive industrial credentials in NCCER core curriculum, in electrical trades, instrumentation, millwrights, and pipe fitting. So these are just other options that you have. I know that through the Engineering Academy that a lot of you got your OSHA 10 training. That's awesome. That's one of the things that we offer as well. So it's great. You're already on the ball. You've got that past you. So that's good. Some of the helpful courses you guys are already taking, so lots of math and science and engineering. There's a Principles of Construction course as well. As far as extracurricular activities, of course, the Engineering Academy, Technical Student Association at some schools. The ACE Mentor Program, I don't know if you guys are aware of it. ACE stands for Architecture, Construction, and Engineering. There's an ACE Houston chapter, and at Fluor, we host the Sugar Land chapter. So we, of course, not this year because of COVID, but we'll host high school students on a weekly basis, usually Wednesday afternoons, to come into our facility, learn about architecture, construction, and engineering, all the different disciplines. Then they have a chance to work on a project where they can compete for a trip to Washington, D.C. And also college scholarship funds. So that's something that you can do. Look into it for next year for sure. We usually start in September, October timeframe, and we'll be sending some information to the Academy to put into the newsletter as well. Things like student council or event planning committees are great. These are all building your leadership skills and your project management skills, which you'll need if you want a career in construction for sure. And for volunteer activities, Habitat for Humanity is fantastic. So I believe that you guys have a chapter right there in your school, but there's lots of Habitat for Humanity opportunities around Houston for sure. So that's my 15 minutes. I'm right on time. So happy to take any questions that you might have.
Thank you so much for that. It was very, very informative on the construction aspect of things. And so starting off with our first question, what is your favorite part of your job that you do daily?
So my favorite part, actually, and because of COVID, I haven't been able to do it. So my favorite part is actually visiting the job sites and actually walking those job sites. For me, being an engineer and being able to see something from your design and what was in your head go onto paper through calculations, through drawings, through, it's not paper anymore, but it's through CAD design and others. And then actually seeing this built in real life, larger than life for these kinds of facilities, it's just amazing to see the work that we do go from nothing, just an empty field, into this huge facility or bridge or road or whatever it happens to be. So that's, to me, the best part of my job, is seeing this work go from nothing to something that's going to stay around and help the communities that we're in for generations to come.
Wow, that definitely does seem very interesting and very cool to have the opportunity to work with. So moving on to our next question, what does your company do regarding intelligence and intelligence services for the military?
Well, I can't tell you, so I cannot answer that question. And actually, I don't know because they don't let us know. So it really is top secret. We have people who have top secret clearance to work with the government in that capacity. And so unfortunately, that's about all I can say about that piece of our business.
Yeah. So moving on to the next question, what is the most ambitious project that you have completed or in the process of completing?
All right, let me think about one. There's a really interesting project that we have going on right now. It's called the Gordie Howe Bridge, and it is connecting the US and Canada between Detroit and Ontario, I think, is on the other side. So I haven't had a chance to visit yet, but I'm really looking forward to it. It's a huge bridge. It's replacing something that they had before that's really, really old and should have been replaced a long time ago. So because we're dealing with different countries, we're also dealing with different requirements for the same bridge. And so it's been really interesting to make sure that we're meeting everybody's requirements, that we're working together. And especially during COVID, where we can't cross the, we can't cross the border right now very easily. It's been extremely challenging. So that's one for sure. Another one I'm going to give you two because I can't just give you one. We have too many. There's another project that we're about a year away from completion, and it's a huge copper mine in Peru. So that one is called the Quellaveco project. It's at very, very high elevation. So before you can even visit the site, you actually have to go through a medical evaluation not just because of COVID, but because it's a very high elevation. And so when you get to high elevation, there's not as much oxygen. So you have to make sure that you're physically fit enough to actually work up there. So it's really interesting, the challenges that they have installing this copper mine way up in the mountains in Peru. So that's another one that's really challenging.
Wow. So moving on to our next question, what classes do you feel like are beneficial for high school students, or even when you go to college to take to work in your field?
Yeah. So for me, I'm a mechanical engineer, so I think it doesn't matter which engineering discipline you decide to go with, we're always going to need that particular discipline. A lot of construction engineers also have very heavy civil engineering discipline. So, they're experts in working on roads and bridges and structures and things like that. So we see that a lot. I would say that while you're in college, if you can get any exposure to hands-on building something, like for me, there were some labs where we actually learned how to weld. We learned how to work with a lot of the drill presses and lathes and all kind of things like that. Getting that hands-on experience is really good. Another piece of it is in the industrial engineering sector, they have a lot of classes around planning. So planning to build a project this big is really important as well. Understanding what the scope of it is, what the schedule is going to be, what it's going to cost. Those are all very important for someone going into the construction industry.
I definitely agree with you that those are very important things when you want to go into the construction industry. Hands-on is definitely the way to go. So on to our next question. Let me see. So going off of the copper bridge, I think you said in Peru, what exactly are the steps it took to have it designed and then in process?
Right. So I'm going to just go back to one of my previous slides, if you don't mind, and it'll help explain a little bit more about how we actually work all of our projects. Because I showed this really fast, I know before. So in the design phase, this is usually at the very, very beginning. So the clients come to us, they have an idea of what they want to do, but they're not sure of exactly all of the specifications. And so we have engineers who work on the design piece of things, where they're doing this modeling and conceptual design. A lot of times they're doing a lot of feasibility studies, like would this be better or would this be better? And they're trying to decide between a lot of different options. Then we present those options to the clients to help them decide which way do you want to go. Maybe there's one way that you can go that will get you to market very quickly. But maybe it won't last a long time. Maybe there's a different way that you can go that maybe take a little bit longer to build it, but it'll last a whole lot longer. So those are the types of issues that the clients are thinking about. We also have to look at, you see one that says under there, siting. So siting means, where are you actually going to build this? And so for some of our clients, like the one in Peru, if you're looking specifically for a particular metal like copper, there's only certain places that you're going to find that, right? So high elevation is not the ideal place to work, but that's where the copper is. So that's where they're going to go. We do help some of our other clients, for example, if they're wanting to build a chemical plant, let's say, and they're using natural gas as a feedstock, that's what's coming into the plant. they'll want to figure out where in the world is the best place for them to build this kind of facility. And so we help them with those kinds of evaluations. Are you going to build it in the US Gulf Coast where there's lots of infrastructure already? Or are you going to build it, in another country? Or are you going to build it in a country that maybe needs this kind of facility more? Like, are you going to build it in the Philippines? Could be. We've done it. We're doing it now. So lots of different factors. Then when we move into engineering, we really are, and it usually starts with our chemical engineers. So they outline the whole process for everybody else. They decide really what that process is going to look like. And that's how the other disciplines chime in. Normally, then they're looking at much more detailed engineering. So as a mechanical engineer, as an example, the chemical engineer would tell me, I need this type of tank, I need this type of vessel, I need this type of pump, but they wouldn't know how to do that. So I would, as a mechanical engineer, meet those specifications so that the chemical engineer would get what they need. They need this size of tank, they need this kind of pump, they need this kind of vessel, and then all of the piping that connects it all. And so we go step by step. Then as an engineer, you actually pull together the specifications to buy these things. So as a mechanical engineer, I would put together the specifications for a pressure vessel, a pump, a compressor, a tank, the piping, valves. And so we'd buy each and every piece. And just think about a refinery, a chemical plant, a mine, all of those individual little bits and pieces. As engineers, we specify every single piece, and we send that information to the buyers. And so we work with the buyers. They find the best price, the best place to buy those particular items. Fabrication, we can do as well. And then all of that material, all of those designs get to the construction site at the right time, at the right place, meeting the right specification. And then the construction personnel put those all together. And so planning is very, very important. We have to figure out when we're from the very, very beginning, how are we going to construct this? What's the sequence going to be? How can we do our engineering and procurement so that everything gets to the site when we need it? And so lots of planning. And then for startup, so startup means everything's in place and you're ready to go. We usually do it piece by piece, system by system, because you can't do it all at once, right? It's just impossible. So we plan that startup too. What needs to start first? Do you need the water first? Do you need the power first? What do you need first? So we think through all of that, and then we help the clients get those things ready to go. A lot of times we'll do testing with maybe for a plant, maybe water, something that's not corrosive or dangerous, before we actually pull in the real product that comes in. So lots of testing, lots of quality checks in this part before we actually load it up, pressure it up, and get it ready to start up and go. So that's maybe a 3-minute answer to how we go through and build these projects. And it's the same process no matter what kind of project it is, whether it's a mine, a bridge, a chemical plant, a pharmaceutical plant, whatever. We go through the same process.
That's definitely a very lengthy process, but
yeah.
definitely needed to make sure everything goes as planned.
Takes years.
Oh, go ahead. Sorry.
No, I say it just takes years. It takes years and years for some of these projects.
Yeah, that would make sense because of you have to make sure everything's in place in order to make sure it goes how you want it to go.
That's right.
So thank you so much to Ms. Thibodeaux for coming to speak to our students. It was a pleasure listening to your talk, and I'm sure we all learned a lot. So thank you so much for joining us, Ms. Thibodeaux, and I hope you have a great rest of your day.
Thank you.
Bye.
Bye.
So introducing our next speaker, we have Dr. Keith Drake. He's the Vice President of Business Development for Gallon Data, providing cloud connectivity for medical devices. His activities include business partnerships, marketing and sales, overseeing Gallon Data's quality management system, and coordinating Gallon's monthly webinar series. Please go ahead, Dr. Drake. Just so you know, you are muted.
How's that? Is that better?
Yes, perfect.
All right. Sorry about that. Yeah, thank you for that nice introduction, and hello to all the students. Sorry we can't meet in person. I'm really a face-to-face kind of person, but I will go through a few slides here, tell you a little bit about my background and my career path through the world of engineering. Janavi, you can see my screen, I think. I'm screen sharing okay?
Yes, perfect.
So you see the title of my presentation is The Infinite Opportunities of Engineering. I truly believe that. Engineering as a career field gives you so many opportunities. And if I can leave you with one thought, and that is, whatever career field you go into, whatever your first job is as an engineer, will not be your last job. Each job you should view as a stepping stone to more responsibility, more opportunity, and more of a chance to give back. As an engineer, as an engineering student upcoming, and as an engineer, you have gifts and abilities that most people don't have. And so if you want to give those gifts and abilities back to society, engineering is a wonderful way to do that. Let me just share with you briefly my path. I have 3 engineering degrees, all from the University of Virginia. I got 2, my bachelor's in electrical engineering and my master's. While I was undergraduate, I was in the Air Force ROTC program. So I spent 4 years at the research labs at Wright-Patterson Air Force Base near Dayton, Ohio. I got out of the Air Force, joined a small startup company called Abtech in the world of data mining. And so I learned a lot about data analytics, machine learning, and how to apply those advanced tools to solve real problems. After a few years of that, I shifted over to medical automation systems, an early stage company, and that got me into the world of healthcare data, healthcare analytics, healthcare informatics. And that's been my main area ever since. I worked for 4 years at Quest Diagnostics. You may be familiar with Quest. It's the nation's largest commercial laboratory. Probably a third of you have had your blood drawn or other specimens sent to Quest Diagnostics by your doctor for analysis. I ran a technology-based business development program for Quest Diagnostics. As I was sharing with Jefferson before the session, just fairly recently, I've been a college professor, both at UH Clear Lake teaching undergraduate and graduate engineering. I did that for 2 years, and then I helped Houston Baptist University, just right up the Southwest Freeway from you guys, start their new College of Engineering. But about 1.5 years ago, the entrepreneurial bug was calling me again. And so I got out of academia and became the vice president of Galen Data. Now, what is Galen Data? This is our main product. It's called the Galen Cloud. It's a connectivity solution specifically built for medical devices. There is some amazing technology out there, gadgets that are implanted that you would wear that all help us with our health, but they're largely not connected. So Galen Data, we don't have any medical devices. We provide connectivity for medical devices. It's a very sophisticated system. It takes a lot of engineering know-how, technology know-how. There's a regulatory aspect. We become part of the medical device. So the Food and Drug Administration, FDA clearance, we assist in. And then, of course, since it's a cloud solution, cybersecurity, security, privacy, protecting the data is very important as well. So it's a small company. We've been around for 4 years. We're in the Clear Lake area. We're always looking for good students to intern during the summer, so keep that in mind. Let me go to my next slide here. When I present this slide face to face, I kind of go around the room and ask for answers. In the interest of time, I won't do that. But the question is, what is an engineer? And I go around the room and I get really good answers that are correct. Well, an engineer is somebody who looks at design requirements and technical requirements and architects a system and builds it and tests it, and all that is correct. But here is the best answer. And if there's nothing else you remember from our time together this morning, please remember this. An engineer is a problem solver. That's all we do is solve problems. When you go to college and learn engineering, that's the one and only one thing you'll learn, how to solve problems. What do I know? That's the starting point. When I get to the end, when the problem is solved, where will I be? Sometimes that's not so obvious. So that's an engineering skill, defining what the end point is. So where do I know? Where do I want to be when I'm finished? And how do I measure that? What resources do I have? What tools, technology, money, people, skills, expertise to help me get from point A to point B? And then what are the steps to get from here to there, from where I am now to where I want to be? And here's another thing, please remember this. You may think, wow, I've got my handle on this problem. I know what the problem is. I know where I'm starting with. I know what the steps are. And you'll get halfway into step one and something will change. Somebody will leave your team. There'll be a new requirement that you didn't realize up front, and you'll have to readjust. That's where the skill of engineering comes in, is taking your plan and readjusting it every step of the way. No plan in the history of engineering has ever been executed from beginning to end without any changes. I can guarantee that. All right, so let's get a little bit more specific to you guys, your interests, and where your next couple years may take you. This is a three-dimensional space, and think of it as the three dimensions of the world of engineering. The first dimension, do I have drawing tools? I think I do. Yeah. So the first dimension is your college majors. Are you going to study electrical engineering, mechanical engineering, chemical engineering? There are many, many different types of engineering. When you graduate, you'll get a job, you'll be paid very well, and you'll get a job in a certain industry. I've been for the last 20 years in the medical industry, but there's transportation, energy. Energy is a huge industry here in the greater Houston area. Healthcare medical that I've already mentioned is another huge industry. So you may be a mechanical engineer working in transportation or working in healthcare or working in the communication industry. And then lastly, and I want to focus on this, I think I have the next slide that focuses on this a little bit more detail. What is your role? What is your function? What are you doing in that major, in that industry? Are you designing things? After they're designed, are you developing them? Are you doing basic research before they're designed? Does anybody like to break things? If you like to break things, blow things up, then being a test engineer may be your calling. Test engineers are very good at stressing systems, whether they be software, hardware combination, and trying to break them. And if you can break them, that's a good thing, because now we know what the weakness of the system is. That goes back to the design. We improve the design, we develop it again, and it's an engineering cycle. Arguably, for the last 15 years of my career, except for when I was a college professor, I've been in sales. I've been selling the products and services of the company I represent to other companies. It requires an engineering background to do that because I'm selling to engineers. Engineers don't want to buy from vacuum cleaner salesmen or car salesmen or appliance salesmen. They want to buy from other engineers because there's a peer-to-peer relationship. Some of my classmates, when I finished my undergraduate degree, they went right into sales because they had the talent of selling, they had the engineering background, and they did very, very well. So I will clear the drawings. So the last thing I'll mention on this slide right here is your career will take you from point to point to point throughout this three-dimensional cube, throughout this three-dimensional space. You are not locked in to one location, one XYZ location. Always be looking for opportunities to bounce around and increase your influence. All right. I'm trying to get to my next slide. If I turn off drawing tools, there we go. Engineering majors, I've got about 3 more minutes before we take your questions. So there are lots and lots. You know, every school has chemical engineering. Every school has civil engineering. Some of these are a little bit more abstract: architectural engineering, agricultural engineering. I do want to focus for a minute, and Jefferson, this is the slide that you and I were chatting about briefly before the session. When someone, I have 3 degrees in electrical engineering. When someone says, oh, I'm an electrical engineer, that really doesn't tell you a whole lot. There are so many different sub areas within electrical engineering that often have nothing to do with one another. You can go into circuit design. More detailed than that, you can design the chips that go into the circuits. My area is on here, signal processing. So signal processing was my area, specifically image pattern recognition. I had a military contract for my PhD research. I developed some advanced algorithms to pick targets out of military imagery. And there was a lot to that. So I was more on the software side of electrical engineering than the hardware side. But if you pick engineering, you've really opened up the door to a wide range of opportunities. If you choose electrical engineering, even more so. There are so many different areas that you can focus on. I'll just buzz through this so we can get to your questions. Lots of other different types of engineering. We talked about engineering functions that you can do consulting, analysis. For 4 years, I did education. That was my engineering function with my degree when I was a college professor. I'll leave you with 3 words of advice before take your questions. The first bullet here, you see it reads business versus technology. Those are 2 different sides of the same coin. You'll go to college, you'll get an engineering degree, you'll get a good job doing engineering work, but it will be very important to your success in your role to know about the business side of your project and your company, because you'll be asked for advice. You'll be asked for input on business decisions. You may come up with 3 design options. Each one solves the problem, but each one has a little bit different cost. One may have a higher dollar cost, one may take more time, and the third option may require more expertise, more skills that your company currently doesn't have. So those get into the business side of your engineering project. Always look to expand your knowledge, your awareness of the business side, the financial side of whatever you're involved in. Second bullet, never just meet requirements, always do more that's required. Always put in an extra hour or 2 or 10 and provide not just 100% work product, but 120% work product. If you do, you will stand out among your peers, and that will create opportunity for you to gain more responsibility. And along the same lines as the third bullet, volunteer. Janavi, Jefferson, I see you on my screen here. Are you getting paid a lot of money to do this today? No, you volunteered. And by doing that, you're providing a valuable service to the other students, and I'm sure they're thankful for the service you're providing. You're increasing your skills. You've met me. Who knows where our relationship may take us? I may offer you an internship in a couple years, which allows you to get a good job. By volunteering for anything and everything, you create opportunity for yourselves. You never know what that opportunity is going to be, but it's always there. With that, I will take your questions.
Thank you for your presentation. I'm going to be moderating the chat for the questions now. So with our first question, although they provide experience, are unpaid internships always worth it?
Always, who knows, but I would say If money's not a factor, if you don't need to earn money during the summer, I always did. We did not have a whole lot of money growing up. Yes, so let me come at it this way. The answer is yes. If I were looking to hire somebody and I'm looking at 2 resumes and I'm looking at their internships, I don't care if they were paid or not. What I'm going to look at and what I'm going to ask them about is, what did you do during your internship? What responsibilities did you have? What projects did you work on? What problem did you help solve? So that would be the main focus that I would look at.
On to our next question. What is the most challenging thing that you have faced with the Galen Cloud?
The most challenging thing is our competition. And so let me flip back to the Galen Cloud. So it's competition. Now, when I say competition, you're probably thinking, oh, there's other companies out there that do the same thing that we compete against to get business. And there are, but that's not our main competition. Our main competition is what we call the buy versus build decision. Think of it this way. A new medical device company, 3, 4, 5, 6 people, they've got a really cool technology. They've got some stuff working, and they've gotten to the point where they realize, I need connectivity. I need, when I'm out there in the marketplace and I've got thousands of my devices being used by patients, I need to be able to monitor that data. I need to be able to know when a battery level is low in one of the devices to send them a text message to change the battery. So quite often that company will say, I'll just build my own solution. It's not that hard. Anybody can send data up to Amazon Web Services. The challenge comes in, and you see it here on this slide, is the regulatory part. FDA, HIPAA, GDPR, CCPA, 21 CFR Part 820. Our system is ISO 13485 certified. None of that has to do with the specific technology, but there's so much to it that adds to the Galen Cloud being certified by the FDA that often customers don't realize. They think it's going to be a simple matter. Many of our customers built their own cloud solution and they realized, oh my gosh, what have I gotten into? And they give us a call and we come in and save the day.
Awesome. So moving on to our next question, we have, how much importance do grad schools and entry-level engineering jobs put on which university you choose for undergrad? Like, for example, the prestige, the school research, etc.
Yeah, good question. You'll probably get different answers from different people. And I'll go back to my example. I'm looking at resumes to hire somebody. I'm going to look at what their degree is, what their grade point average was, maybe what school they went to. Certainly if 2 resumes are identical and one went to some university that nobody's ever heard of and the other one is University of Virginia, I'm going to lean more toward the University of Virginia resume. But that's not going to be a major factor. I'm going to look at the project work that student did, both undergrad, graduate school, rather than I'm going to look at the internships that they did during the summer versus the prestige of the school. So let that be a factor, but not a major factor.
So for our next question, someone asks, what were some of the major things you achieved or learned while working in this field or at your current job?
Well, good question. I didn't really realize this when I was in college. I didn't really realize it till a few years into my career. But an engineer is just a problem solver. That's probably the most important thing I learned. We know how to assess a problem, define it, and effectively and efficiently solve it. That is not, it sounds easy. I make it sound simple. That is not easy to do because of this last step. The steps, and you've got to revise the steps, modify them, and sometimes repeat the process. Engineering is really, really hard. It is more than just math and science and running numbers through an equation. That's 20% of it, but the other 80%, and Jefferson and I were talking about this before the presentation, when I was a college professor, doing career fairs like this that were in person, parents would come up and say, well, my son, my daughter is really good at math and science. They're going to make a great engineering student, aren't they? And I'd say, well, that's a good start, but there's the other side of the engineering coin. There's the math, the science, the ones and zeros, the algorithms. The other side is creativity, curiosity. Engineering is not a white-black world. It is not ones and zeros. There is fuzziness around the edges of problems and levels of gray in between. And so if you're curious about how things work or why things don't work, if you're creative, if you can look at problems from a little bit different angle and come up with a solution that nobody else can, then you're probably going to make a very good engineering student and a very good engineer.
Awesome. So kind of going off of the last question that I just asked and off of your answer, it prompts our next question. So what is a great versatile engineering major?
Can you repeat that? You broke up a little bit.
Oh, okay. The question is, what is a great versatile engineering major, or per se a major that provides room to explore multiple fields?
Really, all areas of engineering. I don't have that on a single slide. All areas of engineering, I would say if you wanted to pick the two broadest areas of engineering that give you the most opportunity, one would be obviously electrical engineering because of all these different areas. And then the second would be mechanical engineering. Mechanical engineering is very, very broad as well. In both those areas of engineering, and all areas of engineering, these engineering functions apply: research, development, test, design, analysis, etc. But let me offer a little bit additional advice. Don't let your selection of your engineering major be solely based on which is the broadest, mechanical and electrical. What do you like to do? And let me go back up here. So agricultural engineering, growing and processing food. There's a lot of engineering in agriculture. If you grew up on a farm or always had a garden, always growing plants, if that's biology, if that's a passion of yours, then agricultural engineering may be your calling. Now, there's probably only a handful of schools in the United States that offer agricultural engineering. Another area probably more specific to this area is marine and ocean engineering, anything on the water. What is it? A&M, Texas A&M Galveston is its own university that focuses solely on marine and ocean engineering and management. So yeah, pick a broad area, but also pay attention to your calling as well.
That's all we have for questions now. So if you could stop sharing your screen, Dr. Drake. Again, thank you so much, Dr. Drake, for coming to speak to our students. It was a pleasure listening to your talk, and I'm sure we all learned a lot about the possibilities engineering has to offer to us. So again, thank you so much to Dr. Drake. I thoroughly enjoyed your talk, and I hope you have a great rest of your day.
Thank you, guys. I enjoyed it as well. Janavi, Jefferson, you did a great job. And to all the students, if there's anything I can do to help you, please don't hesitate through Janavi or Jefferson to reach out. Bye, guys.
Bye. So let's get started. On to the next speaker of the day, we have Mr. Joel Morales joining us. He has been an executive director of Polyolefins Americas at IHS Markit since 2013 as a plastics consultant, helping clients understand supply and demand and pricing dynamics globally in North America. Everyone, please give Mr. Morales a warm welcome.
Good morning. Let me share my screen and see if I can get this correctly here. Okay, so, oh wait, it's disconnected on me. Try this again, sorry.
No worries.
Okay, are you able to see my screen or not yet?
Not yet.
Okay. How about now?
Yes, I can see your
Awesome. Okay, so my name is Joel Morales. Again, I'm going to talk about chemical engineering and being a plastics consultant for 15 minutes, then open it up for questions. As you can see from the slide here, if you want to be a chemical engineer, you probably need to be comfortable with math and science. You probably need to like those subjects. I always did. On the plastics consultant side.
Sorry to interrupt.
Sure.
But, I only see a white screen right now.
Okay. So I was trying to be able to look at the screen and you at the same time. I'm just going to go ahead and look to the side then as I do this. So just 2 more seconds here. We'll share this.
Okay, perfect. It's great now.
In presentation mode. There we go. Okay. So as I was saying, you're going to want to be comfortable with math and science. I can tell you in my career, now that I'm a consultant, in my consultant role, you need to be comfortable speaking in front of groups and basically selling your services and showing your expertise. And if you want to be a consultant in anything, you need to be good at it. So you don't come out of school and become a consultant right away. You need to start your career and do different things, probably 5 to 10, maybe 15 years. And then you go from that engineering role to a consultant role. In my particular case, you look at my background, I actually worked in Pasadena, Deer Park area, here in the Houston area at one of the production plants that you see when you drive by with all the pieces of equipment, making plastic, high density polyethylene specifically, which goes into like milk jugs, into a pipe that goes into the ground, gas tanks for vehicles, the bags at the grocery stores that you put your fruits and vegetables in, a whole lot of different things. And then I worked in the manufacturing side. I worked in resin distribution where I would buy that material and sell it to clients all over the country. And then I spent 5 years at a company that actually will make the bottles that you buy at the stores once they're filled with whatever product, whether it be Listerine for mouthwash, shampoo bottles, even milk bottles. So having worked in that, what we call the chain of the industry, manufacturing, distribution, and then purchasing, our client base that we serve tends to be somewhere in that supply chain. So having that background has allowed me to do what I do as a consultant. So I'm going to show you some slides here on our industry and what we do in the petrochemical industry, just to give you some kind of basis. It is oil and gas related, so I'm guessing many of you have parents perhaps in that industry, but we're what we call a little bit downstream. So in our business, when we talk about upstream, downstream, on the upstream side, the most extreme upstream is going into the ground and getting the oil and gas. And on the downstream is buying the product off the shelf at Target, Walmart, Whole Foods. So that's the entire chain. You can see here from the slides, petrochemicals are based on carbon and hydrogen and typically come from oil and gas. And in our country, the US, it primarily comes from gas because we have a lot of it. Okay. The term came up in the 20s and 30s as the refining industry took off. They needed a term to describe the other end use applications of this chemical to plastics, and hence the term petrochemical. Now, let's understand what we talk about feedstocks. Basically what they are is what you need to eventually make these plastics. And it's a very dynamic, complex industry. And it's a good thing that it's very complex, because if it was easy, then nobody would pay us for our services to explain them as best we can, the trends and forecasts in the marketplace in terms of pricing and supply and demand. So let's jump into that. Here's a bit of a spectrum of the different types of feedstocks that you can get. And on the very left, we have what we call these renewables, the biomass. You've seen the Exxon commercials about taking algae to make things. Sugars. We see in Brazil, for instance, they take sugarcane and they convert it into chemicals to eventually make the same plastics that are made from gas and from oil. And as you go left to right, you see natural gas there, 1 carbon molecule, ethane gas, 2 carbon molecules, propane gas, 3. And as you move to the right, the more carbons you put into it, the heavier the feedstock gets, and you start converting at some point there, that C4 butane. and that's the liquid that goes into like lighters and stuff. And that's a liquid, all the way to the right, which is the heavy oil. And you keep going, you get like tar, which is what they use for asphalt for building roads. So quite a bit of range in what we call these fossil fuels coming out of primarily the ground. And if we focus here a little bit on the gas side of things, this is a real big deal in North America because we have a ton of it. It's a competitive advantage for the United States. We ship our gas all over the world and we make a lot of money on it. We use the ethane gas to make ethylene gas, which makes polyethylene plastic, which we ship all over the world to supply the growing demand. You know, C3, the propane. So we have a lot of natural gas here in North America, and a lot of our industry is built on it because we have a competitive advantage versus other people around the world who have to use more expensive types of feedstocks for their petrochemical industries. Now, again, each of these molecules, starting from the bottom, you know, methane, that's what you use to cook if you have gas stovetops. Ethane gas, this goes into making ethylene gas, which goes into making polyethylene, and poly means many. So you take this, you use ethane, which comes from natural gas discovery in the US, and you eventually can make plastic very cheaply and competitively. You go up to the C3, you go to propane gas, and there you see if your parents or you grill, that's very common for using to grill, propane gas. And then the C4 and normal butane is what we put into lighters. And as you get heavier, you get more liquid. And on the left, you can see the boiling points are very different. And this is important because you may have heard of these liquid natural gas terminals where they export liquid natural gas. If you've been to an Astros game, there's Freeport LNG is a big sponsor, the big old sign. Well, they built a terminal in Freeport to take liquid natural gas in these very thick steel shipping vessels. And you need them very thick because you have to freeze and pressurize these products because the boiling point is so low. You see there at methane, 161 degrees negative degrees Celsius. So each gas is very different, has its own supply and demand dynamics and own industries. And this is the kind of stuff that we follow as consultants at IHS Markit. Now, if you look at how natural gas, now we all just take for granted in our homes that the fireplace comes on and you can cook food, but it's a very complex supply chain. We saw just how complex it was here in mid-February when many of us were without power and electricity. Actually, most of us were able to keep the natural gas flow if you had a gas fireplace. So that was a good thing. This is kind of a flow diagram. So if you start on the left, you see the wellhead, that's you're taking the actual gas out of the ground. And if it's called wet, that means it has some natural gas liquids associated with just the methane gas. Methane is dry. That's the wet gas is the ethane, the propane, and the butane. And you take it to a processing plant and you separate it with equipment. And you see there on the right, the dry gas, the methane, well, that goes into these pipeline systems to heat our houses. That's the industrial use, what we call residential, ResCom, residential commercial use, the biggest use of gas in our country and frankly, the world. But then you see those NGLs coming down at the middle. That's the natural gas liquids. That's the ethane, the propane, the butane, and that's fractionated at other plants. They take advantage of the differences in the properties, and they can send the ethane, propane, and butane to the petrochemical industry, as well as the light naphtha also. So this stuff is very complex and very and separated all along the supply chain. And if we look at there, not only is there the gas side, but there's also, we talked about earlier, the heavier you get in carbon, you start going to liquids all the way to asphalt with 50 plus carbon chains. And each one of these has its application, right? Gasoline, C5, C12. I mean, that's what you put in your cars. If you're taking a jet fuel is very different than gasoline that goes into vehicles. Heating oil for houses, all the way to bunker fuels for the ship liners, to asphalt. And so each of these has its supply and demand dynamics. Each of these has its demand markets. And we follow the pricing by following supply and demand, any trade patterns, global tensions in the Middle East. If they're fighting with each other, some of the supply has changed. All that basically keeps us in business as we talk to our client base on market trends. And as I mentioned, the part about knowing the math and science as a chemical engineer is all throughout this chain, there's pieces of equipment where they take heat, is a very easy one they do. Here's an example of a distillation tower, a separation column. Basically, you just heat stuff up, and things have different properties. And as you heat them up, your heavier components will stay, and then the lighter components come out of the top, and you separate gases. And as you get things that are closer together, well, you need more complex distillation columns to separate gases that have boiling points that are very similar. So it's chemical engineers that will design these distillation columns and make sure they function properly. And every year there's innovation and new techniques and new technology to make these things cheaper and more efficient. And these feeds, as I keep mentioning, they're very different. So here's an example of, on the left, light naphtha, which is a type of carbon, C5 to C9, heavy naphtha, more carbons, kerosene, more carbons. And as you go left to right, the liquids get more viscous. So on the top, if you think about it, some stuff flows like water, and on the right, some stuff flows like molasses. And you can imagine when you're designing equipment, it's a lot different a piece of equipment to handle liquids that flow like water than flow like molasses. And this is what chemical engineers do in our industry, is they figure out how to separate all of these in the most efficient and profitable way that they can for their companies. Now, crude oil, which is the oil in the ground, goes to refineries, and refineries principally make gasoline, but they also make some stuff that supports the petrochemical industry, which is over here in the steam crackers and olefins. So the message here is that oil not only goes into gasoline, but it also goes into making critical chemicals that go into plastics that we use in everyday life. And as you can see here, on a 0 to 100%, what comes out of a refinery, a very small fraction here goes into what we call this petrochemical use. So the majority of it is gasoline, kerosene, jet fuel we talked about, LPG, which is propane and butane that we ship around the world, and some of this asphalt, PET coke that goes into making roads. And this stuff is very heavy, high carbon, and you've got a wide range of products coming out of the refinery. So refineries are important for chemical and plastics production, but the main use of refineries is still gasoline. So in my last minute, before we open it up to questions, basically it's a very complex industry. We're very blessed to be in North America, where we have competitive and abundant natural gas and natural gas liquids like ethane and propane. The ethane allows us to make ethylene and polyethylene, which gives us a competitive advantage to ship those plastic pellets to other parts of the world that they need them, like China, Indonesia, where they have these developing middle-class economies, and they make product that we buy over here on Amazon. So in essence, we send them the product so they can make it cheaply over there and send it back to us that we're buying online every day. So with that, I'll open it up to questions and appreciate your time today.
Awesome. So for our Q&A, starting off, we have a question. Did you learn about all these types of plastic in college, or is it something that you learn, or is it something that you learn on over time working in the field or at your job?
Sure. So, college is meant to teach you how to think, right? So you learn very broadly a lot of things in college, but your biggest reason you go to college is to show the workforce that you can complete something and that you know how to think. So I will say college taught me some basics about plastics in books, but my career in working at the plants and talking to customers and seeing what they made and produced and learning about that in the marketplace, walking through a Target over the years and seeing the types of plastics change and things going from metal and glass to plastics. I learned more on the job than I did in school, but school is absolutely 100% required to get your foot in the door, to prove to future employers that you were able to finish 4 or 5 years of school, and we hope that you learn to think. So I can tell you in our field, if you don't have a 4-year degree and preferably in engineering, you don't get a chance through the door. So it's very important that you go through college just because you need to prove to the workforce that you can complete something. That's very important. Yeah.
Awesome. So our next question is, what is your favorite part about your daily job?
So my job's changed a lot with the pandemic in the last, call it last 14 months. You know, one of my favorite parts used to be to actually see my clients and move around the country, speak at conferences, go to China once a year and to their plastic exhibitions and see the different trends around the world and meet people from different cultures. That has changed. It's been replaced with a lot of this on Zoom. I would say that still dealing with people all over the world and helping them is a favorite part of my job. And I look forward to hopefully within the next 6 months, not quite the same amount of travel as I used to do, because I think the pandemic has proven that we can do our jobs efficiently and effectively without having to travel so much. So that's good for the family home balance. But I do miss seeing my clients. So favorite part of my job is the people interaction. So I'm an engineer, but by no means am I in a lab or punching numbers, 8 to 12 hours a day. I'm interacting with people on quite a bit, which is why I mentioned earlier, if you like consulting, you need to be a people person. You need to like to speak in front of groups, debate at school, any opportunities that you get to stand and speak in front of groups. All that stuff helps prepare you for a consultant type career.
So our next question rides off of your answer, actually. So how many years do you think it will take to be a consultant?
So I was very fortunate in that I started right out of school as a chemical engineer, worked at a plant in a kind of a technical service role, which had an engineering role, but also had a commercial aspect to it. So some people typically, you come out of school, you go work at a plant 3 to 5 years as an engineer, you work on distillation columns, separation systems, how to make things from 80% efficient to 85% efficient, because all those percentages of efficiency result in dollars for your corporation. But I was kind of able to skip that role because they needed somebody, and I speak Spanish. If you can speak multiple languages, that always opens up your career paths as well. And I immediately worked in a tech service role that allowed me to work with the plant a little bit in engineering, but also travel with the sales force to go see customers and try to troubleshoot their problems because I spoke Spanish, and I did that in Mexico, Latin America. And so I kind of skipped a bit of the 3 to 5 year, pay your dues as an engineer. And then I went to resin distribution and learned the sales aspect. And then I got to be a buyer of what those plants made. So I learned that aspect. So it took me, I would say, about 12 years of work experience to become a consultant. And I think, there are exceptions to everything, but people that do what I do and my colleagues tend to have closer to 15 to 20 years more experience. So, there are different levels of consulting. We do hire some folks right out of school and they're junior consultants, but it does take them a while to develop. So I would say a minimum of 5 years with maybe a max of 15 type of range.
Awesome. So moving on to our next question, what classes do you think are beneficial to high school students, or what classes should we take in college if we want to do something similar to your field?
Sure. So, there's no consulting field in college because consulting is for anything, right? You can be a soccer coach consulting, a dance instructor consultants. There's all kinds of consultants for anything. Anyone who feels that they're good at something to the point that they can get other people to pay them for it, you're a consultant. But specifically for the engineering side, and engineering is very unique in that once you become an engineer, you can go to law school, you can go to med school, engineers prove to the workforce in many ways that they are capable of using their brain and doing critical thinking. And that opens up the door for almost anything. Finance, I have college friends who I went to school with who are all in Wall Street in the finance sector. So there's a wide range of potential career paths. Engineering specific, you got to like math and science, really math. Okay. If you like chemistry, then the chemical engineering piece is good. But physics, math, science, those they don't need to come easy to you, but you need to like them. If you don't like those subjects and they make you unhappy, then engineering's probably not for you. Maybe computer science is a bit different. Now, if you do feel you want to eventually be some kind of client-facing consultant role, then I would couple the math and science angle with some debate. And you don't need necessarily take the debate classes, but just in general, if you get opportunities within your school with clubs or such to speak, it's difficult to speak in front of crowds, right? It's not easy to sit there with a bunch of people, and you can't memorize speeches. You try to memorize speeches, it doesn't work. People choke when they try to do that. You need to learn to stick to a few themes and just talk. You need to learn that if you forget what you say, you just stop and pause. See, we had an awkward pause there. That's a lot better than trying to stammer or stutter. So the earlier you can give yourself experiences, heck, you can talk to your families. You can talk to yourself in front of a mirror. But if you do want to be client facing, the sooner you give yourself those uncomfortable experiences and talking in front of groups as much as possible, it just makes life easier. And like everything, if you prepare for something and you know your stuff, you give yourself that self-confidence to handle anything. I love going into a conference and not knowing what questions people will ask me, because I like to think on my feet. And I don't mind doing it in front of a group. And if I don't know the answer, then I say, you know what? I need to consult with my colleagues in Asia or in Latin America or in Europe and get back to you. So it's perfectly okay to tell people you don't know. It's better than to make up or try to show that you don't know, if that makes sense. So.
On to our next question. What has changed in your day-to-day job, having to move to mostly online, and what have you learned through it?
So there's pros and cons with almost everything in life, and certainly with the pandemic change in the workforce, and it has major changes on markets, right? So we talked about gasoline. Gasoline consumption went way down with the pandemic because people were working from home, not driving to work. And for a time there, people weren't moving around very much. So that changed the price of gasoline, the price of oil, the price of petrochemicals. It changed demand patterns. So people like myself who used to go to work and go to lunch and started eating at home. And so you go to the grocery store more. And if you think about that, you're going to take more bags from the grocery store. You're going to buy more food that's what we call smaller packages that have more plastic. So plastics consumption actually went way up. People started doing home improvement projects. So people like Home Depot and Lowe's started selling a lot more products. So there was a lot of changes. I will say specifically to your question, what the good and the bad, I miss seeing my colleagues. I miss seeing clients. I think the life-work balance may have gone the other way too much. If maybe people are around their families a little bit too much now, because especially if your kids are online at home and you're at home and everyone's at home. So life's about balance in almost everything. So I will say I like the working from home aspect because I'm much more efficient, because I'm out on the road going to the airport. I'm out on a plane missing. I can't. But the flip side is I probably work more now than ever, because it's so easy to wake up and be in your office in 15 minutes. And since there's no drive home, you can work as long as you want. If you're at an international company like myself, you're getting emails all night and all day. You can work 24 hours a day if you want. So the nice part is spending more time with the family. The bad part is it's probably more challenging to find this work-life balance because it's so easy to work. And companies benefit from this high level of productivity from their employees that they've never seen before. So companies have actually gone from, we were worried about our employees not being productive at the beginning of the pandemic, spending too much time during the day on Netflix. And it turns out they can probably watch a couple hours of Netflix during the day. They're still more productive because they don't have that drive, because they're working too much, that now we're having to tell them, hey, you have vacation, please use it, stop working so much. So it's been a very interesting dynamic here.
Yeah, that definitely seems very interesting with the work-life balance, and you have to find that to be able to benefit yourself and others around you. So thank you so much, Mr. Morales, for coming to speak to our students. It was a pleasure listening to your talk, and I'm sure our students definitely learned a lot. So thank you so much, Mr. Morales. Have a great day.
You guys too. Good luck, everyone. Enjoy your weekend.
Thank you. On to the next speaker of the day, we have Dr. Nathanial Wiggins. He works with both San Jacinto College and Galveston College, and he's also a distinguished professor of engineering and mathematics and a principal investigator of AI Tech Labs in San Jacinto North Campus. Without further ado, please take it away, Dr. Nate.
Thank you. I'm glad to be here. Let me do a screen share here, and we're gonna. I made a bit of a PowerPoint that we can go through today. Okay. And so I am Nate Wiggins. I teach math and engineering courses. I work with San Jacinto College. I work with Galveston College. I also work heavily with the University of Houston system. And then I'm a principal investigator with AI Tech Labs. Basically, I run my own research lab. Okay. And so just a little bit of background on me. I've got a PhD in systems engineering and engineering management from Texas Tech University. I have a master's degree in mathematical science. I have a bachelor's degree. I have applied math, pure math, astrophysics, and Russian literature. Right. And then I have certifications, CAD software certification, online teaching certification. And then I also have a graduate certification from Stevens Institute of Technology with the Department of Defense. And it's in systems engineering. It's like weapons systems, but it's mostly for space systems. I don't necessarily design weapons. Okay. So really, what do I teach? All right. So I teach your kind of first 2 years of engineering classes. And then I teach a bunch of math classes. Okay. So, that's kind of my world. I don't get to always teach the math classes these days. They're kind of a treat for me to get into. I try to teach a college algebra each semester if I can. It's kind of the lower level math class, and then a differential equations, your kind of end math class for a lot of you going into the engineering world. And then you have something like engineering math, but and I teach that occasionally with U of H. And I do a lot of programming type. So when you look at my world, it's going to be a little more computer heavy. Okay. So what kind of research do I do? Well, I make augmented reality homework systems. So like I work with basically making a homework system that you can deploy in front of you. You could imagine being stuck in a math engineering, even a history type question, and being able to pop a 3D model out with you would be very beneficial, right? So I've been developing a different type of homework system that's a little more interactive than probably what you've been used to. I work with neural networks. So if you play video games, I make artificial intelligence that goes into video gaming. And some of that would be like, if you could learn how to beat the video game, what if the video game could relearn how to beat you? Okay. So it's kind of a different ball game. So some of what I work in is more in the academic world, but the casino gaming, the video gaming, things like that is right in my world. Okay. And then mathematical chaos. So I look at system dynamics and chaos. That's something that I would like to show you today. And so being able to generate things that have chaotic behaviors and emergent behaviors. Like, for example, you're a bunch of bacteria cells. That's how you make your body up, right? So the fact that you have human consciousness is absolutely incredible. That's an emergent property. It's called spooky emergence. Okay. And what we see is that we can actually mathematically model these things. So that's kind of my world, is very complex systems, right? That we can model. Okay. So what do I do with students, right? So up here in the top left, you'll see a picture. I'm in the hat here. It's a UHCL hat. And this is Dr. Luong Nguyen. He's over at UH Clear Lake. And this is Dr. Moses. She's at University of New Mexico. And they do swarming dynamics, right? So, and then in the background here is a NASA director, right, of MUREP. And so my students recently have won the NASA Swarmathon. We're one of the top in the world in swarming dynamics. So if you want to control one robot, I can give you a PlayStation controller. But if you want to control 100 robots, we have to have a different approach to it, right? Particularly if they drive, they fly, things like that. There's a lot of dynamics there. So usually when you come out, and so I build robots. So usually when I'm in person, I have robots with me. I have one that can do push-ups and sit-ups and a handstand and all kinds of crazy things. So what you can see here is some NASA Swarmathon type stuff. And we've got basically an augmented reality system so that it's kind of a VR system where you can see the robot, as well as an actual physical robot system. And then you can see that we're running stress dynamics on it. So we're always trying to improve our products, right? Being able to do these things. Another project that we've done recently is acoustic flame suppression mechanics and microgravity. So basically, like if you have a fire on an airplane, okay, or a space shuttle, using like a fire extinguisher is a mess because it's got propellant in it, right? And there's a bunch of stuff in it. So that would get in your ventilation system and it wouldn't be good. So it turns out that you can actually put out fire using sound waves. So working with some military groups, we were able to demonstrate that we can put out fire using sound waves, particularly in microgravity. Okay. So on the little planes here, there's two planes. The one on the right is called a guppy. It drops an airplane out of it. So it looks like the plane's giving birth. It's pretty wild, dude. And then on the left, you'll see the 0G plane. And that's the one my students go up in. So it goes really, really high over the Gulf of Mexico into the atmosphere, and then it just dumps. Okay, it drops, and you experience no gravity. So the students get about 20 seconds at a time of zero gravity, and they get to experience that with training astronauts. So we've been on multiple of those. One of them's microgravity, where we were putting out fire using sound waves. Another one is trying to figure out how could you play motion controlled video games in space? Do they work? Can you control a robot like that? And it turns out there's some challenges there. Here in the middle, you'll see a augmented reality chemistry lab that my students developed. And so that's with the company Serial.io. They're a Microsoft development group. They work in the United States and Singapore. And so the students had created an augmented reality chemistry setup so that you could actually learn chemistry with more of a video game setup through a headset as opposed to the traditional lab setup. Below that is a wing design that we worked with Boeing on, and it's SATOP, the Space Alliance Technology Outreach Program. So this is a patent that we helped develop, and it's a special kind of wing that has a hole basically through the wing, so that it directs aerodynamics a little bit differently. And that was actually patented, and now it's used in aircraft. So these are things that my students are developing that are actively being used. On the top right there, you'll see a Fresnel lens. And that's something that we're gonna be showing next Wednesday. I assume you actually have class, so you probably couldn't join us. But with the Texas Space Grant Consortium Design Challenge, my students will be presenting basically a cylindrical lens that instead of a solar panel, you would put this out, because solar panel you have to move. And if you put that on the moon, it's going to get moon dust in it. Okay. So Jacobs Engineering is proposing a different way to do this. And it's a special kind of lens that'll get funneled in, and that makes it so you don't have to move anything. There's no moving parts. And so we're proposing this to replace solar panels for the lunar program here. So we'll be speaking with NASA next week, and we'll see if that idea gets picked up. I believe that it's going to. One of the senior scientists at NASA is really promoting it. And you can see that we've generated it's called a wavefront plot, basically an intensity plot across the surface. And so we can actually demonstrate our efficiency using simulation designs. Below that is a nano fluid battery system. And so the students worked with University of Houston and Rice University to create a battery system that uses nanotechnology. And the advantage here is that we're able to cool a lot more efficiency. You can see the original design kind of on the left there where it's got a lot of red in it. That's the thermal test. And we're showing that we're going to have meltdown right there. And the design on the right, you can see that we've actually eliminated that possibility. So by redesigning some stuff, and the students do this, they come up with their design, they propose it, and they run it, that you can see that it's effective, and they actually get published and things like that. Okay. So do the students get recognition? Oh yeah, they do. Here's a set of publications that they get. We've also been on Discovery Channel multiple times, and we've been on Nova specials. And so these students get an opportunity not only to do research with industry professionals, but they get industry recognition for it. They get publications, it gets them preference into jobs, and it gets them preference into grad school. You heard the last guy, and he said, well, you know, I learned from books. Well, that's good. That's cool. You're going to need to learn from books, but can you actually get job training before you walk out the door? And that's what I want my students to be able to do. You know, I've got students that are now senior scientists on lunar landings and all these different things. And I feel like the trick there is to get that opportunity before you walk in. Okay. So let's try something together. Okay. So, a bifurcation is a qualitative change in the system, okay? And I have a differential equation, but I don't know if you guys take differential equations. So we're going to try to do this. So instead of that, what we're going to do is we're going to try to make it iterative, okay? So x of n plus 1, like the weather today depended on the weather yesterday, right? And the weather tomorrow depends on the weather today. So let's think about spread of technology, spread of disease, which is a popular topic right now. And basically what we're going to do is we're going to take, let X of N be the percent of people exposed, whether it's a virus. Let's use a virus. It could be technology spread. And there's some other things. This is called the logistic model. Okay. So what we're going to do is we're going to look at this in iterative form. Now, I don't know how much programming background you guys have, so I'm going to use Excel today so that I'm not dragging you through a bunch of programming. And I just want to show you something that I can do. Okay, so here, I'll zoom in a little bit. Okay, let's let N be the day. Okay, let's let K be this biological parameter. What is it? I don't know. Go blame the biologist. And then this is going to be X. That's going to be your percentage of people. So on day one, we see that K is 2.1 and 10% of our people are sick. Fair enough? Okay, day 2 equals day 1 plus 1, right? So that'll give me day 2. K, we're going to say doesn't change right now. Okay, and X is going to equal K times X times, and then 1 minus X, okay? So now what we're going to do is we're going to run this simulation. So this is the equation that I had, right? K times X times 1 minus X. So that's what I have here. And let's run it for a little while. I don't know. Let's be all biblical about it and run it for 40 days, okay? So now we got a data set, but the data set's hard to look at. So we're going to actually just go look at a graph. It's easier to look at. Okay, so you see how it leveled off? So not everybody got sick. Right? Not infinity type people got sick. Not my whole population. In fact, about 52% got sick. Okay. Now that's cool, right? What is this K value? Let's go back to what we were blaming the biologist for. I changed it to 3.2 and my cell mutated. Okay. So I took a single cell and I just created a mutation across it. You see how we're bouncing? We have a bifurcation, which is a qualitative change in the structure. Let's go to 3.5, let's say. It mutated twice. Now I have a period 4, right? Up, down, middle down, and it starts over, okay? So you have one cell, it splits into 2. The 2 cells split into 4, and each of them have kind of their own properties, right? You know, each one's a little bit different than the other one. What happens when we go to 3.7? It became chaotic and unpredictable. Okay, so our single cell, which you guys have taken algebra, right? So this is just a quadratic type equation, right? You're going to get K times X and then K times X squared. That's just an X squared equation. I'm not doing anything real complex here. And it became chaotic. Okay, so I have a theorem for you before I run out of time today. If it goes from 1 to 2, if it can go from 1 to 2, it will become chaotic, unpredictable, and uncontrollable. Okay, so that's what I want to show to you today. It's something out of dynamical systems. This is my background in systems engineering, and I have abilities that I think make me a superpower. Okay, so this is something that I work with. I work with a lot of different groups. And as you can see, I work in chemical engineering, I work in mechanical engineering, I work in chemical computer engineering. I'm all over town and I'm popular. Why? Because we have these abilities, right? Because we have the understanding and knowledge to do this. This isn't real complex. I did it out of algebra, and that means I can teach it to you even at a freshman level. Okay. So what do? I'm a teacher. Okay. I'm a teacher. Let's go back to the beginning. I'm a teacher and I work with these colleges. So if you come to these colleges, I can start teaching you right away. Now at San Jacinto College, I got students go, why don't I go to the university? Just go in as a freshman to the university. What's the difference? Your freshman instructors are usually just that. They're instructors. They're not professors. Okay. At the junior college, you have the advantage that we're already specialized and we've already got these abilities and we teach. We're not a grad student that's running the class. We are a full-on teacher and a professor. Okay. So my students, when you go into this competition here, we're competing against seniors and we're going to beat them. Okay. Again. Okay. So what, and we're talking UT Austin. I'm going to go beat the best. We're not going to go against the scrubs here. And so what I want you to do is you decide what school you want to go to. It's not what school you start at. It's what school you end at. Okay. So when you look at my degrees, I've got degrees from the top institutions, right? Okay. Now Clear Lake is at the top. Yeah, I like them. They're really good. Okay, you guys. Texas Tech, they're the top. Stevens Institute of Technology, it's the top. Two of my bosses, when I went to University of Colorado at Boulder, won Nobel Prizes. Okay, so now 3. Now the third one just won one, but that was recently. 2 of them while I worked for them have won Nobel Prizes. So I've had an opportunity to work with some of the best and some of the brightest. And what I want you to do is when you go to a university, you find the best and brightest because they're there. Okay. And you go find something that you can do research with and you get your name on a project. All right. So I'll turn it over to questions for you. I can answer questions. I work a lot with the different colleges. So if you're ever wondering something about, hey, can I get a systems engineering degree at U of H? The answer is yes, up at the Cotie campus, right? Or can I transfer from San Jacinto College to University of Houston without getting my full degree? Yeah, you can. I can help you do that, man. It's okay. It's whatever's going to benefit you at the end goal for you. Okay. And so if you're ever looking for something, come find me. My name's Nate and I'm the loudest person in town. All right. And if when the world opens back up, I'm going to show you my robots. All right. Okay. I'll go ahead and open the floor to questions for you and anything that I can answer for you today.
Awesome. So everyone, please put your questions in the chat. And starting off, we already have one question. So the question is, what was your favorite project or assignment when you were in school at your colleges?
So I've got a few of them. One of them is with Dr. Cash at University of Colorado Boulder. There's a new satellite going up. It's going to be called the James Webb Space Telescope. Okay. So back then it was called the Next Generation Space Telescope. James Webb was one of my teachers. All right. So what we got to do was design an experiment that's going to go on that telescope. And so my suggestion was a way of detecting Earth-like planets around other stars. And now MIT stole the thunder. They're using basically exactly that method. So I got to be on one of those early projects of finding Earth-like planets. Okay. Another one was in graduate school. My grandfather, before he passed away, he had a hearing aid. And when we went out to a restaurant, he couldn't hear me because of the background noise. It's called broadband noise. And he couldn't hear me. And that's frustrating. It's like, man, that's frustrating. So I got to work with the Institute for Space Systems Operations with University of Houston, and we generated a new type of auditory component that went into a hearing aid. And it also went into a space shuttle component, was why they were working on it. But it went into a hearing aid. And by the time I graduated, my grandfather had a hearing aid and he could hear me at the restaurant. So I identified a problem and we helped create a solution for it. And to me, that was amazing.
Wow, that is really amazing that you were definitely able to help your grandfather. Okay, moving on to our next question. What can a high school student do to partake in a research project over the summer?
Okay, so what you need to do is, it depends on what you're doing exactly. So there's different types of programs going on. And my group will be running different things over the summer with University of Houston. And we are looking at computation and some different things. I'm actively working with, it's actually a purse designer. You guys familiar with Versace? I don't know. Anyways, so there's a purse designer, high-end purse designer, if you're going to buy like a $5,000 purse. And they want artificial intelligence embedded in their purses. Okay. So I'm actively looking for students that are interested in getting involved in some of this and taking a shot at that. Right. So we're looking at some different projects that we can do. And then if there's something called the Space Robotics Challenge. If you look us up, us and Clear Lake are working on it. And there's some area that you can do right there. Even if you're sitting at home, there's something called ROS, the Robotic Operating System. And we could start teaching you how to build your robot in there, in kind of the virtual reality system, so that you would be prepared to get into this, because we're going into the next round, and we need to be able to do some major tasks. If you've ever seen a robot try to open a door, it's incredibly difficult. Just little things that seem simple. And so we need to be able to start building the robots to do these things. And we're working actively on that with Lockheed Martin.
Awesome. So moving on to our next question. What would you say is the most inspiring or motivating thing in your career?
So when I was an undergraduate, I came into a classroom and the teacher started writing and he started following his finger. And I'm trying to figure out what's going on. And I realized this guy's blind. Okay. So my teacher is blind. He cannot see. And he's in mathematical analysis. So he's producing really complex math proofs without being able to see. Okay. So well that we started calling BS on him. Like you got to be faking this, right? So me and my friend are going to sneak out one day. So I stood up and he looked in my direction and he says, "Wiggins, where are you headed?" And can he see me? So later on, I go over to his office. I've got a question for him. So I go walking in and he says, "Nate, have a seat. Let's talk." It's like, how is he doing this? And it turns out he can hear really well. Okay. So I was just inspired by the fact that he can't see, but he can do math really well. Not just he can kind of do math. Like, this guy's one of the top that I've ever seen. And it's like, okay, what's going on? So when I started teaching about a year ago, I had a high school group and I had some students in there that are blind. Okay. And particularly one girl. And I thought, okay, so we're going to do programming. We're going to program an LED to blink. Okay. And of course you can't see it. So it's like, all right, fine. So I get them some cell phone buzzers, your cell phone buzzers. It works a lot like an LED. So we hooked that up and this girl starts programming and making that thing buzz. And we made it make her name in Morse code so that it could buzz her name in Morse code. And she was able to program using a software called JAWS, and we had it going on. And I walked in there not knowing that I was going to have a blind student. And by the time I walked out of there, she was programming. And I thought, I can teach you math. I can teach you how to program. Like, I can do this. And so that was very inspiring to me. And now I'm looking at how can I make math and engineering lessons for students who maybe have a slight visual impairment, who have a major visual impairment? How can I do this? Because it turns out that, you know, we all have intelligences in different ways, and there's ways we can leverage that. And I just think some students are being left behind sometimes, and we need a way to fix that. So I'm looking into that, and that's something that I'm definitely inspired to do.
That's definitely a really, really inspiring story, and really cool to hear that she was able to buzz the phone like using Morse code while she was also blind and coding. That's really, really cool. And so moving on to our next question, what other types of people do you work with on a daily basis, or like your students, how do you communicate with them? Is it only online? Just what do you do in your day-to-day?
So before the world shut down, I was a lot online already. Okay. Now I'm fully online, which is a bit of a bummer because I miss my lab. I miss having the electronic access, right? Like if you wanted to 3D print something, it was nice. Or if you wanted to program something, or you had this idea and you wanted the guts to be built, you know, we could run into the lab and do it. So we've been communicating a lot online. The people that I work with regularly are going to be your different engineering groups, your different math groups, chemists, biologists, geologists, people like that. Okay, so a lot of scientists and stuff like that. But if you caught at the beginning of my presentation, I have a literature degree. Okay, just randomly, I have a literature degree. So I'm working with the English department regularly, and actually, I'm helping hiring in the English department because I'm a trained literary specialist. My background is in fairy tales, which sounds weird, but story time at my house is freaking intense. I'm telling you, I've got Russian, German, Mexican, Brazilian fairy tale background, really strong. And so it makes for really interesting story time. Fairy tales are kind of messed up stories already. And so I also work with kind of your social sciences, and we kind of bridge that gap, because if you look at our space shuttle, it's developed out of science fiction stories from the 1800s, right? So different things, and now you see Star Trek type stuff coming to life in the new SpaceX work. I mean, you're seeing this come alive. So so I kind of work across the board here, and that's kind of my advantage in dynamical systems. Is I'm multifaceted. So I could be working in chemical engineering today, but go into neuroscience tomorrow, you know? And I have that advantage and I have that ability. So I work with some of the greatest minds in town, and I really enjoy it.
Awesome. So that's pretty much it for all the questions today. Thank you so much, Dr. Nate, for coming to speak to our students. It was a pleasure listening to your talk, and I'm sure we all learned a lot. Thank you so much again to Dr. Nate. I hope you have a great rest of your day.
Excellent. Thank you. If you guys have had college algebra, you can come and take intro to engineering and engineering graphics with me over the summer. All right. All right. Bye.
Bye.
Electronic engineering. I did that bachelor in Venezuela. That's the country that I born. Okay. Then I went to study and did an specialization in instrument and control in the Netherlands, in Europe. You know, I've been in the oil and gas field for more than 29 years. I have worked in Venezuela, in United States, in Houston, that is now in Gulf of Mexico, and Alaska, and Angola, and Mexico. Okay, just to show a little bit graphically where I've been living. You know, I start to live over here, moved to US and work on Houston and Alaska. I also work on Africa, where it is Angola, and also on Mexico. Okay, so those are the points that I've been, and also I live a little bit in Europe over here in Netherlands when I was studying, doing my specializations as an instrument and control engineer. Okay, let's talk a little bit about what we put the acronym ICA engineer. What we do, you know, an instrument engineering, it is designed, you know, where we use the measurements to control process variables. You know, the main focus on measurement, and it is flow, level, temperature, and pressure. Okay, Control system engineers, what we do, we take those measures and we use control theories, to design, to control those processes. So now a controls and instrument engineer, emerge both of those responsibilities, and we design, developing, installing, managing, maintaining equipment, that monitor and control those engineering systems, machineries or process. Mainly on the oil and gas industry, we manage processes, that's on the theory. So we're gonna be talking a little bit graphically during the presentation on this one. What it is a control system, probably you hear about what is DCS and what is PLC. I'm gonna explain that in another slides, a little bit detailed what those acronyms don't mean. But if you check those pictures, you see, this is the more modern control system where the operator can visualize whatever is happening on the field. Okay, instrument. The instrument is what the equipment that we use to collect all of the data from the field. Okay, and we have to design, because that depends on the flow rate or the pressure rate or the levels that we need to measure. So you need to specify, as an engineer, you need to specify those instruments. So it's an important part of the instrument and control engineer. Something that it also we control, it is the motors. That's important thing on the industrial side. And we have this big motor control center we call MCCs. Where we can send signals to start, stop, or control speed on a motors. Okay. And a little bit on the design portion, how we started it. We started it. I showed you this one. I'm gonna magnify a little bit this, on the design and the engineering portion of instrument and control and automation engineer. Okay, you still see my screen, isn't it?
Yes.
Yes. Okay. Yes, because I lost the green stuff that I was around. Okay. Let me get a pointer over here. Okay. This is what we call a PNID. This is a piping and instrument design drawing. Okay. So in this case, we have a vessel, and you can see these bubbles. People call us the engineering that put bubbles on a drawing. That's a joke. Because every instrument that we're going to be putting on our processes, it has a symbol. So we started with a bubble like this. This is an LT, okay, that is a level transmitter, and it goes to this symbol that is another bubble with a square that it is a control system. So this signal from a level, that is a measure over here, we converted it to an electrical signal that we put it into a control system that is going to do a controls mechanism to control the level. I didn't put the valve over here to put the valve to control the level on these devices. On this case, this one is to control pressure, but I just want to emphasize that that's what we do. When we started to design a plan, we started to put those instruments on there to measure the variables, okay? And we decide, okay, we're gonna use or a PLC or a DCS that I showed you earlier, okay, to do those controls to manipulate those valves over here, or motors, or other equipment, and that's the intention of the beginning of the design of the instrument and controls engineers. Okay, what it is a DCS? You see, DCS is the distribute control system. We call distribute because you have a huge plant, so you put IOs close to the process, and then you bring all of those data, the flow, temperatures, levels, and pressures, and other information, like if you put a gas chromatograph, or you put a O2 analyzer, and you bring all of that data to the control system that we call DCS, the distributed control system, and we can display all of that information in multiple screens. We can trend it, we can do whatever we want with that data. So we give it that opportunity to give it all of that data to the operator to, do their functions to keep that plant running and safe. during this process, we also bring alarms. Alarms is a really good portion of the instrument and controls engineers. We call that as a barrier because it's how we can handle a little bit the safety of our plant. Okay, and what it is a PLC? That was the other acronym that I showed you at the beginning. And a PLC is a programmable logic controller. What is that? Programmable logic controller is like a industrial computer, let's call it like that, so that we can do programming on there. So we can do, we take those, let me show you the pictures. That's how they look. This is a brand, this is Allen Bradley. So we have power supply, we have the processor, okay? And we will have different IOs. You can have this, for example, this is an Ethernet connection, so we can connect this PLC to another computers, and we have multiple type of IOs, okay? How this one works, how the programmable logic controller works. You see, you have different inputs. That's what I told you it can be measured or digital inputs, okay? We bring those input to the processors, the central processing unit. So we do our software control over here, and we generate an output, that it is start, stop a motor, or open or close a valve, or give it an alarm, or give it a sound, to the operator to know what's happening on our plant. Okay, and also, as an instrument and control engineer, we do plan commissioning and startup. Right now, I'm working on a big project that is Argos. I'm gonna show you later those pictures, and we are right now in the part of the project that we're doing that commissioning, and we're getting ready to start up that platform in early December. Okay, on that, what we do, we test every single signal. It's a multidisciplinary, it's a multiple team working on this. So you test every single input. We check all of the control strategies that we design are working perfect, and the outputs, the controls that control a valve or closing a valve or start stop a motor work. So that's a really methodically procedures that we use for to commissioning that plan. And then after we commissioning 100% of that plan, we said, okay, we are ready to start up. So we start every single system to put that platform in production, okay? Also, instrument and controls engineer do a little bit reliability and maintenance. As soon as you put an equipment on there, you need to know how reliable is that equipment and how we can maintain that equipment, maintenance strategies in order to have this equipment available to the operator for use. When you have a pump that, move liquid from one vessel to another vessel, you need to have those equipment reliable and available for the operator to use. So we have to create those maintenance strategies. And also, as a part of an instrument and control engineer, we call the safety system. The safety system is one of the critical portion of a plan, because this is like a separate system, that is only watching when those variables go off the design, and this system is just right there to prevent any big issue, like a release of a product, because high pressure or a high temperature or a low flow. This equipment is just right there to monitor those variables that we control with the control system, in order to bring the system to bring the plan to a safety state. Okay, that's the function of the safety system. So that is part also what an instrument and control engineer does. It's really, really important. I like that part because we work with a really high-end technology, using multiple processors, to control those or to keep those variables monitoring and the action that we need to take to bring the plan to a safety state. Okay, all of this, I put the hashtag fun because it's not just design or control system, it's also a little bit fun. I put over there a picture. This is one of the platform on the Gulf of Mexico. This is Thunderhurst. Okay, And you, in order to get over there, this is like a small island on the middle of the Gulf of Mexico. You have to travel on a helicopter. Okay, for me that is really fun. So, and this is me, you know, getting it ready with my lifeguard and my safety belts on there on the helicopter. So let me show you a video on how this platform look from the air. Okay. See how massive it is? A lot of stuff on there. Okay. So on this case, I want to show you a little bit. You see the platform that I've been working on the last 9 years. Okay, this one is Thunderhorse, the one that I just showed you on the video. Okay, this is a night view. It's a huge, this is like a probably a 6-story building high, you know, that platform. And Argos is the new platform that the project that we are working right now. This is on production. Thunderhorse is already on production. So this platform has, you know, the on generator has 5 turbo generators, okay? And they have the control system. They have, you know, the production area. They have a lot of big equipment over here that we as an instrument and controls engineer, we do all of the control strategies to operate those, okay? And this is the new one. Oh, can you see my mouse or the pointer? I don't know the pointer again. Okay, and this is Argo. This is the new platform. This platform was just built in Korea. This picture on the top is Korea, okay, where this platform was built, okay. And this is the moment when the boat took it and bring it from. You see how big are these projects from Korea? You see my pointer over here? They sail all the way from the South Africa over here and get it into the Atlantic Ocean, and it's just right here, right now in Texas. You see how far we built it? We built it remotely with a contractor over there, and we bring it over here. So let me show you this video. Okay. The platform arriving to the Gulf of Mexico. Okay. As you can see, I just gonna go back to this one, and as you can see how big are these, the magnitude of the project that we handle over here in the Gulf of Mexico. So and this graphic, I just want to show the different styles of platform. You know, the one that I was showing that been working is deep water. So those are semi-sub, and you can see this is a graphic showing how they are floating structures on there, and we anchor it to the seabed, and we have the drill centers over here, and we have drill centers remotely. So we can connect all of this one on the subsea bed and bring, this is how we produce the oil and gas and bring it to the surface. We process it, and then we send it to the shore. And this is the other, this is FPUs, you know, like a boat style. And this is other type of platform. And this one are platform that are on the shallow waters that you see they already have a tower that is anchored to the seabed, okay? So, but the one that I've been involved most of my time, it is this type on the deep water, okay? I just want to share a little bit, you know, a tip for subsets, you know, that is having worked for me and I think it's a good help for you guys that are facing college, and soon they're going to be on a career. You know, you need to know yourself. What is your passion on? You know, when you're going to go to college, you need to know what you like, because this is going to be your career. You're going to be working for this one for years and years and years. So I think you need to love it. That's really important. When I said on your development, you know, your development, nobody's going to honor it for you. You focus on that. That's the reason. So if you need to take some subject, you take it, you know, because that probably helped you for your future. You know, you have to honor it. It's yours. It's for you. Okay, and also that I always said, give it back, you know, help others. And that it is, for me, is that the purpose of my life, help others. So like I'm doing right now, you know, I like to go and share my experience with others at the high school or also at the college level. I'm part of some associations, you know, that I go college and you know, we interact with the students on there. So keep in mind those 3 tips. So for your future success, okay? Let's talk a little bit about career planning. Probably you already have a lot of counseling on that one, but I'm gonna bring those and then you can ask questions, you know. As I said, your strengths, you know what if you are creativity, if you have leadership, if you like to write or you like to design, just think about those. Look for your interest, you know, if you're interested in math or science, probably most of you are, if you are in the engineering school, you know, or people. So know those interests and look for your needs, you know, is also, I always call the incomes and that kind of stuff is secondary, but you need to think about those. So you identify what career it is on the possibilities for you, and then you look for information on those type of occupational outlook summaries, you know, you're networking like we are doing right now. You know, you're going to be looking for internships when you are in college, you know, or volunteering jobs. Okay, you can search with the technology right now. Not when I went to school, I didn't have all of these resources, you know, that you can, you know, what an engineer does, you know, a little bit through videos, to descriptions over the internet. So you evaluate all of that information and you will select it in your career. So because it's going to be for long term. So now I'm open for questions.
Yeah, so if
clarifications.
I've gotten a couple of questions, but if anyone else has any other questions, please send them directly to me in the chat so I can address them. So one of the questions was, does your job involve a lot of teamwork? Do you have to work with a lot of other people?
Yes. When we work as an instrument and control engineer, you have to work with other teams, you know, like a process engineer, because they know the process, you know, and you work with the electrical engineer because you're going to be interactive with motor. You know, we as a controls engineer, we work on the signals and on the computer areas, okay? And you work with the other disciplines, you know, mechanical engineers, process engineer, and electrical engineers, you know, in order to build whatever I show you at the beginning, you know, the design of those vessels, how we're going to control it, has mechanical portion, have electrical portion, and have process portion. So you work as a team. This is a team effort. I couldn't hear you.
Can you hear me?
I can hear you now.
Okay. Yeah. So the next question is, do you need to know any coding languages to become an instrument and controls engineer?
Yes, I will encourage the student that would like to pursue to be an instrument and control engineer to get some code language, because it's the basic, you know, of the instrument and control. Every time that you're going to do programming on a PLC, you need to know how to program those PLCs. So when you go through college, you're going to learn some different languages on coding. So that will help you to, you know, develop that skill for your future work. Okay, even for DCS or PLCs, or even the MCCs, you know, the motor control centers right now are more intelligent. So you have to do programming on those. And also robotic is getting really closed right now for to the instrument and controls engineers. So I encourage you, if you go to college, in any of the discipline that you take, if you take mechanical engineer, process engineer, or chemical engineering, or electrical engineering, you know, I will encourage you guys to take some subject in the computer science area. It's really, really important.
Yeah, thank you for that tip. Another question was, how much of college do you use in your actual job?
Okay, the college is gonna give you that thinking criteria. You know, you're gonna be when you go through college, you're gonna be, if you love math, you know, that's the place that you need to be in engineering. Okay, because you're gonna be looking at a lot of engineering, chemistry, physics, you know, during the courses. Okay, and that is gonna create your mindset up, you know, to solve problem, because engineer, what we does mainly is to solve problem, you know, and that it is what college helped you to do that. Okay, probably if you it depend where you're gonna be working, to be honest. If you get it into the engineering field to be a scientific, probably you will be using a lot of more of the knowledge that you learn in college, you know, those math model, you know, the physics surrounded those math models and that kind of stuff. When you get into the work in the industry, you're gonna apply some of the concept, but you're gonna be just more designing whatever we need for that plan. So those equipment that they are more scientific, those engineers that took that route, you know, design those equipment, and we apply those equipment to the field, you know, to the processes. But you will use some of your knowledge acquired in college, but the main one is to solve problems.
The next question is, have you seen your career develop from since you started to now, like in terms of different things you do, different things you started to do?
Oh yes, it's as I show you just the last two big projects that I worked. Those are projects that last, you know, Argos has been as a project for 8 years. Okay, it is a long project. I just joined a year ago, but yes, I did. You know, I started it as a field engineer. I went to different positions. You know, I went to work in Alaska, for example, as instrument and control technical authority over there. That gave me the opportunity to coach, you know, different teams out there, you know, in my area. Right now I'm the instrument and control lead for this project, you know, and you will have those experience to be a leader in any position that you get. Okay, as a field engineer, you can lead as a field engineer, or you can lead, you know, on a big project like this.
The last question we'll have for today is, when did you realize that you wanted to pursue this career in instrumental engineering?
Okay, when I was young, like you guys, getting ready for college, you know, I was looking, you know, on that technology. You know, we're talking 30 years ago when we didn't have even computers like we have right now. Okay, but I realized that I would like to be on that field. That's how I started it, just to study electronic engineering. And during my early college days, you know, they brought the subject of control, so the control theory, and I get engaged with that, and I start to take those subjects to become a controls engineer. Or the degree is a electronic engineer, but with a mention in controls. So it's how I get into this one. And after you graduate, so you get into the industry that you're going to be working. I've been working all of this year in oil and gas. Okay, and I get passionate in all of those big projects that the oil and gas does. And remember that it's always being right now is oil and gas project, but we are turning into more renewable energy. So those probably the big project that's going to be on the future, you know, on the renewable portion of the energy. So, but I like, that's how I got engaged into this one, because I like the technology.
Okay, thank you, Mr. Ledezma, for your time and giving your presentation, a very insightful presentation on your career.
I hope it helped and you get motivated to go through the engineering schools, you know, when you get in college.
Thank you, Mr. Ledezma, for your time.
Okay, I hope that helped, and enjoy your weekend, guys. And
Yes, thank you.
okay, bye-bye.
Okay, so our next speaker is Mr. Lopez, who is an environmental engineer, a certified project manager, and the president of the Latin Heritage Network at Arcadis. That is the world's leading company delivering sustainable design, engineering, and consultancy solutions for natural and built assets. Mr. Lopez, you can continue with your presentation.
Good morning, everyone. How are you? Please let me know that you're awake and you are alive. I'm also Ruben's dad, your buddy, Ruben Lopez. He's my son. And I'm glad to present today to you guys. And this will, I guess, will be my last presentation because, as you know, Ruben is graduating, and I don't know how many seniors do we have this morning, but it's been an interesting and a fun journey for Ruben and for all of us. Can you see my screen? Can everyone see my screen?
Yes, sir.
Yes, sir.
Yes, okay. All right. So this is me. This is Ruben, and I was born and raised in Argentina, South America. Came to the US in 1993, and I got my bachelor's in civil engineering and master in environmental engineering in FIU in Miami, Florida International University. Since 2005, I'm working with my company, Arcadis, that I'm gonna tell you a little bit about this morning. And I was hired out of the Boca Raton, Florida office, which is in South Florida as well, as you know. And then in 2012, we moved to Houston. I transferred within my company to Houston. For the past 6 months, I'm the president of what we call Employee Affinity Group, which is the Latin Heritage Network. And I was elected the president for that, which I'm doing for the past 6 months, as I said. And that's my LinkedIn link. The username is Rudalo. Please connect with me anytime. Please send me messages, any questions that you have about anything, you can please feel free to contact me through LinkedIn. So Arcadis, I don't know how many of you have heard of my company, but we are a global company, headquarters in the Netherlands. It's a Dutch company. And our symbol is the fire salamander. I don't know how many of you are familiar with the fire salamander, but fire salamander is equally at home on land and in water. It requires a clean habitat and represents lasting quality and ecological balance. And that's the reason we chose this as our logo, our symbol, because Arcadis' purpose is improving the quality of life for everyone and adapting to different environments. Probably some of you know or may not know that the name Arcadis is derived from Arcadia, which according to Greek mythology is the finest place on earth to live. As again, it creates a balance between the environment where people can live, work, and thrive. All right, so as I said before, our purpose is improving quality of life. And we have a few values. People first, we care for each other and create a safe and respectful working environment where our people can grow, perform, and succeed. As you can see, this is number one. This is very, very important too for us. Client success, of course, we are a consulting firm. We work for different clients and we're passionate about our client success, knowing them well and knowing what they need, right? So we can provide solutions to them. And we value the power of the diversity in our global capabilities and deliver excellence by working as one Arcadis. Integrity, we always work to the highest professional ethical standard, very professional firm. And sustainability, we base our action for clients, communities on environmental responsibility and social and economic advancement. Our behaviors, we value each other, we deliver our promises, we always bring our best, we work as one team, and we dare to shape the future. And for you to have a perspective of our company, we have almost 28,000 employees worldwide. And as you can see, most people are in Europe and North America. We are kind of number 2 in the world. And then United Kingdom, Asia, Latin America, Calisol RTKL is all over the place also. They are our architecture firm that is part of Arcadis, and they were in Australia and Middle East. So it's a global company, literally global company, and you, when you graduate someday, you know, you can literally work in any of these locations. It's a lot of fun. And for us working in North America, we collaborate with everyone around the world, which is pretty cool. In the US, we have projects everywhere, all 50 states, but we have physical office location in the states shown here in orange. In Alaska, as you can see, Canada, Puerto Rico, and Hawaii, of course, Texas, and you know, we almost cover every single state with physical offices. And our headquarters here in the US is located in Denver, Colorado. I like to make this very, very informal. So I know we have a question and answer time at the end, but if you have a question, please don't hesitate. I don't know if we have the raise the hand option in Zoom, but just let me know if you have any question. Just unmute yourself and ask me any questions as we go along the way, okay? Our business. So you're wondering, what do these people do? Okay, so our solutions are delivered cross-sector, but you can, you know, be found in like 3 or 4 what we call business lines. The infrastructure business line, where we is all about building and rail and urban transportation, port solutions. So for civil engineers, structural engineers, definitely something that is going to be right under your alley. And then water business line is about water management solutions. It's all about the cycle of water from the beginning, from you know, from when you start treating the water to wastewater management, to intelligent water networks, all the way to, you know, digital solutions. And then we have buildings here, cost management, program management, and then of course environmental restoration and environmental remediation and strategic environmental consulting, which is here. And I'm part of this business line right here because I'm an environmental engineer, right? All right, so water solutions, as I said before, focuses on the entire water cycle from source to tap and then back to nature. Through our wealth of experience in the water section, you know, we have engineers, scientists, consultants, and as I said before, it covers the entire water cycle. Arcadis is a global top 5 player in water services. Environment solutions, and as I said before, our goal is to improve quality of life, so improving the sustainability, natural and built assets, and we combine environmental innovation, engineering, consulting, construction services. So if you are planning to be an environmental engineer or a geologist or a scientist, we even have industrial engineers, you know, you name it. The field is very broad. And then we have the building and infrastructure solutions for, as I said before, civil and structural engineers, mechanical engineers, and other kind of engineering as well as other scientists, IT degrees, and you name it. And here I provided this slide for you guys, and this is going to be available to you after. But where your major may best fit into our organization, okay? So we also have corporate roles, right, for business administration major. But this is going to give you an idea of whatever degree you plan on obtaining in the future, where you may fall, under infrastructure and transportation, environment, water, So it's very broad. So as you can see, we have petroleum engineering, public health, biology, chemical engineering, civil engineering, construction management, you name it. Okay, so this slide right here will give you an idea where you may fall, all right, within our company. So what is environmental engineering? Does anyone know? Are you guys awake? Does anyone know what environmental engineering is about? Any volunteers?
Anyone can unmute.
Everyone's sleeping. Yeah, anyone can unmute themselves and say it. There is the answer to my question. It's basically the application of engineering knowledge and concepts to care for and restore our natural environment and our solve environmental problems. As you know, everyone, all the large companies and the smaller companies too, they have environmental issues. And what happens when you have environmental issues? The government, the EPA, the Texas environmental, the TCEQ here, but in most states it's called the Department of Environmental Protection. They will find those companies, right? So we are there to help them restore the environment that was impacted. All right, and who does it affect? Everyone and everything, right? Humans, insects, plants, global warming is one, big one. Ecosystems, our planet, all. And what are the environmental issues? Three main areas, right? Air quality, because the large companies, production companies, such as petroleum companies, they produce a lot of when they manufacture their products, they send a lot of contaminants to the air, right? So that's number one. And then land quality, of course, and water quality. When something is, our source of water is the groundwater, right? So when these contaminants trickle down to the groundwater, we have a problem. Or the rivers, right? The surface water. Air quality. Why is this such a problem? Poor quality, as you know, can lead to smog, respiratory and other illnesses. Global warming is a big one. Acid rain, and there are specific regulations for air quality that companies need to follow. So we are there to help them comply with those regulations. From where do air pollutants come? Sound familiar? We see this in Texas a lot, right? A lot of manufacturing company. We have air pollutions in many countries and all around. And it could be nitrogen. These are the main air pollutants: nitrogen oxide, sulfur oxide, carbon monoxide, carbon dioxide. And just to show you a picture, some of the effects of the acid rain on plants, for example. And this is just a tiny example of the issues we face. Greenhouse gases and global warming, most probably you guys are very familiar with that. Then how we can reduce air pollutants, here are the environmental engineers will come here, and mechanical engineers, right? We will design a way to reduce air pollutants. And there are ways that, using carpools, biking, walking, using public transportation will also help reduce the air pollutants. Land quality, I'm not going to go over details over all of these, but you guys can review it. But basically, we also have issues on land quality, and we have the renewable versus the non-renewable resources, right? The non-renewable resources, as you know, once you use it, that's it. But the more green energy, the more green technologies you can reuse at all times. Okay, so the big question, you guys are on your way to becoming an engineer, right? How much money will you make? Is money everything in life? No, right? Probably not, but it helps a lot. If you obtain a bachelor degree from college, university, you will start making around 60 to 80K. I did get a master's degree. You're probably gonna start a little higher. And of course, if you go for a PhD, which you should do, you guys are in the Elkins GT Academy, so Engineering Academy. So you can do that. If you can graduate from the Engineering Academy, you can go all the way to PhD. And the sky is the limit. It's waiting for you. I just added some pictures of some cool projects that we are part of. This is from the North Sea. It's a wind field actually on the sea, because they don't have much land there in Europe. And then we have, we designed Arcadis had designed and implemented New Orleans flood protection after Katrina. This is a cool, very cool wetland project in South Florida. And this is a remediation project I was involved with since I first joined Arcadis. Basically, this is the underground. This is a model of the underground, and what you can see here, what is depicted here is the benzene concentration, the contamination that happened in the groundwater. This right here were underground storage tanks that had leaked into the groundwater. All right, so this is December 4, 2003. After we did the remediation, look, this is 2008, and then 2011, we cleaned it up. Everything is clean. All of this network of sticks that you see, these are all groundwater monitoring wells that you see. And this was a cool project that I was part of. Scientists discover the world that exists, but we engineers create the world that never was. All right, so this was my presentation, and I'm open. It's 10:18. I'm open for questions and discussions, comments.
So I received a couple of questions. If anyone else has any questions, please send those questions directly to me in the chat. So the first question is, has your company ever came in conflict with any other companies regarding environmental regulations?
All the time. So remember, we work on behalf of our clients, right? And in some cases, we do have 2 clients that are neighbors, or 2 clients that have a same issue. And there's a conflict because we work for this company A and we work for company B. So what we do for every single project that we work on, no matter the client, we do what it called is a conflict of interest check. And we make sure there is no conflict of interest for any of our projects. But issues happen all the time, and they're fun to deal with as well, because you always find a solution. Good question.
The next question is, what is the most challenging part of your job?
The most challenging part of my job has been this past year, living with COVID like everyone else. So I love doing field work as an engineer. You have engineers that only love being in the office, and you have engineers who love the field. I'm one that, who love being out there in the outdoors, in the field. And the most challenging is sometimes, believe it or not, has to do with the integrity of your colleagues and workers. You need to set the tone from the beginning. Now I'm a senior person and I'm in a management role, and you need to set the tone that we live by our values, and our number one value is health and safety. We want everyone to be safe, and the way you came in the morning, go back at night, back to your family, and we want you to succeed as a person. And if could be the case that some people don't understand that, then that's it's a problem. That's it.
The next question is, the classes that you took in college to become an engineer, were they difficult?
As you know, you guys need to be ready for all your calculus, Calc 1, Calc 2, Calc 3, and differential equations. At least in my time, those were the classes that I had to take. And I believe right now is similar. Yeah, so the classes that I found most difficult were the math classes, and also the part that had to do with structural engineering. But it's up to each person, right? For example, Ruben, my son, he loves the part of civil and structural engineering. He did great in the engineering academy with those classes, and I'm like, wow, And I like more the chemical engineering part, like the environmental. Environmental engineering has a lot of chemistry. That's the part I like. So depending on your like, yes, you're always going to find some classes that you may not use at all in the future for your career, such as all the math, physics. And I know most of you, and this is like worldwide, and this is everyone. Most people don't like chemistry, and you have to live with it. I mean, you have to take it and pass it, and be successful. Don't even worry about that.
The next question is, when you mentioned field work, what did you mean by it? Could you expand on that concept?
Oh yes, field work. Very good question. So in your mind, right, when you think about an engineer, what do you have in mind? Do you think of someone being in an office with a nice desk, a nice screen, nice computer, and that may be the case, 50% of the case, but engineers, we create, we design, right? And what do you do after you create and design in the office using formulas and software and all of that? You need to test it, right? So we do what we call pilot testing, and pilot testing is out there in the field. That's what I mean by field work, when you actually have to get out of the office and go out. For example, civil engineers and construction management people, they do work in the field as well, because they have to be building stuff, buildings, right? So they need to go and inspect the buildings, and that's field work. And then after we pilot tested, we actually go and implement the design, right? We have to build it. Pilot testing, design, building, hiring a contractor to build it for us. And then after that is what we call operation and maintenance. You have to run it. Like, just think about a refinery, right? Somebody in the office designed the huge refinery, and then someone had to build it, and then someone had to run it. Whoever are actually doing the actual work out there, those are the field engineers, field people.
The last question we have for today is there a lot of innovation involved in your job?
Yes, and right now that's a very hot topic, because we're going right now through a digital transformation, and we have a new strategy. where for everything that we do, we're trying to find a digital aspect, a digital solution to it. So for all the topics that I covered today, environmental remediation, environmental health and safety, building, rail, transportation, traffic engineering, for everything right now, there is a innovation, which is the digital transformation, and also the sustainability part of it. So we want to design sustainable solutions, so these solutions can last forever.
And that concludes our presentation for Mr. Lopez.
Thank you so
much, Lopez, for coming out and giving us this presentation. Personally, for me, it was very insightful.
Thank you so much.
Since I'm interested.
Thank you. Have a great day, and let me know if you have any questions. Just send a message to me. Okay. Bye-bye.
So today we have with us Mr. Srini. He's a technical management consultant with subject matter expertise in cloud migration readiness, assessment, strategy, planning, digital transformation, TCO analysis, consulting, design, architect, developmental ops, automation, and security are some examples of the things he deals with. Throughout his career with IBM and most recently HCL, he was proven to be an expert in providing organizations and clients with innovative, game-changing solutions to digital transformation and real-world business challenges. Please go ahead, Mr. Srini.
Hello, good morning. How are you guys?
Doing well.
So I wanted to share my experience, and I know you all we are planning on going for engineering, and I'm sure some of you wanted to be in the computer science and computer engineering. So what I'm going to focus is focus on how the cloud computing and digital transformation, and how is that going to help in your career path and choosing your career path in any of the technology trends currently happening. So I just wanted to want to share my screen. Okay, this basically about me. I'm currently working as a principal cloud architect for Technonet. That's my own company, and I do consulting for AWS, Second Watch, and many others. And I'm a certified AWS solution architect and Google certified solution architect professional. And I also DevOps professional architect also. So let's talk about digital transformation. Is any of you aware it? Anyone want to raise your hand? Okay, I will focus on the today's agenda. I want to go about what is a digital transformation, and also first understand what is a business disruption and which companies and business is prone for disruptions, and key domains cause for business disruption, and also latest technology trends to learn and focus, and what is a cloud computing. And then I go just briefly about a cloud computing. I'm very sure you guys are already using some of the cloud services in form of Gmail, Dropbox, and many other things. You already using them. So let's go on to the digital transformation. So it's basically about focusing on what with the current technology trends happening, with the digital technology trends, and it is how it is going to result in fundamental changes, the way businesses are operating, the way business are delivering with the with the changes to their customers, giving them better experience and better product line, and how they helping out. You guys very sure all of you You see, the way, we used to use the taxis in olden days. Now Uber, you coming with, much more sophisticated way of reaching out and get the, like a service done quickly. So internet has helped us in many ways. And that's what is we are taking with, taking benefit of all these technology trends. I'll focus on what are the key things, what are the trends. And right now, the focus will be, just, want to bring, how is this happening? What is the cultural change that requires, companies continuously, constantly has to focus on and learning, how their current business going to be impacted with the, with the technology trends. And also they have to, they have to improve, their existing product line or come up with a new product line. So this what is, like every business, is prone to business disruption. So that's what they have to, as a senior management or, as a management team, they have to avoid those and get their, delivery pipeline and make their business, scaled up. So let's focus on, understand what is a business disruption. It's about, you guys, very sure, you all using iPads and also even, I don't know whether you are two young kids, I don't think you used any musical players like, tape record or anything in the olden days. Now, like you see that, the trend has changed with the smartphones, whether it is iPhone or Android devices. So you see there is a trend, people shifting onto the this kind of technologies, which changed a lot of features, and also many ways it helped it helps with the additional functionality, and also low end disruption. I'm sure you all must have used the Sony PlayStation, Xbox. Now roadblocks they have come up with, and also there are many other gaming technologies. There is a change with this less cost involved, and you're getting the same kind of experience, even in a much better way. So that's about low end areas where you're getting a benefit. And you see that like a third is new market disruption. This is what I'm talking about. Like a taxis. Now you have like a Uber. You can just schedule your time, or when you look for Uber, you can get the service done quickly as possible, and also with with a clean and clean vehicles, and also professional service from people. And last one, value chain disruption. This is about like you guys anytime like use timeshare or things in that. So in olden days, people have to book it and do it. And now we have many companies offering that kind of services. Even social media is providing a lot more benefits. Like Craigslist, you can advertise, and you can get new way of olden days we used to go through the papers. And that's where, what are the, advertisement, whether it is a car, you want to buy it, you look for it. Now you don't have to. So that has helped, for us, for us as a consumer, but it killed the, it killed the market for the all newspapers. Now who is getting newspaper daily and reading it? So it's everything, So one way consumer is getting we are taking a benefits out of this kind of a revolution in technology. At same time, companies not adapting to this technology trends, they're losing their business. And some companies are losing partially, some companies are, getting bankrupted also. So I want to show you the, some of the trends, so there's every business, even Amazon itself. So Jeff Bezos, he mentioned here, even Amazon can go, go out of business. So that's what is. Every company is prone to it. And it is, if they don't follow the trends, they don't change according to the new technological revolution. So any company is prone to it. So I just want to tell you, how many of you remember, telecom companies, MCA, WorldCom, Lucent? I'm sure you are young kids, you only use, used a mobile. I'm pretty sure, some may have seen the landline still, but it's nobody is using. So these are the telecom giants we're talking about, MCA, WorldCom. 10 years, 15 years ago, all these companies are out of business. They've got bankrupted. And also you look at, like a recent, 5 years ago, we all have Nokia, Motorola, or BlackBerry kind of phones, and iPhone and all these smartphones came in. They killed the entire, like a mobile device market. And you also take a look at, your, handwritten, have you gone to post office anytime, to mail a handwritten letter to somebody, or friend or family or anything? I'm very sure, we haven't done for a while, maybe we use for sending some packet, but not really, handwritten. And also what's happening to, retail mall concept. So the way we used to buy from going to a mall and do things, are we doing it? No, we are just going to, Amazon or, some other website. We're buying it e-commerce online business. So, and also that list goes on, you look at, your automobile industry, there is a huge change. It's continuously being, being challenged. All this, they, from 100 years, this change is, constantly they're being challenged. Now is Tesla is coming with electric vehicles. So that's killing the entire market. And you look at, some segments of business, financial business like PayPal, the way, you exchange money between two people. Now with the PayPal and Square, even a Bitcoin, all these, technologies, they're taking away some of the services from business banks. So this list can go on, if you speak, I can come out with, hundreds of things, which has been, gone out of business, or, some new technology came in and, led us forward doing, doing a different way of business. So next slide, I wanted to, what has happened, is that, something has changed? Yeah, definitely there is always a change. The change is, I categorized into the 5 categories. Data. And we're getting, all kind of a data right now. If you have a mobile device, you can go to your mobile device, look for, where is the traffic when you're driving, and see, like based on traffic, you can change it. And social media is making us, and also even the business, they can advertise, and we can get, a lot of updates real time and see it. These are happening. And innovation, you look at, the way companies are coming up with a new innovative ways. Smartphone, it's helping us, like a lot of things. It took away, our old phone. I don't know how many of you use the, alarm clock, music players, watches, navigation systems. They all been replaced with the one smartphone. And also you see that innovation is, like you all use the Facebook, the kind of features they keep on testing. It's a real time. They make changes to it, and it's been, asked, they send you a request, yeah, this is the feature been added, you want to test it. So they're getting the real time test done by it. All these are happening real time. These innovative changes helping. And third way, it is, the disruption is happening because companies, all these companies, Amazon, Google, or even Apple, they're all competing with each other. They're coming with, like latest technologies, with the automated machine, automated cars and everything. they're going to cause, they're competing each other. But at the end, we as a consumer getting a benefit of it with a price and better discount and better product line. So all this is happening. One of them is taking, like all of this product win, or somebody is getting out of business because of the competition. So that's what is, it's constantly being seen. And also you see, like another thing is the customer, we all look for a value. So the way, you have to look for call a taxi, and they have to, they receive your call and then, they have to come to your door. Probably would have taken, minutes of time, like a 10 to 30 minutes of time. Now you have a smartphone, you just go into the app and, looking for a Uber, they're just coming it to you. And so that's what we're seeing, yeah, it is, you see the value proposition, you're getting served right away. So that's what is, another trend we're observing. And also, like as we all, I know that, sometimes even now, I personally gone to the Best Buy to do a sample to see a product, and then I did not buy it, right at there. But after coming home and, I ordered from Amazon. There are many people, do this. And it is, because we become less loyal to it, less loyal to our service providers, whether it is a mobile service or, where you used to go to in a specific store and buy things, we become less loyal. So these are the 5 factors which is impacting, and they, as a companies, they have to address these problems and how they can help us, like to do the business with them. So that's what, these are the trends I observed. And other things I want to talk about, what is coming in technology, what is changing. So I'm sure that, you guys hear a lot about the cloud computing. That's what is taking, every company is moving on to the cloud. Even let's say you run a small application, you want it to be on the cloud because of the various reasons, cost and elasticity, and also, scalability. All these factors you wanted to do a cloud. And now we have big data. Why is big data? You see that, like in olden days, if we use the spreadsheet, we can hardly have 10 lines, 10 rows of data. Now everything we do, the way we interacting with the mobile, the way we are interacting with the internet, you yourself don't know how much of data you're generating out of your phone. By going through various applications, what all things you are doing, how much data you're generating it. You probably don't know that, but you don't know, you're using Google, and they're watching you every moment, what all things you are doing it. When you are on Facebook or anything, you can see that, you did, some kind of a search, they automatically showing a products, what you searched it. You're looking for some kind of a vehicle, they're showing some of the vehicles. Or you're looking for a phone, they show, in the ad session, all this. How is they doing it? Because you are generating a lot of data. All these companies, they're capturing all that data, they're using that for their analytical, reasonings, how they wanted to give, experience for the customer. Is that ethical? Is that right? Legal? No, there is a regulation going on with that. So, they can't, how much of personal information they can capture and do things. So that is a different battle. I don't want to go into that conversation. And also, let's talk about artificial intelligence and machine learning. Why is it important? Right now, we already seeing some kind of a trends happening. So let's say, all these automated vehicles are coming. How is that going to help? What is that it is taking information and how it is, able to do, like a automated, driving like as a human we do. So when we are on road, it knows that it has a sensors, it has a information to find if any object comes, whether it is a human, it is coming on way, or is that bird, or is that like some kind of a bicycle or anything. How is that? It's all about there is three things artificial intelligence, machine learning focus on. One is about the data. We have to feed lot of data to identify, to sense it. What it is seeing is like is a human, it is a bird, it is that. And also there is for all this it required a lot of processing. That is what is they focus on. And also another thing, algorithms. We need to have a different way of writing based on that data. How do you identify and doing it? So right now artificial intelligence, we don't have a general AI. What it is shown in some of the movies, they can sense it, touch it, feel our emotions like love and sadness. That's not happening in reality. What's right now, it may happen in future, but what's happening now, all these objects, sensors, and what you can, your voice transmission and audio transmission, video transmissions, and a lot of this sensing machines, those are all happening right now. So that's what is all about artificial intelligence and machine learning. And next is the Internet of Things. I'm sure you are sitting in home. There are many of your devices are not connected to a internet, or not connected to a network, but they're called bots. Whether it is your microwave, or it is your ADP machine, ADP sensors. All these are there are many things in manufacturing industry, and every industry there are a lot of things. So all that is connected some way to help to capture some kind of a data and to provide some kind of a services. So that's what is happening. That's the Internet of Things. And additive manufacturing. This is about we know Nike shoes. You're getting like a Nike shoe. There is a prototype made, and using based on that prototype. Now they're coming with additive manufacturing. So it is you don't have to have any kind of a investment as such, and you can have your layout and everything. You can present it. Then later you can go into the production. 3D printing. How many of you are aware of 3D printing? It's going to come in soon. Still in there is already there. We're getting all these printers right now, and we can get the 3D image printing. So they're all coming. That's a trend which is coming. And also cybersecurity. All our as a personal user, we are on the internet. We are exposed to many things. Internet is one way it is helping. One way it is making all these hackers much more smarter, and they're coming and causing all kind of disruptions. So that's about it. And also last one I want to focus is the blockchain. What is a blockchain? It's not a Bitcoin. Blockchain and Bitcoin is two different. Blockchain is a technology we're talking about. Is that it's like helping to make two parties to do some kind of a ledger process. So that is that's about the blockchain technologies. So there is all this this is a revolution changes happening, and we all should aware of it. And also businesses in particular, they have to see how does one of them or all of them going to cause some kind of a major disruption in their business pipeline, business model, and their operation, how it's going to impact them. So they have to, that's what is the top management has to focus on and prepare for, to avoid that kind of a disruption. So that's a broad about, about the digital technologies. It's what is coming in, what is happening in the trends. And I wanted to give just a cloud, cloud itself is an example. what is the cloud? We all, you all using cloud. You all using cloud, you using Gmail. Gmail is running a Gmail application. Dropbox, you're using a cloud service. Netflix, you're using a cloud service only. So you taking already some of the benefits. It's about, what it talks about is it's a basically internet-based computing whereby shared resources, software, and information are provided to computer and devices on demand basis. So you get the on demand basis. You can scale up, scale down, whether memory or your storage needs and your network capabilities and whatnot. So that's about the cloud computing all about. So I'll just give you in technology terms what is the cloud computing. It's a model for enabling convenient on-demand network access to a shared pool of configurable computing resources, network, servers, storage, application, and services that can be rapidly provisioned and released with a minimal management effort or service. So it means, you can get, let's say I want to run a business, burger business. I want to market locally. So I'm going to develop some application. I already serving my customers in shop. I want to serve more. What if I do some application, and put it on cloud based on demand requirements? It's an ice cream shop, not a burger shop. Let's say ice cream shop. I'm making ice cream. I can ship it to anywhere in the US. So if that kind of a business, I have it. And it's that, I want to give it to everybody. I designed a web application. And now I wanted to give it for a mobile, where you can go to iPhone or, Android, you can download and use it, all my customers, they can use it. So that's what is, so that's about, if I wanted to maintain that application, I need to have a developers, I need to have admins, and I need to have a lot of capabilities in-house. But I'm a one-time, I've designed the application with the help of, somebody who is, software developer. I have the application, I host it on Amazon, and it is up and running. Now I gave the mobile application, I gave the download option, you all can download it and use it. And in order to do my business, I need to have all your contacts. So for that, I needed something like a CRM application to maintain contacts and everything. So I will use, some application, which is a customer service relation application. I can get it on Apple downloads itself, or I can have, if I'm an enterprise customer, I can use, something like a ServiceNow CRM Salesforce application. So those and all, my options. So that means, I can have my model in a different ways. I can design whole thing by taking my Amazon, and from there I choose my servers, I choose my development code, and I have my developers write it, and also they deploy it, and they make it available for all for you all as a SaaS application, software as application, just like how Dropbox is. And another way of is I don't have to maintain all these computers and everything. I just want only, they give me machines. All I have to do is I develop my application and take that application and keep it in a platform as a service model. So I get, I get same functionality done. I don't have to maintain all of those computers. And let's say no, I don't want to use, I want to use something like, it's application, I have it. I just wanted to use, somebody who has done common business of handling, how ice cream shop run their business. So it's all that ordering and everything is already there. I can download it and use it. And even my customer, I can make that available for my customers. They can use it, and they can make the calls requested. So that is a SaaS model. Yeah. So that way, that is another way of already this ordering system. Now Uber Eater is that application already available for many of them. Is doing is like we can make a request, they come and serve it. So they interact with both for us with the business providers who is making all this like a burgers or ice creams or even in some of the shops they're doing the service. So we can use that application. It's how you're maintaining is that different service models. So that's what is all about the SaaS, PaaS, and IaaS. And last one, I wanted to speak about what is the public cloud, private cloud, community cloud, and hybrid cloud. So it's about like a high private cloud is just like Amazon. We don't have to they manage everything, and they give us systems, and whatever we keep it in their system, their servers is what we have to manage. And what is a community cloud? It's like maybe some of the people, common entities, they wanted to maintain their own cloud and use it for their members and things like that. That's a community cloud. Public cloud is sorry, I'm wrong. Public cloud is what is Amazon. Private cloud is it's a business specific. Some company they wanted to have for their own internal, and it's not to host anybody outside people, outside businesses. That's about private cloud. Public cloud is like Amazon. And hybrid cloud is, it's a mixed bag of clouds. You have your company, servers and data centers, along with, some cloud, some application is in AWS, some of them is in Azure, Google Cloud. So all this is, spread across various data centers. So that's about the hybrid cloud model. And so this is broadly, categorizing, like some business applications, it brings more value. Let's say like you have artificial intelligence. If you go with the Google Cloud, they have better options, better services. And with that, you can develop your application much more better ways. So that's the reason people are adopting with the hybrid cloud. Some AWS, some running in own data center, some spread across various clouds. So that's basically about this. And who are the top cloud providers? Amazon is the number one, and Azure, Microsoft Azure, Google Cloud, and IBM Bluemix. So these are the various cloud providers. So it's a very specific window. I don't know how much I can get out of it because of the time constraint. I made I wanted you to get what is the understanding about the digital trends, what is the digital business disruptions, how any company can prone to trends, technology trends, how they can cause a impact to their business, and what they have to focus on it. As a student, what is the areas you should focus on? What are the technologies you should focus on, and mastering those technologies? That way, it helps in your career. So these are some of the technologies. It's one or all, nobody can be expert in everything, but you can choose one of the areas once you come to a specialization. So that's basically I wanted to cover. And any questions you have, yeah, you can raise those.
Thank you, Mr. Srini, for your presentation. I really appreciated the detail and how you explained every single aspect of your presentation. It was very informative. Thank you, Mr. Freeman.
Thank you, everyone.
So on to the next speaker for today. We have Mr. Ashok joining us. He is an electrical engineer working for a manufacturing company providing products and solutions for the oil and gas industry. He's responsible for sales and marketing of products and services to the greater Houston region. So everyone, please give Mr. Ashok a warm welcome and he can start sharing.
Yeah, hopefully this works this time. All right.
We can see your screen.
You can see, great. Okay. So is everyone in? I think, it was like a work day for me. This is what happens every day at work. We try to get people on a call and, everyone's not able to get in. IT has been tough and working from home has been tougher. So that said, shall I start now? Are we good?
Yes, you can begin.
Okay, great. So good morning, everyone. Thanks for spending your Saturday morning with me on this call. My name is Naveen Ashok. I'm the regional sales manager for an electrical manufacturing company by the name of Stahl. So we're into electrical instrumentation and we're specialized in explosion detection. So as we go along, I'll explain to you what all these things are. So when you look at the oil and gas industry, I guess you've seen a lot of issues. You've seen fires, disasters, lots of things happening. So us as an electrical manufacturer, what we're trying to do is keep everything safe, keep people, assets, all these things safe during normal operation, because the oil and gas industry is a dangerous field, right? So during this presentation, what I'm trying to show you guys will be the oil and gas industry from a product manufacturer's point of view, because we are a product manufacturer, and then the electrical and instrumentation manufacturing specific to this industry. So Bisam, that's what I was trying to explain to you earlier in the breakout room. So each industry will have specific requirements. So even though you're under the broad term of electrical engineering, you need to specialize in something that makes you suitable for that industry. And that's what I will come to. That's the next point. So my specialization, or my company's specialization, is hazardous area explosion protection. So maybe this is something you guys have heard of, not heard of. Anybody heard of this before? Hazardous areas explosion protection? Nobody? Okay. So I'll go a little bit into that, because for me as an electrical engineer like yourself, when I came across it the first time, it was something that was, I've never heard of this. Nobody taught me this in school. What is it? But that is what I'm specialized in right now. So this is maybe 10, 15 years ago when I first came across this. And from then I've been learning more about it. And that's kind of what my specialty is right now. And then we'll go over a few typical electrical entry-level careers that are available, for example, at a manufacturing company. So my company, for example, would have some electrical roles, and I'm trying to explain what those careers would be like, what kind of people would fit in those careers. So this is what my whole presentation is going to be about. So I guess everyone drew a blank when I said hazardous area. So what is a hazardous area, right? So when you're looking at the oil and gas industry, one thing you cannot get away from is hazardous gases or dust. So if it's an LNG plant, it's a petrochemical plant, any of these things. So that's an oil rig. So there's going to be oil coming out of that pipe, for example. You've got a well and you've got oil coming out of it. So there's going to be possibly a spill. There's going to be some gases around. So you cannot avoid the gases, right? You're talking about a refinery. So you're bringing in crude oil, you're converting that to different byproducts. So again, there's a lot of chemical reactions going on. So you'll have gases in the air. Or you're looking at a pharma plant. So where you've got, again, a lot of chemicals, you're blending chemicals. So what happens over there? So for example, let's talk about the kitchen in your house, for example. You have a lot of light fixtures, you have switches, right? nothing is blowing up. But suppose you leave your gas on for 5 minutes. What happens? You have a hazardous mixture of air and gas in the air, right? In your atmosphere, because you have a closed room, you have a gas in the air. And now if you go on and put your switch on and there's a small spark, what happens? You blow up the house, right? So now think of this plant over here. So over there, you have a gas present all the time, almost, because you have a process running. So there's a gas present all the time. So what do? But you have to put the switch on because you want to put your light on, you want to put your motor on, whatever it is, right? So what we do as a company is we manufacture products. So be it lights, be it switches, anything that does not blow up the plant in simple terms, right? So that's what we do. We design products that prevent explosions. So that is explosion protection. And this is hazardous areas. And this is a big field, especially if you plan to get into the oil and gas industry. Okay, so this is very basic. So I'm just trying to tell you what an explosion is, the fire triangle, because this is the core of our issue. So you have a process, you have 3 sides. So these are the 3 sides that you need for a fire, right? One is fuel. So the fuel is always there because, like I said, a dust, a gas, something which is part of the process, it's always there, right? Then you have oxygen, which is, again, you can't avoid oxygen because you need it. So the only third side is the ignition source. And that is the third side that we're trying to control in our design, right? So if you take one side of this triangle away, there's no fire. So that is basically the basics of explosion protection. And then so this is getting a bit deep, but I just want to show you an overall view of this. So we have divided the hazardous areas into different zones depending on the risk. And so, for example, on the right, you have the American version. On the left, you have the international version. So depending on how much time the gas is present in the area, we've defined the risk. So there's a zone 0, and there's a zone 1 and a zone 2. So the zone 0 is the highest risk. The zone 1 is still high, and the zone 2 is low risk. So based on this classification, we design products that fit in these areas. So that's the base of what we do as a company. So just to give you a little brief about the company I work for, it's called Stahl. We're a German manufacturer. We've been in the business for over 150 years now. And like it says here, what we do is safety technology for hazardous areas like chemical plants, oil and gas, pharma. So that is our industry. So we're playing in the oil and gas industry. So what safety technology, right? So preventing explosions, keeping everything safe while everything is still operating. That is safety technology. It is a part of electrical because, to get your electrical products, which are safe to be used in the oil and gas industry, this is what we have to do. And that's our global footprint. So we have subsidiaries around the world. So this is the Houston office where I am at right now. It is in Stafford, which is basically 10 minutes down the road. And if anyone's interested, you guys can come by one day. I can show you the shop and what we do there. It's not huge. It's like 100 people. I have some pictures of the factory as we go along. I can show you that as well. And I also worked for a while in the Middle East. So this office over here, I worked there for about 5 years before I transferred over to Houston in 2015. And so finally, we're looking at products, right? So we manufacture products, and everything you see here is something that you can put in the kitchen with the gas on, right? So you have a light, you have alarms, you have switching, power distribution, we have HMIs, camera systems. So this is a basic broad portfolio of the products that we manufacture. All good so far?
Yes.
Great. And you probably have seen some of these companies. I think some of the people from these companies are probably presenting to you also. So these are our customers globally, and we work with a lot of these companies. Some of them are engineering companies, some of them are actual end users. So when you look at the oil and gas market, right, it's divided into various segments, and top down you have the owners, so which are companies like BP, Total, Exxon. So these are the owners. They own the plants, they own the oil rig. And then you have companies like Technip, Bechtel, Fluor, who are the engineering companies. So they actually build the plants for these people. So if you're the owner and you're an Exxon, the Bechtel guy is your house contractor. So he's the one who's building the house for you. And then there are people like Emerson, Linde, who are also making smaller parts of the plant for you. If you're the end user, you're the owner of the house or the plant. And there are people like us who make the actual products. So it could be your refrigerator, it could be your light switch. So that's where we fit in the big scheme of things. So if you're looking at it from a plant point of view, so if you visualize a chemical plant or a petrochemical plant, any of these big refineries you see when you drive down, maybe in the ship channel, for example, this is where all our products fit in the plant. So you have power coming in, you're all looking for, I guess, an electrical point of view, right? So you have power coming in from your transformer and you're stepping it down to medium voltage, then you're stepping it down to low voltage. So this is the low voltage side. So on the low voltage, you have the main power distribution panel. Then you bring it down to local power distribution. Then you have your junction boxes, your motor starters, your lights. And that's what you're trying to feed in the plants in the end of the day. So that's where our products fit in at a plant level. So just to give you, where all these things come together. Then we go on. I guess I only have 15 minutes, right? I don't know how far am I. I'm already 20 minutes. So, so this is what it relates to you guys. So in a company like mine, where we are manufacturing, what kind of roles could a student get at entry level, right? So you're an electrical engineer, you're fresh out of college, you're looking for jobs. So this is the kind of job that you could get fresh out of college. So it's a sales engineer job. So kind of what I started when I was early in my field, right? So I'm out of college. I did some work with the power industry, and then I moved. So I was working in Dubai, and before that I was working in India. So when I moved to Dubai, the first job I got was as a sales engineer. So I have an engineering background. I had to learn about the product, what I was trying to sell, and I'm talking to fellow engineers like myself. So when I'm trying to sell the product that my company makes or represents, and you want to explain what the product does, features and benefits, you want to know deep technical stuff about it. Only then can you talk to your other fellow engineers who are on the other side of the table who need your product. So that is, I know there's a lot of engineering jobs out there, but this is something also that you guys can look at. And what are the, looking at, for example, what is the profile of a sales engineer? I mean, you want people who are more social, you are more proactive, outgoing kind of people. They probably fit in this role more. So, and again, there's a lot of perks. So you can travel a lot, like you see. I was living in Dubai, I was traveling a lot locally. And then now I moved over to Houston because the company needed someone like with my profile. So there's a lot of traveling. And then I've been to Germany a couple of times. I've been on training to Singapore, Spain, all kinds of places. So it's a fun job if you like traveling, you like meeting new people. And again, I guess if you sell a lot, you get a lot of commission. So money is obviously what everybody's in this for, right? So in this job, if you meet your targets, if you do better than your targets, you get a lot of money. That's another side benefit. And your growth prospects are pretty good. So that is one job career path that I could show you guys. Then the other one also, which would be a entry-level kind of job, would be a production engineer. So this is the shop. This is my shop right here in Stafford. And so we are building things especially for customers. So a customer specifies that he wants something which needs to look like this. So the engineer is from a drawing, he's making it into a product. So then he has to call out what size enclosure it needs to be, how many lights it needs to be on it. So he does all that work. So that is another job that you guys could get into fresh out of college. It's an electrical production engineer. And that's what the job, there's a job description. I'm not reading it out. So for this job, you want to be more meticulous. You want to be very detail oriented. I don't think I'm that guy. I can't sit long enough to really do this job. So maybe I fit the other profile. So I wasn't a guy who was going to sit in front of the computer all day. So I mean, again, nothing against it. It's just everyone's mental makeup and what you guys like doing, right? But you want to be a very technically oriented person, and you want to be a team player. So this panel board you see over here is something that we manufacture. So you see it's pretty intense. There's a lot of work going behind it. And then if you like sitting in one place, it's an office-based job, you have good prospects. And you use, I mean, for example, everything you learn in college, you're actually using it in real life, which is good. So that's another career option. So I think with that, I'm out of time, right? Almost. So I'll leave it open to questions. I hope you guys liked it and you learn more about, I mean, at least I open your eyes to some things. And if you have more questions, let me know.
Thank you for your presentation. We'll move on to questions now. Everyone, if you have any questions, please send them in the chat. I've already received a couple of questions. So, okay, we can start with the first question. What other career fields do you work with, like engineers from other career fields?
I didn't get that. What other career fields?
So engineers from other career fields do you work with?
What other engineers?
Like civil engineering, things like that.
Like, so I do work with some mechanical people, instrumentation people a lot, automation. And then when I get into, with some companies, you also have to deal with the project engineer. So that's a different kind of engineer, I guess, who are trying to run the plant and all that. So those are the typical kinds of engineers I deal with.
The next question is, what kind of classes did you take in college to become an engineer?
What kind of classes? So I learned, I mean, so I studied in India. So I guess it's a little different from what you guys do here. But, and honestly, it's been so long, I don't remember really. But yeah, I'll have to look that up. Honestly, I don't remember anymore. Maybe it's even outdated now. You know, what I studied back in the day, maybe it doesn't even exist anymore. But, you know, but electricity, I think, hasn't really changed that much. But that's a tough one for me. It's been too long, I don't remember really.
So the next question is, do you also have to work outside office hours for bigger projects?
Well, it depends. I mean, with this role, you get a lot of freedom. So I'm traveling a bit, so I'm out meeting customers. So when you're out all day, when you come back, and you have some important emails and stuff like that, you still need to do it. And so it depends, but it evens out. Sometimes you may have, you know, half a day, you're free. You don't have meetings, so you can chill a little bit. You can run errands, you can buy milk on the way home or something, you know, so it all evens out. So I think sometimes, yes, sometimes when the workload is very high, you may have to stay late. Again, you can do this from home nowadays. So I don't really carry work home that much, but yes, I mean, I would say 10%.
The next question is, after learning this job experience, what are some growth opportunities?
So for me, so I was a sales engineer, then I became an account manager, then I became a regional manager. So, I mean, this role is, you have a lot of growth opportunities. So next you can be maybe a sales director, then you can be maybe a VP of sales, you can be a CEO. So I think salespeople are quite, you see a lot of growth in the sales field. In my field of work. So in manufacturing, it's typically the salespeople that grow to become your CEOs, general managers, people like that. So I think there's a lot of growth prospects in this.
The last question we have for today is, do you have any difficulties communicating with other people on your job, as you have to be in touch with many people?
Right, not as much. Yeah, so I do come across a lot of people from different other countries, other cultures. So you have to be, I guess, accommodating. And some people, obviously, English isn't their native tongue. And so, for example, right now I'm dealing with a company, and there's a gentleman who's a customer of mine who came in from Japan. So for him, it's a bit difficult. So, you have to give him the time, and you have to kind of think through what he told you, and maybe you need to ask him once or twice. So I've seen that issues with a lot of people, that especially when they come in from other places. So I guess you have to be human about it, and try and be adjusting. And same thing with, maybe people don't understand my accent sometimes. So no one's perfect. So everyone has to be able to give and take a little bit, and kind of give that extra room for people. And that's in any field, I guess.
That concludes our question and answer session. Thank you, Mr. Ashok, for coming out and talking to us about your field of engineering. I'm sure all the students like me learned a lot from your presentation.
All right. Thank you, kids. Thanks a lot.
Thank you, Mr. Ashok. Yeah.
You're welcome. Have a good weekend, guys.
Yes.
Thank you.
So welcome everyone to the link B. Our next speaker is Ms. Garza. She is part of the University of Houston Society of Women Engineers. So everyone, please give Ms. Garza a warm welcome.
Hi all, thanks for having me. Yeah, so I'm from the Society of Women Engineers at the University of Houston, and I actually brought a couple more people from there with me today. I'm gonna go ahead and share my screen. Okay. Let me know if y'all can see this.
Yes, we can see it.
Okay, perfect. So I'm gonna go through this presentation real quick, talk about like what SWE is, right? Society of Women Engineers, I'm gonna refer to as SWE throughout this presentation, and like why you should potentially join when you go to college. And then at the end, we can have like a little panel with the people I brought, because we're all like engineering students in college, and I know y'all are thinking of like possibly doing engineering when you're in college. And I think it'd be nice if y'all ask us questions about either SWE or UH or just engineering in general. So I'm gonna go ahead and start, and then I guess the people that are here with me can introduce themselves once we start the Q&A. Because I think I do see Natalie though. Hi, Natalie. Anna too. Okay, cool. All right, so I'm gonna start off about SWE. All right, so what is SWE? Well, we're the Society of Women Engineers, so it's an organization about empowering women in engineering or tech-related fields. And you don't have to be a woman to join. It's about empowering women, not about being a woman, right? There's a difference. Here I have our mission statement. It's to empower women to achieve full potential in careers as engineers and leaders, expand the image of the engineering and technology professions as a positive force in improving the quality of life, and demonstrate the value of diversity and inclusion. So that tells us a lot about SWE by itself, because it shares our goals with you, such like the vision, a world with gender parity and equality in engineering and technology. Now, why should you join SWE? Okay, well, there's a ton of reasons. Okay, so I'll go over quite a few here. One of the main reasons is networking. SWE, especially at UH, we have a lot of networking opportunities. We do like a lot of resume critiques and mock interviews with companies. And we always have companies sponsor our general meetings, and they come and talk at them. A lot of things like that. It's really good because you get to already meet a lot of company reps. So you make the connections already. You get their like email and stuff, ask them questions. But at the same time, you're like practicing talking with a company rep. So then when you go to career fairs or like interviews for internships and such, you're already comfortable, because one of the main parts of like getting like a job eventually is being comfortable talking with a recruiter. So that's really important, really good for professional development. Along with that, right, a lot of industry exposure, because we do have a lot of companies come out to our meetings. We have a lot of outreach events. We do community outreach like gardening, food banks, etc. But we also do a lot of outreach with K through 12, right? Like we're visiting you here at this high school career fair type thing. We do a lot of other work like that. Actually, Anna here is our outreach chair, so that says a lot. Collaborate with fellow engineers. We have a lot of socials and also study nights. So you get to meet other engineers that are like in your classes, but maybe you're not in your classes with them. They're like in a different section. Y'all can help each other out with homework or just like socialize. It's really nice because sometimes in some classes, maybe you don't see everybody, you know, so SWE, you see everybody outside of it, even people who aren't in your major. You develop your leadership and management skills. This is really good because I've developed a lot just through SWE. I'm the president, by the way. I think I forgot to mention that. I'm Caroline. I'm the president of SWE at UH. We have a really good mentorship program as well. I had a really good mentor when I was a freshman. We pair up like mentor mentee, usually in your same major, and they help you out with like all types of things like building a resume, elevator speeches, all kinds of things like that. It's a really strong program. It's really nice. And the annual society conferences are really cool as well. Every year there's a big SWE conference somewhere in the US. I've been a couple. I've been to the one in Minneapolis. That was really nice but cold. Been to the one in California, Anaheim. That was a really fun year. This past year was online. It was still a good time, you know. We're online right now, but hopefully this coming year it'll be in Indianapolis, so that's pretty cool. Never been there. Scholarships, this is another big reason to join SWE. There's a lot of scholarships. As you can see, in 2018 SWE dispersed about 238 new and renewed scholarships valued at more than $830,000. That's so much money. That's SWE like kind of nationally. By the way, that's not SWE UH. We also give thousands of dollars in scholarships, but not like 800,000, right? I myself have gotten quite a few scholarships from SWE. So however much you put into SWE, you usually get back. It's a really nice organization in that way. And of course, you get a supportive SWEster family. I love my SWEsters. We're so close and they really are my family. To help portray all that I've just said, we have a quick video to help, you know, give you the image of SWE. Let me know if you can hear the sound.
SWE in general, like the UH chapter at least, it's one of the most giving and charitable organizations I've ever been involved in. Support is immense, and you really just never have to ask for anything. SWE just gives. I mean, at least the people in SWE. I'm very grateful to be a part of that.
My experience has just been absolutely amazing. I've been able to meet other people who aren't in my major, who I would have never really known because I never take classes or see them beyond what I normally do in class. But through SWE, I've been able to make these great friends, and on top of that, because I was so involved with SWE early on in my SWE career, I was able to get multiple scholarships, and that has been huge. And I actually tallied up the amount of scholarships that I got, and I've gotten over $10,000. Giving to SWE is a really, really great investment because you really are going to get back what you put into it.
I got a lot of networking, definitely a lot of networking, and a lot more friendships too. Most of the SWE members I got to meet, meet my friends, and hang out in events other than just SWE. And SWE really has a lot of connections.
I've really created confidence within the way that I speak to professionals. I've really become close-knitted with some of the members. Being a first-generation college student and also being a woman, it's just really intimidating going into an engineering field. And so the mentor program is really helpful to be able to talk to someone who's already been through your classes, who's already faced the adversity. And I think that was just a great opportunity, which made me love SWE even more.
My freshman year of SWE, we had mentorship assignments, and I'm still in touch with my mentor. She's really helped me just grow professionally and helped me out when I'm trying to interview or whenever I'm going to a career fair. Outside of that, the SWE community in general has just been a great support network if you're looking for jobs or internships, whether that's in the University of Houston or if it's outside nationally.
Personally, I attended a lot of awesome people throughout the department, and some of them have become really close friends of mine. And obviously, you know, professional development and
helps so much in your growth and development, both personally and professionally. It's really hard to express how much it has helped me in the past 3 years in my undergrad.
My favorite thing about SWE is definitely the community. We just have a large network of individuals looking to help each other. In the University of Houston, we have really close friends and people to study with whether it's for your next test or people to practice interviewing with if you're looking for a new job when you graduate.
Everything that SWE does is just amazing. You can tell people put their heart and soul into helping others.
SWE members are very supportive and genuine. It's a really good resource to have while you're balancing work, school, and personal life. They're the people that you're going to be remembering about whenever you're looking back in your college days.
I think my favorite thing about SWE is our outreach. I think we do a lot of community service, and I love helping the community. I also really enjoy our mentor program.
One of the things I enjoy most about SWE is that we're just open to any member to just come in. I like how you don't have to be just a girl to come in. Guys are welcome to join too, and they really support women in engineering. Also, I love the women empowerment and the energy that SWE provides at all of the events and the general meetings, and how everybody is just looking to get involved and trying to take advantage of SWE, and SWE has a lot to offer us.
I would say my favorite thing about SWE has to be the outreach and the volunteering. I know it's a little cheesy, but it's seriously so close to my heart because I didn't know I wanted to be an engineer until I was a senior in high school, like very close to graduating, and the only reason I knew I wanted to go into engineering was because somebody introduced it to me. For me to now be able to come and do that for somebody else, it's a huge impact because I know that if somebody wasn't there to show me, I wouldn't be where I am now. So I want to be able to do that for others going forward.
Inspiring.
Fun. Friendship.
Community.
Supportive.
Community.
Inspirational.
Fun.
Possibility.
Amazing. Opportunistic.
Empowering. Family. For me, it's home. It's really a place that everybody comes, to Houston from all over the country, all over the world, really, and you can really find your comfort zone in SWE. You can find people who are nowhere near like you, people who are very much like you, and that's kind of like your family in a way, but you really feel comfortable in SWE. You feel like you can learn, you can grow, and you can be yourself, and that's really an amazing thing about it.
All right, so thank you for watching that. I hope the sound was good throughout that. I'm not really here to talk about like the different membership types, but the reason I have the slide is if y'all, like, when you go to college, you're interested in like different orgs, like maybe you've heard of like SHEP or NSBE, the National Society of Black Engineers, or the Society of Hispanic Professional Engineers, or even ACES, the American Indian Science and Engineering Society. We actually have like joint membership dues with those. So like when you go to college, don't think you only have to join like one organization. You can actually be part of multiple. So that's there to remind you of that. And right, so we're SWE from U of H, but you can go to SWE like anywhere. As you can see, there are currently over 400 sections in the US. That's a ton of sections of SWE. Oh my gosh, that's both professional and collegiate. So really, if you go to any college that has like an engineering program, you're very likely to find a SWE chapter there, a SWE section. My bad, they're not chapters. We're even internationally as well, as there's over 60 international SWE sections, and here's the map of all the SWE sections in the world. So that's really nice to see because I love SWE. Yeah, and let's say you have a couple more years of high school left. You're not like you're not graduating. There's actually a SWE for like high school age. It's called SWE Next. It's for anyone up to the age of 18. And it's free. It's really nice. It's an online program. They have a bunch of things there. They have like scholarship tips, how to apply for college, like thinking about what kind of engineer you want to be. Also, they send you emails whenever there's like STEM events or activities in your area. Like I know UH, we have a couple of outreach events and other organizations do, and they send you emails when those are around your area so you can attend them. It's really nice. Also, some of them end up going to the conference. I've seen them there when we've gone, so that's really nice. There's a QR code for that website, and it's also that link down there, swenext.swe.org. Apparently y'all have like a whole engineering thing at your school, so y'all could also look into that on the side if you want to look for like activities out in your area. It's pretty nice. Before we just start the Q&A, I'm going to introduce the people who are with me because we have a lot of different engineering majors here. Just going to talk about some quick tips for success in engineering. If y'all are really looking, y'all are graduating right now. I'm not sure how many, like, say in the chat, like, are you all seniors, juniors? Where are you? Get a good consensus. While y'all are doing that, I'll tell you, engineering is more about hard work than natural intelligence. Junior, senior, junior, senior, junior. Okay, all around that age. Sophomore, freshman. Wow, look at y'all coming out here. Oh, good job to y'all. Yeah, definitely look into SweNext then. Yeah, so it's really about that grit. And while GPA is important, it is more important to be well-rounded. Similar to, I'm pretty sure they tell you this in high school as well. It's not just about that 4.0, it's about doing other things. So joining something like SWE really helps you because it has so many different aspects to it. You get the volunteering, you know, the professional development, everything else, the leadership. It's good to find a good study support group and support system, right? That's really important. SWE was that for me. But if y'all don't join SWE in college, definitely find one anyway. Once again, SWE has that. We have study nights and such, so that's really good. Start developing soft skills and good study habits early. That's really important because then the classes just keep getting harder. You know what I'm saying? And it's good to start those habits early so then you already have kind of a plan already set in motion. There's this engineering complex that everyone in the room understands what is going on except me. I don't think that's true, right? We're all in school for a reason, right? We're all here to learn. So it's not like everybody shows up already knowing everything engineering. We're in these classes for a reason. And most important, practice self-care. Although education is the most important, of course, even more important than that is your own physical and mental well-being. So make sure to look out for that you know, while you are in school. It's very important, especially now that we're like in unprecedented times. So here's all our handles and stuff if you want to look into SWE UH graduating, you know, looking into going to the University of Houston. Definitely suggest already looking into it. Leave that there. And this will take us straight to our Q&A panel. So like I said, my name's Carolina Garza. I'm the president of SWE UH currently. I'm actually, right, because we're both like, we're kind of all STEM. I'm data science is kind of my major. I started off as industrial engineering, if y'all have questions about that, but I'm graduating with math and data science. I have a minor in computer science. So I'm like kind of in that tech zone, a lot of statistics too. So, but I have quite a few others. If y'all want to go ahead and introduce yourselves, so y'all can ask us questions on SWE, UH, or our specific majors. So.
I'll go. I can go. My name is Anna Alvarez. I'm a chemical engineering major. I'm also the outreach chair, like Carolina said. So I mostly focus on K through 12 events. I'm a chemical engineering major, but I started in biomedical engineering. So I know about both majors. So yeah, that's me.
Hi everyone, I'm Natalie and I'm a senior in civil engineering. So yeah, it's pretty cool. So if you guys have any questions about civil engineering, maybe like where do you even start? Like how do you find a job? Like do you start thinking about that? Because I was thinking about that in high school. I don't know. So if you're stressed about something, I got a bunch of advice.
So what we can do is everyone can send their questions in the chat, the main chat, or they can unmute themselves and say their questions out loud. And either one of these so that we can have an interactive discussion. So I can go first. So Ms. Garza, you said that you changed your major, right? So what influenced you to change your major?
Well, you know, not everyone starts in the right major. Anna also changed her major, but I started off as industrial engineering, and I really liked the idea of it, especially when I was like in high school, you know, thinking like between like engineering and business. That's what a lot of people say when they do industrial. I really like the efficiency of it and such. I didn't really like the classes when I was in it. And everyone was like, oh man, don't worry, nobody likes classes. Wait till you get internships. And well, I did get my internship and I still didn't like it. I actually got 2. And I was like, I should probably, I don't know, I really need to start thinking about what's going on. And the data science program opened up like that year. It's brand new at UH, and it was like everything I liked about industrial engineering. But like, yeah, it was all the parts I liked, like the efficiency, and we took like classes on VBA and stuff. So it was like kind of like that coding efficiency. It didn't have the manufacturing aspect of it, because I worked at a manufacturing plant as my internship, and I was not about it. I don't like the environment. It's very hot and sweaty, and I'm a lot better at the digital inside aspect. And I still get to talk a lot. Data science is a lot of communication, which is industrial engineering as well. So it's kind of the overview look, and I would be accomplishing the same with what I have now. So it was just finding what was good for me.
So we do have a question in the chat, a couple of questions. So the first question is, how do you get internships and what is a good place to start?
I can go ahead and start this question, but y'all can jump in if y'all want as well. Well, first, you have to apply to the internships, of course. That's how you start. Good place to start. But before that, it's good to maybe find a group like SWE or a different group like that. There's so many, right? But obviously, I think SWE is the best. There's a lot of resume critiques. Even find a mentor, someone who can like help you. You know, build a resume, do your elevator speech, practice with friends. You know, really practice, because a big part of it, like when you finally meet like that rep, like let's say you go to a career fair to find an internship, when you start talking to that rep, there's like a line, right? There's a line of people just to like one company, and like so it's kind of quick, like you feel like kind of pressured. So it's really about that practice. So when you're there, you don't like, you kind of only get like one chance when you're talking to that rep at the career fair. So you got to really kind of hone your skill of selling yourself and asking good questions so that they can like take your resume, you know, you get an email them back. But really it's about applying everywhere you like would like, doing a lot of applications, because you're not going to get everything, right? You only get called back for some of them. So apply everywhere and make sure you have like good skills. Do y'all have any other tips? Also connections. I got one of mine through one of my advisors.
Okay, so yeah, it's really about connections. Something is saying is like, it's who you know, not what you know. And that's mostly true. I mean, what you know helps, but like being involved in organizations or anything, any hobbies you have, sometimes like that is something that it's really good for your resume. So say that you work at a dog shelter and you're kind of the leader and you're doing something. Those are really important skills. Or you're working in a team at a church or anywhere else, like those are really important skills that people like to see. Just because they're not technical, maybe you don't know anything about coding, like Carolina said, a VBA, I have no idea what that is. That doesn't mean you're not a good candidate for an internship position. You'll learn. So I think another thing is just being ready, being really eager and taking the initiative to learn. Maybe like watch a couple of YouTube videos. Like when you apply for internships, you'll see qualifications. They might mention a program. Watch a YouTube video, like a few on that program, maybe see if you can get a free student version, kind of build those skills. We had an info session with SWE, which is also really awesome because you get to make connections through those info sessions and general meetings with companies. One of them mentioned like, look at the qualifications and fill in the blanks. So if you think you might be lacking some interpersonal skills, just like join SWE, go to get a mentor, kind of talk about it, talk to someone where you can kind of help develop those skills. And yeah, join the mentorship program, go to organizations when they have info sessions, networking socials, cover letters. Cover letter, just kind of like what you should do for that, like really obscure things that seem kind of really daunting at first. But once you kind of put your foot in the water, like you'll get comfortable with it. You'll feel like you're more prepared. You have more talking points. Hope that helps.
The next question is, how do you like chemical engineering? What classes in high school should I take if I'm interested in that specific field?
I guess this one's targeted towards me. I really like chemical engineering so far. Don't get me wrong, it's difficult. I mean, a lot of engineering classes are difficult. I'm not gonna lie. It's something that you realize around your freshman year is kind of like you're dipping your foot in the water, like getting into the first coding class and stuff like that. And then your sophomore year, you're going towards your like major specific classes, and you'll get a taste of how rigorous it can be, but it is manageable. It is something that you can definitely do if you have the right mindset. I like chemical engineering. I love chemistry. I'm interested in biomolecular engineering and stuff like that. So the incorporation of biology and chemistry together. You can also do biomedical engineering. I just didn't personally like how specified the career is, but that's not to like get you to venture away or like turn your head away from biomedical engineering. Do what you enjoy. What I would suggest, the classes that you would take is definitely look into your not just only like your engineering classes to know like the technical stuff before you go in. It's something to have fun with. I know I had fun in my engineering classes in high school. Chemistry, I would definitely like see if you like chemistry in that process and those processes and stuff like that, because you'll have to take a lot of chemistry, especially organic chemistry and general chemistry and even like advanced chemistry courses. Calculus, if you can take calculus in high school, I would suggest it. It would make it a lot easier once you go to college. But that's what I suggest. I hope that helps y'all.
Thank you for your response to that question. The last question we'll be taking today is, it says that I know SWE SWE focuses on engineering, but do they also include some aspects of computer science or technology? If so, what exactly?
Well, I guess I can answer this question because I'm technically not an engineering major anymore. Yeah, so we do include aspects of computer science and technology as part of the mission statement I read earlier, right? Because it's engineering or tech-related professions, you know. We have a lot of, we have quite a few members who are computer science. We have another officer who's a computer science major. I'm the president, I'm a data science major. We do have occasionally some companies do have computer science positions. I know I brought a company last year, Data Iku, they were a data science company. So that came for one of our info sessions, stuff like that. So we occasionally do have some companies, not too many, but a lot of the companies that come anyway, they do also accept computer science majors. And they've said that in the past. I know quite a few have like talked to me and said that they do like computer science and data science as well, if like, you know, people were interested. So yeah, and because we have computer science majors, some of them help each other out at like study nights and such like that. So.
I think we can.
Sorry.
Yes, go ahead. Go ahead.
So like SWE accepts all majors. We accept all majors, whether you're a biology major, stuff like that. I like everybody usually starts out in engineering, but then everybody ventures out and they find their own passion. It's a lot of soul searching whenever you're like switching your major, because you're like deciding, do I like what I'm doing, or am I just like going through the motions of it? So we accept everybody and anybody that comes in, and we're always willing to help everybody. even those big companies that are like big engineering companies that they're usually say they're looking for engineering majors, a lot of them do accept other like computer science and stuff because they also have like departments where they need computer science majors, data analysts and stuff like that. So definitely it's still good to join those organizations, even if you're like thinking, well, I'm not an engineering major, why should I be here? Well, I'm not a woman, why should I be here? We accept everybody and anybody.
So thank you for your presentation and this panel. It was a very fruitful discussion, and I'm sure all our students, including me, learned a lot. So yeah, thank you.
Yeah, I also dropped my email in the chat. If y'all have any questions, further questions about SWE or UH, if y'all are looking, go Cougs, right? Engineering in general. And I think Natalie dropped her email as well, so if y'all are interested.
Mobile phone with the profiling, and we are using a various type of technologies. We are using AI, we are using perfect mobile type of solution, which is doing the artificial intelligence for identification of objects. So that's my background. I'm developing the automation framework using a Java and C#. That is my two programming language I use. And the backend, the automation tools I use from Windrunner, then RFT, which is Rational Functional Tester, QTP, Selenium WebDriver. So currently we are using like Selenium WebDriver, the open source tool with the C#. Whereas my tool, I'm with that. I'm also using various tools like Puppet and TeamCities, Jira, all these integrations with the automation. We are storing into our database where we use that information for predicting for the future releases. So that's what I'm doing. Let me introduce to my topic. What I'm taking today is a software development. So before I start with the software development, let's first understand what is software. Software is a set of instructions or programs that tells computer or smartphone or tablet or phablet or electronic devices what to do. And software can be broadly categorized in 4 categories. One is a system software, development software, application software, and embedded software. System software is like your operating system, right? Or how your computer is interacting with your hard drive, or how your computer is interacting with your router and all the stuff. That all comes under the system software. Then development software, you are using a tools like you are using a Java IDE, or you are using Eclipse or C#, like that type of development, or your Notepad is a simple example of development software. So that type of software also develops, so that categorized under development software. Now, application software is like you are using the various applications, like you go to Amazon, you go to the Home Depot, there are applications which is for specific tasks to be performed. So that type of application software or any other apps you are using on your mobile phone, that classify under the application software. Another one is embedded software. Embedded software is a software which interact with the various electronic devices. Either it is, your car, like in a Tesla, we are controlling the car with the software. So that is one of the example of embedded software. Now, after the software, now what is the software development? Software development is a set of computer science activity dedicated to process of creating, designing, deploying, and supporting the software. Now, in general, the software development team, currently we are working in an agile world. So in agile world, these are like a few stakeholders in our software development team. One is a product owner, scrum master, software architect. Another is a developers, like software developers, UI designer, quality assurance engineer, and business analyst. Let me give you a brief introduction about each stakeholder. Like first is a product owner. Like product owner is a person who is like dealing with the business people and
talk with them, try to get what we like to develop. So he's like getting the information from the business and crafting in a form where development team can develop the software based on that. So they should be like a negotiator between the business and development team. For that type of role, you require a degree in science, engineering, or business administrations. You can do the certification like Certified Scrum Product Owner, which is on the scrum.org, you can do it. The salary range, as for the Glassdoor, it is 74,000 to 50,000 in this particular role. Next is a Scrum Master. The Scrum Master is like, is an organizer of a team. He talks with the people, get the work done. Like he is familiar with a little bit of technology, and he is coaching the people for conflict. If there is a conflict, he try to resolve it. If somebody need help, so he's the person who will become a resourceful to the team. For the Scrum Master, you require a degree in science, engineering, or business administration. You can do the certifications for that. It's a Certified Scrum Master certification. The salary range is between 70 to 140,000 per year. And it is the average. You can go above also. It depends upon the organization you're joining and the projects you are joining. Next is the software architect. The software architect is the key person who understands thoroughly the domain. The domain, when I'm saying, because when you're developing software, the software will be either for oil and gas industry, or it is for the e-commerce application, or it is a retail application, or it is a stockbroking application. So he has a domain expertise. He also has a programming expertise and a user interface, how to develop the software which is easy to the user. He also tried to resolve the problem in a unique way based on his experience. He is a good communicator who communicates with the team what they are going to develop. He actually go with the actual practical approach, with not only the theoretical approach. If there is some technology available, patterns available, he try to convert in the form that the whole team can consume it. It is a leadership position where he interact with the various stakeholders and lead the team. For the software architect, you require a science and engineering degree. You can do, there is like more than 100 certificates available. Some of the very well-known certificate you can do is AWS Certified Solution Architect, Azure Solution Architect, and the salary I have mentioned is like 81 to 170. And if you're joining a Microsoft, Google, that type Facebook's, it's about 200,000 for the architect. So another person who is in the team is a software developer. A software developer is main responsible for developing a code, writing a code. So he should write a code in such a way that it can be reusable, and that is it should not create any problem like errors or anything, and it should fulfill the client requirement. For the software developer role, you might be taking some classes of computer science in your high school, right? So you might be learning Java or other languages. So you can easily become a software developer once you do the college, or you can do the certification, like you can become a Java certified, or you can become a Microsoft certified. There are some certification I have listed here. You can participate. There are a lot, like in the software industries, for each vendor have their own certifications. So you can, whatever you like, if you like to go for Oracle, you go for Oracle certification. If you like to go for Java, go for Java certification. So that is required to get into the industry. So only the college degree is not sufficient. You need to do a certification in the software development team. The salary range is between 71 to 120K. It can go above as your experience grow. It's reached 150 to 200 when you become architect. Another person is a UI designer. UI designer is a person who is good with creativity, who is good with art, but he also know he do the research, and based on the customer experience, they design the software. So suppose you think about you're using your Fire Stick, or you're using your Netflix. So whatever the designing coming up, so there is some UI designer or UX designer who designed that software. You do that. it is become so easy for user to interact with the software. So that's the role of a UI designer. So for UI designer, you can get either a degree in management system or web designing. You can do, there is a lot of certifications available. One of the certifications I mentioned here, but there are a lot. You can search in the Google and you can get that information. The salary range is between 63 to 120K for UI designer. Another person is a quality assurance person. Quality assurance person is a person who has a domain expertise. Domain means on where you are working in that particular line. Like suppose you are working in oil and gas, suppose you are working in manufacturing. So that domain expertise plus a technical knowledge. Second thing, he also understands the development. So the person who is in a QA have to understand what are the problems the developer can make, and then find a problem and create a software which is bug-free and easy to use. The degree what's required for QA role is you can do the degree in science, engineering, or management information system. You can do a certification in CSTQB, ISTQB. There are a lot of certifications out there. Any of this you can take based on your interest. The salary range will be 48 to 88,000 per annum. And if you, there is another branch of QA, which is automation. If you go on that field, it is which currently what I am, which is in between the QA and development, because a developer do the development role and QA do the testing. So what as automation guy do is like bridge between the development and QA, so help both of them to deliver the quality software. Last not least is a business analyst. A business analyst is a person who do like a data review, statistical analysis for the software, financial planning for the software projects. The business analyst do the documentation so that like whenever you get a software, right, there is an installation instructions are there, or like release notes are there. All this will be done by the business analyst, and it always communicate with the business people and try to get them on the page what the software do and are they comfortable with software which is developed, take their feedback and pass it to the customers, and the customer is development team. So for that, for business analysts, you require a degree in science, business administration, or MIS or analyticals. The certifications are CAP and PBA. These are the common certificate used in the industries. The salary range will be between 52 to 110K. Apart from this 6 roles, there are other team also. Team members are DevOps. DevOps is like, if you search for the Google and you search for the software development job, nowadays nearly 55% jobs are for DevOps or automations, or because everybody in the development team are developer. There is no role of specific like QA or developer. DevOps they do all that thing. You can, there is a subject matter expert also there, and the person who is running the whole project, project manager, is also part of the software development team. So what you can do now when you are in the high school is like you can cultivate analytical thinking, right? You think about if you like to go to software industries, so you should do like critical thinking, how this happening, do logic building exercise, right? So suppose you are looking at some web page or application, how it was, what should be behind that. So do that thing, keep learning a new tools and technology. So if you are learning a Java, try to learn the different tools with like a C#. Because in software industry, we are never stick with one language. We work with multiple languages. Learn new patterns and frameworks, because after learning a programming language, you also need to learn the patterns and frameworks. And after learning the patterns and frameworks, you can design the frameworks. Like I'm developing my own frameworks for artificial intelligence and machine learning. Same thing, you start learning that there are a lot of videos available on Udemy or YouTube. You can go and search for it. Develop a deep understanding of OOPS and DBMS. OOPS is nothing but object-oriented programming and database management systems while you are in high school. Design and develop your model project. So if you learn the Java in your high school, try to develop a small application using your Java. then participate. I strongly recommend you to participate in conferences or workshops or present some paper, research paper and articles in the student area. So that you can do. So what is the future like from now, like next 5 to 10 years when you are going out in the market to search the job? These are the field where software development will lean to is artificial intelligence, ITOPS, which is Internet of Things, cybersecurity, blockchaining, low-code development, augmented reality, and virtual reality. These are the very, very unique field where the software development in the future will go. It is in the future, you will not write a code because, believe me, currently there are a software which is in artificial intelligence. You just say, that, hey, like, hey, Siri, create a view code for me. Siri will write the code for you. So, but these are the like unique field where you can introduce your these are some of the area. These are my contact details. You can reach me on improvingautomation@outlook.com, or this is my LinkedIn handle. If you like to learn about my framework, I can go further. Do I have time? I don't know how much time I have. Okay, a couple of minutes I have. So like, this is one of my framework, what I'm preaching, like actually is like, this is the taste automation framework where like I break the automation scripts in like data is coming from the CSV file, which is an Excel file, an XML file. And then using the configuration, it is going to the various modules. I have my own libraries, which is logging the information. There is a different classes. And then all this together, running the scripts on the browser, on the application. So this is the type of thing. So if any of you are familiar with it, like C# or Java, like a small thing, I'm just giving a thing. If this is a code, right? Like a person who's starting learning the code, they write like code this. But after the code, we break this thing and convert this code in a 4-line. So this is like how you create your own patterns and frameworks, so that can be reused again and again, no hard coding. So this is the thing you can do it. Now I'm open the question answer session. If you have any questions, you can ask me.
So yeah, we'll begin the question answer session. If you have any questions, please send them directly to me. I've received a couple questions throughout the presentation. So the first question is, how much do you learn on your job?
Every day, each day, every day. Always you be a student when you are in software development. There is no ending. Because frankly speaking, I'm working in Java from last 22 years, but still I have not completed 20% of Java. That many classes Java have. So every day, based on your requirement, you have to learn new patterns, new technology, keep learning. That's the key. I learned from my juniors also, who are like a freshman coming from the, graduated from the college. They come to us and sometimes they also come with a very new patterns or frameworks, and we love to learn from them. So every day we have to learn. But I have learned, at least you require some analytical skill, logical thinking, and degree in computer science to be in a software development.
So the next question is, what is the most rewarding part of your job?
Most rewarding part is like, I love to see my framework, my script goes to the production, it works, and there is zero complaint from the customer, and they give the good feedback. And anyways, our software industry is the highest paying industry. If you are in a software, in any engineering, it is the highest pay in the market. No other engineering can pay you more than software.
The next question is, how much of your college experiences and knowledge do you use every day in your life?
Frankly speaking, I take the college as which, make me understand the problem and make me a logical thinker. Else, like whatever the things what I learned, I learned the Java like a 2.1 and currently is a Java 5. So between that, whatever the new versions, some new classes, I keep learning that. And then I started a C#, I started the Linux, then I learned, there are a lot of software because, for automation, I am certified from all the vendors like RFT, QTP, Load Runner, Fusion, all this, and I keep learning. Every year you have to be certified, you have to learn each and every tool in the market.
Okay, that concludes our question and answer session. Thank you, Mr. Shroff, for your time. I learned new things about software engineering.
Okay, thank you, everybody. Bye.
Yes, thank you.
Right. Our first speaker today is Ms. Cotie. She is a project executive with Gilbane Building Company and has built many landmark projects in Houston. With a degree in architectural engineering from Penn State, she has used her engineering degree in a unique way, leading to being named a top 20 under 40 by Engineering News Record. Angela is the chairman of board for ACE Mentor Houston and is active in the community and her kids' activities. Everyone, please give her a warm welcome to Ms. Cotie.
Good morning, everybody. I'm excited to be here today and talk to you. I have a presentation, but for some reason it's animated, so I might have an engineering degree, but that doesn't mean we always know how to make everything work, right? Some of you guys I know because you're part of the ACE mentoring program and you have participated with that organization, which I'm excited about. And I might as well dive in. If anybody has any questions as we go, I'm more than happy to stop and y'all interrupt me. But the first thing, it is Saturday morning. And one thing that I've learned during all this COVID stuff is that it really kind of stinks, but having your camera on makes a big difference when it comes to making relationships and being professional and having your face known. So if any of you have any guts, and I don't care if your hair is standing up because it is Saturday, I didn't do mine, I'd appreciate it because it also makes the speaker and your coworkers feel a little more comfortable. There you go. I see some faces popping up when you can see other people and you know that you're talking to somebody who's actually, one, listening, and two, you can gauge the engagement of the people that you're speaking to if you can see them. It's kind of hard if you say something and you don't see any faces going, oh man, she's crazy, or oh, that's kind of interesting. So just remember that as you guys go through and you have other speakers pop up, that they appreciate when they can see all your smiling faces. I'm going to share my screen. I'm going to start here. Thank you, all the faces popping up. Thank you, thank you. I don't feel like I'm looking at myself anymore. Okay, so like I was introduced, I'm an architectural engineering. I went to Penn State and studied architectural engineering. I'm sure a lot of you guys heard of all the different kinds of engineering, and architectural engineering is probably not the top one on everybody's radar, right? Everyone thinks I'm going to be a mechanical engineer, electrical engineer, civil engineering, things like that. And when I was young, I really wanted to be an architect. I thought that that's what I wanted to do. And I loved old buildings. I loved all those types of how you could repurpose something, how I could take something and turn it into something else. And I thought, this is what I want to do. So I spent a lot of time in high school in classes that were architecture related and other drawing classes, a lot of math classes, preparing for college, thinking that's what I wanted to do. And then I started looking at schools. And when I looked at Penn State, I saw architectural engineering. So, well, this kind of is cool. It blends not just the design, but actually making it work, if that makes any sense at all. I know you guys are all engineering students, so you want things to work. You want to understand how the mechanics work, how does the systems work, all of those kind of good things. So I said, well, why don't I try it? This sounds kind of interesting. I'll dive in a little bit more into the different types of majors and opportunities I had through architectural engineering and why I ended up choosing construction management, because I'm sure you guys are like, what? She's a construction manager? Yes, I do wear a hard hat every day and boots. But now when we get to the end, I'll show you some pictures of what I'm doing now, but I'm working at the Mickey Leland International Terminal, and I'm running the the operations for all of the construction. It's a $350 million project. Very successful in this industry when sometimes people just don't think that there is a, that it matches up. So a little bit about me. We've already heard that, and I like this one because it was taken long before everyone was wearing masks. So this is me with a mask, but probably a long time ago. And if you look close, I am covered with some gold. But so that's who I am in my work get up. So I don't know why that old one is in there, but basically construction is one of the second largest industries in the United States. And I'm sure everyone hears a lot, and you guys are in engineering, so you don't hear a lot about going into trades and doing things like that. But the professional opportunities within our industry are also widening a great deal. There's a huge gap in professionals, and you guys hear that all the time, whether it's just in the construction field or all the engineering fields that lead up to making a building a building. So within the construction industry, there's a lot of different opportunities, and everyone's like, well, you know, I'm an engineering student. I don't want to hear about all that. Yeah, I thought the same thing, right? I never for one second thought that how does actual construction relate to engineering? And then I realized it's a giant puzzle, right? Every engineering student loves puzzles, whether it's a math puzzle, a challenge that you have of some sort, you get to make something, whether it's a robot, all of these cool things fit together into different pieces, and they have to be put together in the right pattern, in the right timing, the right layers, in order, one, the building doesn't fall down, two, that you protect all the materials that go in it, three, all of the moving parts that you need in order to actually keep building it, right? I can't build a roof and not have a floor because you have to be on something to do it. So, so there's a lot of different jobs, and I think you would all be somewhat surprised how many engineering roles are within all of these different opportunities. So within construction management, I work with most of the professionals that I work with now have a engineering degree of some sort that are leaders at major companies around Houston. A lot of superintendents take different paths. There's a lot of superintendents that have started in the field and worked their way up to their position, but a lot of them, they are engineers by nature, if that makes sense. You guys have met people that just always have good ideas and always see how things happen and make it work. And they are surprisingly intuitive. Now you'll see, I had a superintendent for years on a project. He was a civil engineer, and he wore jeans and boots every day. And he spent a lot of time. He was probably the best superintendent I ever worked with. He really knew what he was doing. And there's a lot of other engineers in the field that do surveying. I mean, everything has to be exact, right? I can't build a building and not have it laid out the way that it's supposed to be laid out. And every single company has those folks on their team that make sure that it's accurate. Then there's a lot of specialty contractors, people that I'm hiring in order to do things. So when everyone thinks of a building, they think of the architect, and the architect has to stamp the drawings. And then the engineers all need to stamp the drawings. I'll get to that real quick. But we also have a lot of smaller contractors that are involved that have to have an engineer on board in order to make them even allowed to do the work. If I have to have a fire protection engineer, as someone needs to sign and stamp a drawing before we're allowed to put anything in the building. And that's just one example. The mechanical engineers, there's a lot of BIM modeling. Does everyone know what that is? 3D modeling for the buildings. It's a requirement on every job now, mostly of the big projects that we work on. You have to have someone like that to do it. So again, these are all opportunities that are maybe a different path. Maybe it's just something you hadn't thought of before. And then we have safety, quality, and then there's some other opportunities that you don't always need an engineering degree for, but business development is more of a sales role. Estimating, we have an estimator. He's actually he is a civil engineer also, and he understands it's about budgeting. So I get to spend millions of dollars of other people's money every day. I have to be a good steward of their money, and I have to do it accurately, and I have to account for every cent. But that is there's a lot of money that changes hands in construction, right? You got to build the building. You have small guys that need to be paid, and then I have to get paid to pay them. So there's a lot of other pieces that are involved, as well as marketing and other opportunities there. So this would be just, when I think of the engineers on a job for a construction project, this is a easy list, right? This is a very simple list of who is involved. Everyone, there's a structural engineer, obviously. There's a mechanical engineer that designs all of the mechanical systems. That's your air conditioning, heating, ventilation. But now as you see, and we'll go through some of my project pictures, I've worked with a lot of really cool mechanical engineers that have done some things that are totally outside the box that you never would have thought of. The same thing with electrical engineers. I have plumbing engineers. There's a lot to do with sound, low voltage controls. These are big businesses, guys. These are super big businesses with lots of wide open opportunities. So if you're thinking electrical engineer, mechanical engineer, and you only think oil and gas, and you only think about cars, consider what other opportunities you can do and what you see every single day. Literally, your school had tons of engineers that made it work. And I'm sure you guys have heard that through through your teachers, and just looking around your space at your home. I'm certain that you guys see what an engineer does every day, right? But sometimes we forget, because we see the big picture and we see the engineering that is the cool engineering. But don't forget that as I go through some of the pictures, there's a lot of cool engineering that you probably never would have thought of. The other ones that I always thought was, there's huge opportunities to still invent in construction. So I don't know about you, but even being an older person now, I still love to invent. I love to be creative and something different. And in the construction industry, there's so much opportunity for innovation, whether it's where there's a lot of discussion now about robots. I'm sure you guys all hear about the news, and people worried about losing their job to animation and to automation, in robots. But there's a lot of opportunity for these two things, right? Everyone needs their hands in construction. It's going to take a long time, but we need brains like you guys to figure out how to make it safer for them, how to make it more safer for them physically. There's a lot of people out there. One company that I'm working with, TD Industries, they all have, they've been practicing using robotic arms with their technicians. So these arms, when men have to work up here, men and women, there's a lot of women out there, are up above their head, your arms get super tired. But they've invented these arms that kind of go over it and support them so they can continue to do their work and not hurt their backs and their arms. And as people do these jobs, they're aging, right? You can't have somebody who has the same amount of agility when they're 25, can't always do that same thing when they're 55 and make the same amount of money. Well, they're going to make more money as they go, but to keep doing what they really love and be passionate about, your body gets tired and people get injured, or they have to find other jobs sometimes because they're tired. It just comes down to getting older. So I originally am from Maryland, and I came to Houston because I had an opportunity to build Minute Maid Stadium. It was Enron Field at the time. And I was 22 and moved all the way from Maryland, Pennsylvania, where I went to school. And then I came down here and I got thrown on this job. And I was in our industry, when you're new to something, it's called you're green. So I was super green on this project, but I got to do some amazing stuff. Even I was in charge of all of the sound system, video boards, RF distribution, which basically is the system that when you watch the game on ESPN, there's a connection between that and the truck and the satellites, and it has to be one continuous line of wire. I was in charge of all the seats and even the foul ball pole. So it was pretty cumbersome, but I'm certain you guys can look at that and figure out all the different engineers that were involved in that. I've worked on historic renovation projects. I've worked on schools. And this is a cool one. I did the African forest exhibit at the zoo. So again, when someone thinks of civil engineering and they think of, I use this tree as an example. I had to move this tree. It was over 150 years old to another spot at the zoo. You don't just pick that sucker up and move it with a crane because that's a very, very, very expensive tree. We had an engineer come out, figure out what its weight would be, how are we going to move it, how do we pull it across this space? And it was because they not only were they an engineer, but they specialized in horticulture and plants. So there's a space for anything that you're passionate about. I know all of you guys have different dreams and different things that you would love to do, but it all can come back to engineering somehow. And that's what's really cool about where you guys are right now, because if you love inventing, if you love figuring things out, no matter what field you choose, there's always going to be an opportunity for you. So stick with it. And I know it's hard. I know that my freshman year in college, I called my mom and dad and I was crying. Yes, I'll admit it. I was crying. I said, how do I can't do this. I can't do this. And my mom's like, you can do anything you set your mind to. And because it was hard, right? I mean, we all know that when y'all go to school, what they're going to do is they try to weed you out, right? In an engineering program, they want the best and the brightest. And the way to do that is to find the kids who are partying too hard and let's scrape them off. And the kids that want to not do all of these classes, they scrape those off. The ones who don't want to go to the 8 a.m. Chemistry class, then they get rid of all of them, right? So then there'll be a core group of kids that they have not weeded out. And a lot of kids fall victim to that, right? They don't realize that's what they're doing. So beat them at their own game. That's where I was at. I said, you're not going to stop me. So I did it. I had to take chemistry twice. I was not a chemical engineer, obviously, but we all have our own journey. And I remember a guy told me one time, he said, why are you in this program? And I said, well, because that's what I want to do. I want to build buildings. And he said, okay, fine. So when I got nominated for the engineering news record for the top 20 under 40, and I was certain to put that on my LinkedIn and sent it to that professor. So I was a little ugly, but that's okay. But don't let anybody tell you you can't do it, regardless of where you're from or what you look like or anything. It doesn't matter. You all of you have a spot, and you will have a spot. If you choose to do something different, like go into construction, there's opportunities there too. So this was, I'll keep going real quick and then I'll take some questions. Does that sound good? And keep us on schedule. I worked at the Houston Zoo, like I said, but this is the chimpanzee exhibit, sorry. And if you look at even how this wall has an angle, an engineer was involved, I promise you, because they had to figure out how far an animal could jump. So if I have a tree and the chimp can only climb and swing so far, I had to make sure that a chimp couldn't get out. So there was a lot of science that went into each one of these pieces. It may look like it's just placed there, but it's actually there very strategically, and no chimp has escaped, so we're good. We did my picture didn't come through. The rhino exhibit here, the same similarity, but if you look at the rhinoceros, when we first built this exhibit, there was an enormous boulder right here. Well, the problem was that a rhino can move a boulder about 5 times its weight. And what he did is they took that, I don't know if you've ever seen this exhibit at the Houston Zoo, but there's like a trough all around this area here. Those rhinos pushed that thing right into the trough, which made a bridge for some deer-like animal that they had in there at the same time. So that thing just walked right across and jumped out. We got him back in. But when it comes to engineering, there was a lot, and you'll see as I did a lot of work with a lot of different animals. So keeping animals alive is critical. And there's a lot of life support systems that go into things. So when you think of mechanical engineering, electrical engineering, life support systems are critical, as well as plumbing. I worked with a company out of California that did nothing but life support systems for animals. They designed the elephant exhibit. They designed all the different aquatic life exhibits, things for penguins and you name it, turtles. I've built exhibits for about 30 different animals. And, but that's a niche market. So that's one thing that you guys are going to see as engineers as well, is what you're passionate about can be part of anything. If you love animals and you're like, well, maybe I should be a vet, but I really like engineering. There's something for you, right? There's opportunities to blend those two. And that's how this particular company was that, and they're making a fortune doing it. They're making a ton of money because they work through what each animal likes. This is the SpongeBob SquarePants exhibit. It didn't come through very well. I don't know what's wrong with my pictures. This was awesome because we won an award for a THEA award. It's a themed entertainment award, but we had, it was for innovation in the entertainment industry. So this was the first exhibit ever like this. On the screen, SpongeBob will talk back to you. And the way the technology that was used to do that, again, was another engineer, was an electrical engineer that kind of broke away from what he was doing in the low voltage world and said, I want to try something different, loved entertainment. This was huge. We had lighting design. There's people that we had smell come at you. We had water squirt at you. So from the seat designers to the lighting designers, they were all engineers. That's it. That's what it looked like. That's obviously a rendering, but so we've done a lot of different things. I've done an ice exhibit at Moody Gardens, 9 degrees in an island off the Gulf of Mexico. There was a little bit of engineering going on there. What do you guys think? A lot of study of the materials and things like that. So we had to, but it worked. We had to build it and we had to make sure that we asked the right questions and we got to the root of it. And I was involved in every stage. So I'm glad that I have the education that I have to make sure that I can ask the right questions, leverage the right people, and have the right relationships. So here's a picture of the tent going up. And then the other thing is with my degree and all of the engineers that I work with, they have incredible opportunities to help people all over the world. So this is a picture after Hurricane Ike of what Moody Gardens looked like. But I have some friends that there's been some hurricanes there was a tornado, I think, that's gone through. I live right over in Siena. I'm not far from you guys. And so there's been some hurricanes that have gone right through our area that they come out and they help people make sure their homes are safe. People that they do research on how to recover things, how to fix things. If a bridge is going down, civil engineers are engaged in making sure that how are we going to do it. So you guys ask me some questions so we can stay on time. Anybody have any?
Yeah, feel free to type it in chat so I can read it aloud.
Well, as you guys type, this was the aquarium down at Moody Gardens. Again, I would hope that this was all engineered, or I sure as heck wouldn't want to walk underneath of it. But when you think about just the angle of the glass so that you can actually see through it and see light. And this is the penguin exhibit, which again is a cold globe inside something else. And now I'm working on the new airport, which is, it's going to be awesome. And I did not realize, and one thing, I learned something new every single day, and which I'm excited about. I don't think I would be happy in a career where I didn't have an opportunity to learn something different. I learn every day, like today or yesterday, I learned about the weight of an airplane going over a manhole. So seems kind of simple, doesn't it? Well, not if you're the airplane. If you're on an airplane and you hit a manhole that isn't the right strength. So again, the civil engineers involved with making sure that every single piece is safe, not only just general safe, but they need to understand airplane safety. So let's see, are there some chats in there?
Yeah, there's a few questions. Due to time, we'll just answer one of the questions.
Okay.
So someone said earlier, you mentioned being inventive. How do you have something that is your favorite that you invented? Sorry, do you have something that is your favorite that you invented?
That's going to take longer than 5 minutes, but I will, I don't know. That's a good one. I think that ice exhibit was one of the most amazing ones. And then mechanical engineer does design those arms for the deal. Those are, there's a lot of opportunities there. And where is the new airport? And that's Bush, the Bush International Airport. We're doing the new international terminal. So if you go out of Houston in 2022, you'll be walking through my project.
Well, thank you so much to Ms. Cotie for coming to speak to our students. It was a pleasure listening to your talk, and I'm sure that our students learned a lot. Thank you once again, Ms. Cotie, for joining us.
Thank you guys for having me. Thanks for having your cameras on, folks. That was cool. Thank you.
All right, see you.
Call me. You guys are welcome to contact me anytime, and I'll share my information with the Academy. Thank you.
With that being said, our next speaker, like I said, is Mr. Chaffee. He is speaking from 10 through 10:30. He is a veteran of over 50 years experience in the aerospace industry at NASA Johnson Space Center, focused on design, development, and operation of manned spacecraft and their systems. His expertise is propulsion and power systems, robotics, biomedical engineering, systems engineering, and integration and program management. Please give a warm welcome to Mr. Chaffee.
Okay, well, good morning, folks. I'm real pleased to join you this morning, talk about chemical engineering. Chemical engineer, I am not a traditional chemical engineer as the way they are usually thought about in the Houston area. I was a chemical engineer in the space business, which involves some very unique applications. Chemical engineering, however, involves use of chemical principles, obviously, in order to figure out how to produce a product for their employer that will create a profit for that individual. And the principles of chemistry are very deeply involved in what we do, as opposed to being a mechanical engineer, civil engineer, structural engineer, things of that nature. So the examples that I've worked on in my lifetime were rocket engines and propellants, fuel cells and advanced batteries, explosives, recycling of waste materials, and trying to satisfactory for the astronaut crew wherever they are. And also at the end of my career, I was deeply involved in trying to learn how we could live off the land at both the moon and on Mars. So it was a very interesting variety of tasks. I'm deeply trained in various areas of chemistry, primarily in inorganic and organic chemistry, physical chemistry, and I enjoyed that very much. But my deep expertise is as a rocket scientist. So I have a great deal of joy when I'm arguing some topic such as politics with an individual, and they say, well, who do you think you are, a rocket scientist? And I say, yes, as a matter of fact, I am a rocket scientist. At the NASA Manned Spacecraft Center from 1962 to 2015. I did retire in 1999 and worked part-time for them, and then became a consultant and an advisor for them. And now I am completely withdrawn from any connection with NASA. But I held a variety of jobs, and that is typical for a chemical engineer. As an example, I was the deputy chief of propulsion and power systems for all of the manned spacecraft systems that we developed. For the International Space Station, I was chief of program integration. So I figured out how we were going to assemble the thing on orbit. Now, my staff and I did that, and it was a very interesting topic because there were 46 different pieces that had to be gathered and assembled, most from the United States, but a couple from Europe, one from Japan, and 3 or 4 from Russia. I was for several years. I was a wonderful job that I really loved. I was also deputy chief of automation and robotics for several years. I loved robotics. I was deputy chief of biomedical engineering. Among other things, I had to figure out how to give the astronauts shots, which they didn't like, but I enjoyed doing, and a variety of special assignments. So I had a great career over my period, and really enjoyed it. I still stay very much in touch with NASA and the people that I worked with. The range and scope of jobs for chemical engineers is very large. Now, typically in the Houston area, chemical engineers are involved in things like refineries, chemical plants production, waste management, waste sewage treatment, water purification, things of that nature. So the work and the assignments the airplanes, etc. Chemical engineers do have a involvement in that, but the space application is much more involving of chemical engineers. So the jobs that lie in your future, some in the immediate future, and some a little bit further on, or for instance, in the next few years, we will be returning humans to the moon, and you will be returning to the moon to stay, and you'll be creating large lunar bases, developing a commercial capability on the moon involving primarily mining of the moon. That will be a very interesting activity. You're going to have to learn to live off the land, because you can't take everything you need from the Earth to the moon. You're going to try to figure out how you can use lunar materials to create the bulk of the activities, bulk of the materials that you need on the moon for use. Ditto for Mars and its moons. After we've established a presence on the moon, we will be going on to Mars and landing on Mars, living on Mars, probably also living on the 2 moons of Mars. We'll be mining the asteroid belt. There's going to be space tourism. So all of that will happen during your career as a engineer if you go into the space business. The mode of operation of a chemical engineer, as in most engineers, you're a member of a team. You're going to need to demonstrate high competency. Obviously, you got to work well with others. You must be able to lead your team successfully. You got to stay current with advancing technologies. And to do that, I suggest you regularly read the literature You join and participate in technical societies and develop high communication skills. And on top of that is listening. You got to be able to listen and understand what people are telling you. You're going to have to be very good at speaking, presenting, and writing your ideas, so you can put forward things to your colleagues and your bosses as to what you think needs to be done. If you're very talented in specialized video products, that's a very useful talent. Also, the rewards for chemical engineers are many. You're going to work in exciting new areas in a space program. Many of those things will be the first of a kind assignment. They will be things that no one has ever worked on before. Mainly involved with new environments. The environment of the moon is very strange, very different from the Earth. The environment of Mars is very different from the Earth and the moon. If we go into the asteroid belt to mine the minerals and chemicals from the asteroids, those are very small bodies and almost no gravity. You're going to have some very interesting challenges in dealing with that. You're going to be working with people very broadly internationally, because these projects are going to be very, very large, will involve many, many countries. And if you're like me, I worked with all of the European countries. I worked with the Russians, Japanese, etc. You will have the opportunity for international travel, of course. If you're interested in flying as an engineer with experience, you'll have the possibility of selection as an astronaut. The salaries within the government for engineers are very good. Typically, you will start coming right out of college. You'll start in the $80,000 to $90,000 a year range, and in 10 or 12 years, you could expect currently to get up to in the range of $165,000 to $170,000 a year, which is a reasonable living wage. Let me give you a sense of things that I worked on that you may be interested in, and the major one, because of the limited time, I'm gonna show you. And since I'm a rocket scientist, is I'm going to show you a rocket. And this is a steering rocket from the Apollo spacecraft. It's a 100-pound thrust. You can get the sense of the size of it. It weighs about 7 or 8 pounds. It has a combustion chamber made out of molybdenum. The nozzle out here is a super alloy, a nickel cobalt super alloy that withstands very high temperatures. And there's 2 little valves up on the end up here that allow fuel and oxidizer to enter into the chamber, burn and combust, and run out the nozzle to create thrust. Now, most rockets that you're familiar with are the big booster rockets, and the little rockets I worked on primarily were completely different than that. They were steering rockets. They allowed the spacecraft to change its velocity, either plus or minus, going up and down, sideways, or rotating around. So they typically operated in what you call couples, so that if you wanted to just roll around, you didn't also induce an up or down motion or a sideways motion. Very, very interesting. I had to work very closely with the people who were doing guidance and control to make sure we understood how to do maneuvers and how to initiate thrust from each of the rockets that we wanted to do. The propellants were very toxic materials. There was typically bipropellants, meaning there was a fuel and an oxidizer. And the fuel was a material called unsymmetrical dimethyl hydrazine, which is very much like a very concentrated ammonia. And the oxidizer was nitrogen tetroxide, very much like a concentrated nitric acid. Very nasty things. You don't want to get them on you or in your eyes or etc., because they'll do great damage. So when you're around them, you have to be suited up with protective masks, etc. But working in a rocket test facility was very exciting for me because, for instance, in that little rocket that I just showed you, as I was one of the chief developers of that for the Apollo program, I managed to blow up 12 of them during the development program, which was of great concern to the astronauts. And I would get calls immediately after I reported that it happened. I would get calls from the chief engineer and then from the astronaut office wanting to know, hey, Norm, what happened? Are you gonna get that fixed? We can't tolerate that. And so we did get it fixed. And each of the Apollo spacecraft that flew had 16 of those on what's called the service module and 16 on the lunar module, and all of them worked very well during the program. That's a very top level view of what I did. I also worked on fuel cells. I worked on little explosive devices that were used to initiate all of the pyrotechnic activity that allowed us to separate stages of the rocket during launch. They initiated things like the burning of the main engine. They allowed us to get rid of the escape system when we didn't need it anymore. We could initiate an explosion and blow that device off and send it off into the ocean. So I had a very interesting career as a chemical engineer, burning things, sometimes burning them up, and blowing things up on purpose. So that was a great deal of fun. I've got some advice for you when how to succeed at the university level, because I've been through it and mostly succeeded, but university that has an approved program in chemical engineering. All schools will give you a good education. However, you want to plan your complete 4 or 5 year program as you go in with your advisor. And then when you get there, you know, there's a lot of folks that don't understand these rules. Go to class. When you're at the university level, you know, it's not like high school anymore. The professor will show up. He may not even look at you. He'll just turn to the board and start talking and writing. And if you don't pay attention, he doesn't care. He'll understand that when he gives you an exam, and you know, shortly you'll not be in university anymore. So go to class, study alone, of course. For group studies is just great. You can learn so much from being in a group as you study to do homework or do tests or that kind of stuff. If you're having trouble understanding a concept in any of your classes, go knock on that professor's door and say, hey, you know, can you help me understand this? I'm not getting it. And they will. That's why they were there. Ask for help early if you're having problems. Plan your time while you're there so that you're allowing plenty of time for for studying and sleeping, and maybe a little time for beer drinking or going to parties or things of that nature. Sleep before your exams, that's always a great thing. You don't want to stay up all night and then go to the exam. That's a very bad thing to do. Allow some time to have fun. Yes, sir.
Mr. Chaffee, due to time, we're gonna have to move into the Q&A. So if you could like wrap it up, so then they can ask questions.
I'm through. Yep. I'm wrapping it up. But join your student engineering society. There will be at all the schools. There will be a student chapter of the American Institute of Chemical Engineers. It's run by the professors, so you'll get to meet the upperclassmen and the professors and get an arrangement with them. Read the literature regularly, and I think it'll be a great success. So I'm open to questions. That's a very short oversight of what a chemical engineer in the aerospace business might probably do, and is an overview of my career. So I'm open for any questions you might have.
All right. If you have any questions, just type them in the chat, and then I'll read it to Mr. Chaffee. So one of the first question is, what were some of your largest teaching moments? And also, if possible, so what was some of your largest teaching moments in your career?
Some of my
largest teaching moments.
Repeat my life's
largest teaching moments in your career.
Largest teaching. Well, failures. When you're doing testing and you're expecting everything to work out and be just fine, and then you have a failure that's unexpected, which requires you to go back and re-examine all of your hypotheses and preparations and that type of thing. So as an example, the vibration environment on the rocket engine, the Saturn V rocket engine, is very, very difficult to deal with. And up on the far end where the spacecraft is, it's exaggerated, and so we had to test all of our components very much in all the expected acceleration environments. And the first time I took all my components, put them together in a complete system, mounted them like they were going to be mounted in the spacecraft, and then subjected them to a vibration environment for 8 minutes, like they were going to endure during launch, and then opened up the test chamber to go in and expecting to see that the system that I had put in there to test was in completely good shape. About half of the parts had broken away and were in the bottom of the test chamber. So all of the calculations we had done for how to attach these things and to mitigate the vibration response had not been adequate. So it was go back to the drawing board, folks, and figure that out. So it's things like that. When the rocket explodes when it's not supposed to, you want that to happen while you're in the test and design mode, not while you're halfway to the moon, things like that. So I'm sure all of you have seen Apollo 13 and the things that happened. It was my division that was responsible for the hardware that exploded on Apollo 13. Now it was caused by an unexpected and unplanned for test at the Kennedy Space Center that was not done right. But still, you had to deal with that, and we learned an awful lot. And when that happened, I had to go into work and stayed there for 4 days, with no sleep, working on the team to get that figured out. Okay.
Well, thank you, Mr. Chaffee, for coming to speak to our students. Due to time, we'll be now concluding the session. It was a pleasure listening to your talk, and I'm sure our students learned a lot from your speech.
Thank you.
Okay.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Any of y'all can email me or call me, by the way.
Yes, sir. Thank you.
Thank you for coming.
Okay. Thank you. I enjoyed it.
Now, with that being said, our third speaker, like I said before, is Mr. Obinna
Ilochonwu.
He is a Schlumberger's industrial IoT architect, where he is helping to shape and develop the company's IoT platforms, such as Agora. So please go ahead, Mr. Ilochonwu.
So can you hear me okay?
Yes, sir.
Okay, excellent. Okay, so my name is Obinna Ilochonwu. People call me Obi, not Obi-Wan Kenobi, just Obi. So, but that reference is probably lost for those who are not Star Wars fans. So I'm the Schlumberger Industrial IoT Architect. I work in a center called SLIC, is the Schlumberger Industrial Internet Center. And today I will be talking to you about the Internet of Things, but more specifically, the Industrial Internet of Things. So, what is Schlumberger? So some of you are probably wondering, who is this company called Schlumberger? Some context. We are the world's largest oil and gas service company. We have about 82,000 people, 170 nationalities. We work in about 120 different countries. And the company was founded more than 90 years ago on the principle that if you have an electric source under the ground and you have receivers at the surface to analyze the signals, you can infer from the analysis the formation of the rock. You can infer the rock types, how the earth is packed, and you can use that information to be able to increase the probability of where you have oil and gas reserves trapped between the bottom and the top. So that's really what is called a log in the industry. We have grown over the years and expanded the business line to include everything from looking for oil to drilling for oil to installing wells, extracting fluids from the subsurface, and we're deployed in offshore to the middle of the jungle and the desert. But in all these different business lines, the main facilitator is really data. It's digital technology and intelligence. So intelligence is pretty much data and software, and that's the lifeblood of all these solutions. So we employ AI, data analytics, visualization in all these different solutions to be able to extract value for our shareholders. So that's about Schlumberger. So let's go back to the topic, Internet of Things. What's Internet of Things? It's pretty much just the connection of smart devices to one another and with the cloud, with the idea of sharing information, processing data, and being able to deliver little bits of compute resources in all these smart devices so that we'll be able to give us more valuable data to be able to make decisions on that data. So that's what it is. But let's go back in time and see how this started. So previously, all interactions were done between human beings, you'll be able to ask questions to another human being, and based on that, on the answer to those questions, you'll be able to make decisions. So it was pretty much between people and people. Eventually, it grew to between people and intelligent devices, which we call computers. And as technology advanced, we were to have these computers organize themselves in networks, which we call the internet today. And the interactions were between human beings and this thing called the internet. Now we're at the stage where take the human out of the loop, and where the interactions are between intelligent devices. So between intelligent devices and the internet. That is what the Internet of Things is. It's really this self-organizing network of compute nodes where devices talk to other devices to be able to answer questions. So of course, these are silly questions, but the kind of questions that you would want to have asked, are things around, for example, your smartwatch today, which by the way has more compute and memory than what powered the first rocket to the moon, right? So advances has grown, and because we've been able to have compute resources shrunk into devices like this, that's helped us, advance technology. So for example, your smartwatch today, can monitor you, and if you're having a heart attack, it can, dial up your doctor. It can send your location to the ambulance, and they can pick you up. So that's one example of what really
Pardon me,
connect.
Mr. Obi. It seems like you're
Yes?
sharing your screen, but we don't exactly see your screen.
Oh, you don't?
Yeah.
Okay, that's a shame. I had it set up previously. So what did you see? You
just saw you speaking, but like we completely understand what you're saying, which is pretty good.
Okay, that's a shame. Let me go ahead and with in the last room, it was I shared it and everything was working okay.
We have to reshare it at the bottom. There should be a place for you to share your screen. So
let me go ahead and reshare then. So can you see it now?
Yeah.
Okay, you can see that?
I can see it now.
Okay, so I'll quickly rush through. So I know we're going to be short on time, so I'll quickly rush through that. So I said, so it's that. Those are all the business lines, and the idea of software embedded in all those different products. Really, it's what adds value to the operations. As mentioned, Internet of Things, about connecting those devices. So that interconnectedness of devices and being able to share data amongst the devices is really what gives us value. And I was talking about the history of Internet of Things, before the interactions were between people, later on between people and devices, which we call computers. Eventually it moved to the connection of, where those devices are interconnected, and we have people interacting with the internet. And finally, between devices and the internet. That's what the Internet of Things is. As I mentioned earlier on, we still have interaction between people that still exist, but we are moving now to the future where we don't necessarily need humans in the loop, and we can have devices connecting to other devices on the internet. Right? So that is the Internet of Things today. An example of this in your smart home, and this actually happens today in your smart home. You can walk into your, from school into your house. The house knows it's you because of your watch. And it's able to turn on the AC to your desired temperature because it knows it's you and not your sister who prefers maybe higher temperature. So you walk in, sit on the couch has a pressure sensor on it, and it knows that since you've sat on it and you're orienting towards the TV, it's probably time to switch on your favorite TV program. So it puts on Star Wars for you. The fridge has a sensor that talks to the outside, and it knows that it was hot outside. So you probably need a cool soda. So it chills your soda. But while it's chilling your soda, it also knows that you've gone from 10 Sprite to 2, and so it knows you're short on soda. So it sends a call to Walmart to order a refill for you, right? So this is this technology is there today. This is not the future. This is what exists today. But take this concept and apply that to the industry. So take IoT and then apply that to industrial devices, make sure it's secure, make sure it's rugged so you can operate in the jungle. And voila, you have the industrial Internet of Things. So the industrial Internet of Things is simply taking IoT and making sure that it's secure enough and robust enough to work in the industry. Why is secure and ruggedization important? This is why. At home, if you walk in and let's say your sensor detects it was your sister, not you, and you sit down and it turns on Teletubbies instead of Star Wars, well, you're probably irritated, but life goes on. In the field, if your pump, if your valve on the well, thinks that there's no more oil coming in and opens up the valve and you have oil and gas kind of sprouting to the surface, that could cause an explosion, that could kill people. So the amount of accuracy and the precision and the tolerance for risk on the edge for industrial devices is much, much more than what you would have for your house. So the industrial Internet of Things takes it one step further to make sure that, you know, the tolerance level and the tolerance for risk is really low. Make sure it's secure so you can't hack into it, you know, or else bad things could happen. So Schlumberger, we have our own IoT platform, and that's called Agora. That's the screen you see behind. And what we've done is we've taken our intelligent device on the edge. We have incorporated the ability to talk to well site devices. And then we've added artificial intelligence, compute visualization on the edge so that, you know, we'll be able to, you know, process data and answer questions and make decisions on the edge. So we don't necessarily need humans. We're also able to push data from the edge to the cloud, where we can take advantage of the elasticity of the cloud, the infinite compute that exists on the cloud, to be able to answer more in-depth questions, and also, you know, to have humans look at, be able to look at operations from the cloud to the edge. IoT is growing big time. There are about 41. There'll be about 41 billion devices in 2027, and it's growing every second. So pretty much every single second, 127 devices are being added to the internet. The market is going to be about 2.4 trillion in 2027. So what does this mean? For me anyway, it's job security, right? It means that I get to do what I love doing, but know that this technology is going to be around in the near future, you know, for the foreseeable future, because this is only going to get more and more advanced, and we're going to get more and more IoT-fied, you know, as the world moves on. So what does that mean for you? So, you know, this is a typical job description that we'll see that we have actually for Schlumberger. If you look around, the first thing here is about, you know, making sure that you master a language. There are many languages. I don't care which way it is, Java, Python, C#. Pick a language, master it, because that's what's going to help you get to the next stage. On top of that, make sure you stay in school, guys. You know, make sure you get a degree. You know, and if you are looking at the IoT field, make sure it's STEM related, preferably something around computer science, but it doesn't have to be. You know, you can stick to a STEM, one of the STEM degrees, as long as there's an element of compute in it, you'll be fine. The other thing is about experience. So this is chicken and egg. We tell you we want you to have experience before you start working for us, but then you ask yourself, well, how do I get experience? So it's chicken and egg, but you can break that chicken and egg cycle by internships, volunteering, you know, look for any related associations where you get to practice, you know, set up, be a webmaster, have someone, you know, being able to create a database for information, but just make sure that you're able to get experience, you know, before you get to the you apply for the job, because then we will ask you for job experience, which doesn't sound fair, but you know, you can do things now before you actually start looking for work. Important teams, you know, gone are the days when we lock computer science guys in the basement and have them, you know, work alone. Today, the world is interconnected. The same way devices are interconnected, human beings are also interconnected. So work in teams, make sure you're able to, you know, learn how to leverage the best of each other in a team setting. Working under pressure. So, you know, people ask me, well, how do I solve problems under pressure? How do I make sure that if I have a problem, I can deliver a solution to it and, you know, do that on a, you know, on a continuous basis? Well, it doesn't come by magic. It comes by practice. So make sure you have boot camps, hackathons, participate in this. Practice makes perfect. The more you learn how to solve problems in these scenarios, you know, the more it will benefit you in a real company setting. And then also the willingness to learn. I learn every day. You know, you can't put a brakes on learning. You have to, you know, keep on learning. You have to be curious about the world. You know, so keep on learning. Make sure and education is not just in school. And there are lots and lots of online resources these days that are, you know, really geared towards people who want to add value to their skill set. So I tell my people that work for me that, you know, your brain is like a toolbox, and you have to continue putting tools in that toolbox, you know, so that you can be able to use those tools to address problems in the real world. And then finally, you know, companies are not set up, you know, for, at least my company is not set up for charity. It's really, we owe our shareholders at the end of the year, we owe our shareholders a return on their investment. So we need to be organized, we need to be disciplined, We need to be able to do what we say we're going to do when we say we're going to do it. And that also applies to our employees. So this idea of organization, time management, that has to start from now. It's not something that is going to just come up to you when you're, when you're working. It's something that needs to start now. Yeah. So learn how to manage your time, learn how to be organized. So that's pretty much it. Sorry about the mix up in the beginning. I was trying, I thought I was sharing my screen, but I guess I wasn't. But anyway, that's it. So any questions?
If you have any questions, just feel free to type them into the chat and I'll read them aloud.
So I heard that if your parent works at Schlumberger, you're able to get like a scholarship for I think like $5,000 or $10,000 scholarship. Do you know how that process works?
Sorry, I didn't hear the question. Could you repeat it?
So I heard that if you have a parent that works at Schlumberger, then you're able to apply for like a scholarship. Do you know how that process works?
Oh yes. So it's so actually my daughter is going to college this year, and we're using exactly that same process. So yes, you can there's a website in Schlumberger, on Schlumberger's site, and you can go in there and apply. You just need to include your parents' employee information, and that will get tied together.
Okay, thank you.
We have a question and it says, how did you start your application to Schlumberger? Did you have any pre-qualifications?
So we in generally in Schlumberger, I've been in Schlumberger for about 21 years now. I started off in Houston, and when I started, it was pretty much the same process as it is now. It's go to the website, put in your resume. We do like to see that you have a bachelor's degree, at least in a stem cell, one of the STEM fields. But now we are actually more open. So as long as you do have some kind of experience or educational background in one of the sciences, you're good. So we do have a website, www.sab.com/careers, and you can go in there and apply for internships for full-time positions or even temporary positions.
Any other questions? Well, if there are any questions, thank you so much to Mr. Obi for coming out to speak to our students. It was a pleasure for listening to your talk, and I'm sure our students learned a lot. And without further ado, our next speaker is Mr. Aparicio. I'm not sure if I'm pronouncing that correct. I hope.
That's good enough.
All right. He is a seasoned information technology professional with 30+ years of experience working in the energy industry, mostly for large multinational companies in several countries. He also has a broad-based background encompassing technical operational management, business development, consulting, customer relationship management, Scrum Master, agile coaching, and project management roles, and among other things. Everyone, please give a warm welcome to Mr. Aparicio. You can take it away.
Thank you so much. So thank you, everybody, and thank you for letting me share part of my experiences with you. So as Philon said, I'm going to talk about computer science, which is my major. And I've been working for so many years, but has always been in computer science. I've been in the oil and gas industry, mostly in different areas of the oil and gas industry, but all the time doing computer science or information technology. So this the first slide tries to cover everything that, or most of what we do in computer science. So we have the whole network components, the brain of artificial intelligence, some of the browsers, so we can recognize some of the large companies there like Microsoft, Google. We got the drones, which are very common today. the small drones. We got also a robotics part. We got the big drones, and also part of what Google and other companies are doing about the driverless cars. And we can see now cars are very much a computer with wheels, very much. So this is my email at BP. Feel free to contact me if you have any questions. And also I have my LinkedIn profile in there. You are welcome to invite me to join you, or you can join me, and I'll be more than glad to do it. So a little bit about my background. I was born in Colombia, and I really grew up there and went to high school and college there. And I got a degree on Bachelor of Science, Systems Engineering and Computer Science in Colombia, 1980. And when I initially came to the States, I came to do a master's in computer science in Rochester, New York. Went back to Colombia, worked for some time, came back to the States in 1999. As part of my work, I went to Anchorage, Alaska for 6 years. I was there. I did an MBA in general management. And
please mute your mics as y'all come in. All right.
And I've been working oil and gas most of my life. Oil and gas has been most of my life. We now call it energy rather than oil and gas. And through my time with BP, I've worked in Colombia, worked in Venezuela, I work here in the US, in Alaska, here in Texas, I work in England, Scotland, and Trinidad, and currently work as a project manager for BP based here in Houston, working on one of the projects that we are developing, a new platform that is going to be placed in the Gulf of Mexico in the next few months. It was on the news last week when it came from Korea to Corpus Christi to finalize the commissioning and getting it ready to start producing. So what is computer science? So computer science, in some places it is known as computer science. Some schools also call it software engineering, software science, management information systems, and they are a little bit different. Some of those are more into science, some of them are more into engineering, some of them are more into management. So, and some of them have more focus into math and computer programming. Some of those have more emphasis into doing business or doing support. So those three are closely related. And what it is very much the theory and design of computing systems and software. Is very much developing software tools. We can call it software applications, but these computer systems. And it goes from the very, very beginning when you have a concept all the way to designing that application or that software, building it, testing it, deploying, and maintaining the application. And as anything that you produce has to meet some needs. So it is specifically to meet the needs of individuals or businesses or any type of organization. And some of the roles, computer science, multiple roles. The same way, if you are an engineer, you can have multiple roles as an engineer. There are many, many roles for computer scientists or information technology. And that's one of the good things about computer science. So this is a short list, like you can be a programmer, an analyst, a database analyst. You can go into network, you can be a web developer, you can be a project manager, you can go into data warehousing, you can working for Amazon, Google, Microsoft, and those areas. In the last few years, been a cloud architect, cybersecurity. They're very, very important roles. So there are many, many roles that you can do as a computer scientist. So why did I choose computer science? So I always wanted to be a veterinarian. That's what I always dream about being. And up to the last moment in high school, that's what I wanted. I was very lucky because I didn't have any issues going through high school. I was good at math, good at physics, chemistry. So I got a good, I was very focused on my studies, but something happened in my family on that year. My dad sold the farm and I wanted to be farming. And I decided that I didn't want to become an employee as a vet. So I decided that I needed to do something different. At that moment, my oldest brother, and the 6th of 9, came for vacation, and he talked to me about something new. That was 1974. something new called computers. I've never heard of a computer before. So he talked to me about computers and how computers were going to be part of the future and how computers were going to revolutionize life and everything. So I said, that looks very, very, very interesting. And over a couple of weeks, I got a couple of booklets. I read it, and I decided that I wanted to be a computer scientist, and have ever liked it ever since. Never regretted for multiple reasons. It was challenging and fun learning, going through computer science, been learning all the time. That's one of the challenges in computer science. There are new tools, new software, new platforms that come every single a few months. So if you don't keep up learning, the younger generations will take over you. You lose your job, or you fall behind. So it is you are always learning. I can create things. I can create applications. So I can say, I built this that is being used on your phone. That's a great feeling to me. And also there are new technologies you can be learning about. I went from working on mainframes using punch cards to today everything is real time and online. So I've seen the whole transformation of the industry in the last 40 years. So it's changing. And it's not the only one. All the engineering fields are changing. So some of the social fields are changing. But that's what. Something also very important is there is lots of jobs, and I'll show you some numbers later on, and some great salaries. It's one of the things that you want to do, or you want to know, is if you go through college for 3, 4, 5, 6 years, you want to make sure that at the end you have a job that you really like, and also if you can get a good payment for doing what you like, even better. So that's something very important. It's not the only degree that offers this, but this is one that is probably one of the best ones on that aspect. So as any other degree, engineering is not for everybody. Being a lawyer is not for everybody. Being a doctor, a dentist is not for everybody. Being a school teacher is not for everybody. Being a priest is not for everybody. So there are some characteristics that you would like to have if you want to go into computer science. And these are some of those. If you like solving mathematical and logical puzzles and complex problems, that's what we do with computers. We try to solve problems that you can automate and repeat. You need to be good at thinking abstractly. You need to be able to get a lot of information, being able to focus on something, being able to reduce to the key important part and go from there. You need to be very good at planning and organizing activities. I don't know if you have wrote a program, a computer program, but a computer program is just a sequence of instructions. You need to be able to give precise and elegant explanations of how things work. If we are programming a robot to do something, maybe for a simple task, it requires 300 different instructions. So you need to be very clear about that. You need to be also good at making it as optimal as possible. In computers, we talk about saving nanoseconds. If you save 2 nanoseconds here, 3 nanoseconds there, things go fast. So you need to be able to be elegant and giving instructions. I don't know if you have ever tried teaching somebody to do a specific task, like go from this place where you are sitting to a kitchen. You may do it in 20 different ways, but you want to find the shortest, simplest, the way that is more foolproof. Also, you need to be able to be good at research. You need to like researching, going and thinking and trying to find solutions, and also working on groups. The whole idea of I just go into a dark room and all of a sudden I create things, that's not true. Nowadays, you need to start working on groups. And it requires some skill. So you need to be able to focus on something. You need to be able to pay attention to detail. If you talk to somebody writing an application software, they want this to be green, this to be font size 8, for font size 10. So you need to be able to do that. You need to have a lot of initiative and creativity. There is nothing worse than a web app, an application that doesn't catch your attention because it is boring, because it doesn't keep your attention. So also you have to be good about critical reading and thinking, good at giving directions, as I mentioned before, logical reasoning, organize, and listening skills. Because if you are developing an application, you don't do it just for the fun of doing it. You are doing it because somebody is going to use it, you're going to sell it, or it's going to solve a need. So you need to be able to listen carefully and understand what your clients or your users need and want. So you can then capture those, create the rules, and then implement something. So where do we computer scientists work? As I said, that's probably one of the few degrees that you can go and work basically anywhere you want. There is not a simple organization today, big organization, mid-sized organization, that doesn't have an IT department, that doesn't use computer technicians or desktop technicians or project managers. So this is probably the only one that you can be and work on any of these multiple industries. You can work on the software business. You can see some of the big names in there. You can go into technology companies such as Amazon, SpaceX, Tesla, which are very much people that all they do is computers. So they build the Tesla car is very much a computer with wheels. It's no more than that. In the energy, you got the oil and gas, mining, electricity. So you can see a whole bunch of industries. There is plenty of jobs in that, all for computer scientists. And you can be there developing applications, keeping their networks up to date, keeping their networks secure. For the hackers that happen today, you need to be very good at that. You cannot think of the federal or even the entertainment, which is another big business, doing movies, animation, that's casinos, online games, gaming, creating games. So there is plenty of work. So what can you do in high school to be ready to go into computer science? Different degrees need different classes that you should take in high school. So the recommended classes, the core classes that you need, especially if you go into computer science or software engineering, is you need to take as many of your English classes because you will be able to read more, write better. Math is the foundation of logical reasoning. To take a foreign language classes, take as many as you can. Nowadays, we work out of home. We work with teams that are spread over the world. My team, I work with people that are based in Malaysia. I work with people that are based in Hungary, in Budapest. I work with people that are based in the UK. We all work in English, but sometimes you work with people in Spain that don't speak English. So the most foreign language that you learn, or at least that you can read, the better. Science and social studies. And you can start taking some of the electives. It's better to take some of the electives in high school, like computer science, writing, take some programming languages, statistics, some of the math classes, because that's going to give you an idea of the classes that you're going to take in college. And also you can gain some of the credits already. And also you can start enjoying and say, oh, do I really like writing code? Is that what I'm going to be doing for the next 20, 30 years? Do I really like it? So that's good to start testing it as early as you can. Some of the college courses that you will take, there are plenty of classes. There will be classes like Introduction to Program, Software Architecture, Object-Oriented Programming, Mathematics. You will take a lot of math classes. There will be database classes, simulation, cybersecurity, robotics, artificial intelligence, computer graphics, systems analysis, data structures. There is plenty of classes in there. In fact, I was checking some of the programs here in the schools in Houston, and they only take a few of these classes because 4 years is not enough to take all the classes. So some of those classes, they give you electives. Most of these become elective classes because you can go in multiple areas. So regarding work, I said that this is probably one of the best fields. This is data that I took from the U.S. Department of Labor, which is updated a week ago. It says that employment in computer and information technology occupation is projected to grow 11% from 2019 to 2029. By the time that you graduate from college or your master's or your PhD, this is where you want to be. There will be plenty of new jobs in the information technology area, and emphasis on cloud computing, collection and storage of big data, which is the big data warehouses, and information security. And it is normally it's difficult to predict what's going to happen in 5 years regarding jobs, but this is one that has been consistently growing. And that's something that you want to take into consideration. And also the median annual wage for computer and information technology was $91,250 in May of last year, which is more than twice the average of the other median annual wages for all occupations. So it is very good. It's very well paid. There are plenty of jobs. And these are some of the also from that page, from the government, some of the roles there, typical roles, like for example, if you are a computer network architect with a bachelor degree, you can easily be making over $110,000. You can see all of them in here. And just wanted to talk a little bit about the computer support specialist. That's a job that normally doesn't require a degree, not even an associate degree. Most of those guys that I know that do that, they have learned it by themselves, or they have gone through some of the online classes. They do their own certifications, and they can easily make over $55,000 after half a year of classes and a couple of certifications. As long as they like it, and as long as they want to put the extra time learning by themselves, it's very, very good. That's even higher than the average wage of the other occupations in the country. So that's what I wanted to talk about computer science. So if you have any questions about computer science, or if what I do or what we do at BP in information technology, I don't know how many more minutes we have left, but
all right, thank you.
I can stay as long as you want until my wife calls me to start making lunch for her.
There are a few questions in the chat. One of them being, what's the difference between IT and software engineer? What is it like to work as an IT project manager?
So IT is information technology. So that's a generic name for information technology. And that nowadays, for example, at BP, we call it digital technology. We move from information technology to digital. But that's the generic name for computers, for phones, anything that is based on computers, based on bits and bytes is information technology. Telecommunications is also considered information technology. And the other one was software engineering, or?
Yeah, so what is it like being a software engineer? No, sorry, an IT project manager.
So I've been a project manager for the last 20 years. So I enjoy being a project manager for multiple reasons, because I have the opportunity to work with people, be part of a team, a large team. Generally, they're geographically dispersed teams. And to me, I like it because I can provide direction. I allow my teammates to grow and to be on their own, give them their space. And at the end of the day, we as a team deliver something. That's what I like the most about being a project manager.
All right. We have another question. It asks, if one is interested in taking computer science in college, would it be more beneficial to take calculus or statistics in high school?
I think that we'll go for calculus, because there is a sequence of classes that you need to take. Like you have to take calculus 1, 2, 3, In some cases, you may need to take calculus 4, differential equations. So the most that you can take before you get into college, the better, because you can get those sequences early on. You can end the sequence probably when you are in 4th or 5th semester, and that opens the opportunity to take some of the advanced electives. And statistics, I think that even some of the programs may not require statistics, but statistics is one that is becoming very, very important, because we are doing now a lot of data intelligence, and the data scientist, which is another very good job. I should probably list it in there. Is very much about statistics and understanding the business, but it's about knowing statistics, knowing some of the statistics packages, software packages. So that's a good one. And also, I would say classes tend to be easier in high school than they are in college. So if you can take them while you're still in high school, it will be easier to get better grades than when you are in college.
Another question asks, which coding language is most beneficial to learn right now that will be very beneficial in the future? And which one do you personally prefer?
So that's a kind of a difficult question for me, because I haven't coded in probably more than 15 years. But I know that people that know Java is kind of the basic language for web applications and for those things. And also languages, I don't know, Python is a very common language right now, extremely powerful. I took a class recently just for the fun of learning, but my job doesn't require me to use it. But Java is very good, and there are so many others. Like if you learn C or C++, C#, there are multiple versions of the C language, but there are many. So I remember when I was in college, our professors used to tell us that the worst you could do was to learn BASIC. There used to be a language called BASIC. I don't know if it still exists, because it will allow you to write code in a very disorganized way. So they say people start learning how to program not being elegant about writing code. So you end up writing code that looks like a spaghetti, which is very difficult to support and maintain later on. So if you can learn any of the structured languages, what they call 4th-generation languages, things like that, but I don't know the names of all of them. There are many today. I'll go for Java or C++ or C#.
In the multifaceted computer science field, which aspect do you think is the best in working in this field?
So for me, I think that if you're going to be in the business of writing code and writing software, something that is extremely important is to keep learning, because there are going to be new languages, new platforms, new things that you need to keep learning. Otherwise, the new generations, people getting out of school, are going to displace you very quickly. So keep learning, try to jump into the new software tools that show up in the business, in the market. That applies to probably any of the engineering, but especially in software, go and jump into that as quickly as you can, learn about them. And also something that is very important is being responsible for your work. If you say, I'm going to do it in 3 days, 4 days, do it. And since we rely a lot on software today, make sure that you write a software that is well written, that doesn't have as many flaws as it could. So that's what I would say that is very important in my view.
This other question asks, what types of problems do you encounter and have you solved with computer science?
Wow, that's like we're trying to go, right now we're trying to beat COVID. There is a lot of computer science power doing the analysis that they do to analyze the virus. There is a lot of computer using DNA research, the genome. So there is a lot of computer science behind SpaceX. There is a lot of computer science right now trying to fly the small helicopter in Mars. I don't know if you have seen the news. They tried to fly the helicopter last week. They found a small software issue. So they're right now trying to fix the issue. So software is everywhere right now. So, and it is helping solve problems every day, all kind of problems. So,
Okay.
so you choose what area you want to work on.
Is coding necessary to be an IT project manager? And what about cybersecurity?
So cybersecurity right now is extremely important in general. We just saw recently they hack into a lot of companies here in the US through a company called SolarWinds that manage networks for many, many organizations. Some people say that they were the Russians that got behind that. So we need to protect that. Every day we get that hackers get into the banks, they get your credit card information, social security information. So cybersecurity is extremely important. We don't want a day after tomorrow you are driving a Tesla car and they can hack into your car and they make you crash. Eventually they could hack into your pacemaker. People that have implanted pacemakers, they can hack into your pacemaker and accelerate your heart. So we need to protect almost everything today. So cybersecurity is extremely important. It is a field that changes every single day because as much as we have the good people trying to prevent it, there is a bunch of bad people trying to be smarter than we are, trying to find new viruses, new things, how to beat us. So that's a constant fight against the bad actors. That's how we call them. And also from the jobs, probably one of the best paid jobs right now. It may be very stressful because you are dealing with very difficult topics, but it's extremely, extremely important. You mentioned something of the second part of the question.
I think you answered most of it. Like, okay, the first one was, is coding necessary to be an IT project manager?
No, not necessarily. I don't write code. I started writing code and I wrote code for many years. Now I don't write code and I don't even get to inspect code anymore because I don't have the time. And also we get different layers. Like I have, whenever I do projects that involve software development, I have like a technical lead that works for me. That's the person that goes and reviews the code. So if you are a manager, normally what you are trying, your main role as a manager is to communicate with your clients or your customers, avoiding surprises, providing guidance, and probably helping with the sequencing, removing roadblocks for your team. So that's what managers do, really. But I need to understand what they are doing. So if they tell me, oh, I need to write this program, it's going to take me 20 days. I need to know a little bit about writing code, say maybe this is only like a 10-day effort rather than 20. So, but other than that, you don't need to be, you don't need to write code to be an IT project manager because there are multiple areas. If you are really into the software development, yeah, it's good to know. Good to know the different languages, a little bit about different languages, where to use which one, which is better for which task.
All right, thank you, Mr. Aparicio, for coming on over and giving us a fantastic presentation. It was a pleasure listening to you, to providing all of the facets and aspects of computer software and engineering.
You are welcome, and I hope that I help convince some of you to go into computer science. It's a very, very, very fun degree, and it is very good. And we need a lot of very smart people in that field. We need a lot of smart people joining computer science. So there are so many problems that we are tackling right now, where we need computer scientists. So please think about it if you haven't already decided.
All right, thank you.
Okay.
Before we move on to our next speaker, give a big round of applause to Mr. Aparicio. Digital round of applause.
Okay, thank you so much.
Our next speaker is Dr. Tracy Benson. He is in his 13th year as a faculty member of chemical engineering at Lamar University. And everyone, please give him a warm welcome. It is yours.
Thank you very much. You can hear me, correct?
Yes, sir.
Okay. Well, good morning, all, and thank you for inviting me to speak with all of you today. So you think you want to be a chemical engineer? Well, maybe I can give you some insights, and you can make your best judgment if this is the correct career for you or not. If we could just take a moment and look back at one of our presidents, Herbert Hoover, really our nation's only engineering president, who came out with this statement. Says, "There is the fascination of watching a figment of the imagination emerge through the aid of science to a plan on paper. Then it moves to realization in stone or metal or energy. And then it brings jobs and homes to men and women. And then it elevates the standards of living and adds to the comforts of life. And that, ladies and gentlemen, is the engineer's high privilege. That is why we do what we do. This elevates the standards of living, adds to the comforts of life, helping to bring jobs and homes to people." Oftentimes I'm asked, why did I become a chemical engineer? I don't really have a great answer. Yes, it is true. I enjoyed chemistry and math in high school, but that's only probably a very small part of it. As I was in high school and young in college, I still wasn't sure that being a chemical engineer is what I wanted to do. But as time progressed and I got to be more involved and I did a co-op experience, it told me that is exactly the right field for me. Chemical engineering takes natural sciences, chemistry, physics, life sciences, biology, microbiology, biochemistry. We mix in a lot of mathematics and a whole bunch of economics. And essentially, we're looking to transform one type of chemical or energy into a more useful type of chemical or energy. And at the end of the day, that's what we're doing. So again, we combine that chemistry, that math, and that physics. We operate chemical plants. We design chemical processes. We do research and development. And finally, we have fun. Yes, believe it or not, you have fun. Now hear me out. It's not always going to be fun doing homework until odd hours of the night, till early wee hours of the morning, doing those final design projects, studying for finals and stuff. No, I get that that's not really all that fun. But the people that you will meet, the connections that you will make will be with you forever. The working with your faculty and your professors, there's just something magical about that process. What do we make? Well, this is kind of a snapshot, and I always kind of like to take a deep breath. A couple of big deep breaths here. We make cereals, meats, vegetables, frozen foods, canned foods, boxed foods, gasoline, diesel, motor oil, WD-40, garbage bags, Walmart bags, combs, toothbrushes. You see how that goes on and on and on. That list of all the different items that we use every day has got chemical engineers behind it at somewhere along its journey. Even so much as a chip, a Pringles chip that you buy at the store, right? You see that's a little math equation right there. Okay, it's a little bit of an inequality too. Where do we work? Well, you'll find that probably the bulk of us are in the chemicals and fuels area. Fuels are, for the most part, are about taking crude petroleum and converting it in the downstream processes to make many of those items I just listed off. It's not just your gasoline and diesel, but It's all these small chemical compounds that grow into larger things that we make: plastics, polymers, automobiles, all these things that we use every day. Electronics, small portion over here. We use these gadgets every day. They contain chips, and it's a chemical process, believe it or not. Generally speaking, Intel will hire more chemical engineers than any other engineering types, simply because the manufacturing of chips is a chemical process. In more recent decades, I'd say in the last 20 to 30 years, you're going to find more of this in the pharmaceuticals industry, making many of these compounds that whether it's hydroxychloroquine, for example, being as we've been talking about that for a little over a year now. That's an interesting molecule that has this kind of attachment over here on this compound, and making it, synthesizing it, purifying it, that's all a chemical process. A little bit here on petroleum refining. If you are anywhere in the Southeast Texas area, and I'm talking Beaumont, Port Arthur, all the way along over to Houston area, this small little area of Texas generates about 30 to 35% of America's transportation fuel. In other words, 1 out of 3 people across the U.S., they either drive or they ride a train or they fly, all because of the fuels that are manufactured in this process, in this small area of Texas. Refining is the processing of crude oil into products such as gasoline, kerosene, diesel, asphalt, coke fines, and other organic molecules. This is some pipe racks here. So we're always trying to, many of these are liquids or gases that we're moving from one location to another. This here on the right-hand side, this is a distillation column. And I'm gonna move out of the way a little bit. And back over here, we have, I'm in our unit operations laboratory this morning. So we have a distillation column in the lab that we can not only demonstrate what happens inside here, but also the students can do experiments and say, okay, if I do this, if I change the feed rate, if I change the temperature, if I change the pressure, what happens? How does my products vary? How well does it perform? Can I optimize it? Ooh, optimization, about economics there. Yes, yes. So here's an overview of a refinery process, taking in crude oil. You have a distillation crude unit. Usually these operate under a vacuum. You get off the top of it, you'll get your very light gases and hydrocarbons. Oftentimes they have to go through a hydrodesulfurization. In other words, we want to remove the sulfur compounds. And you see through here, as you go down the tower, you get larger and larger and larger molecules. And they end up having to doing a little bit of chemistry to them, some more separations, some more chemistries, more separations. And finally, we get the products that we normally think about: propane, butane, gasoline, propylene, propane jet fuel, ultra low sulfur diesel. Now, with that being said, chemical engineering isn't just about the petroleum industry, although there's probably about 15% of all chemical engineers work directly within the petroleum industry. We have broadened out, as I said, we're looking at pharmaceuticals. We're also looking and working in other areas of energy. We are expected over the next few years, by 2050. I know you might not think that's a few years away, but as you start getting a little years under your belt, you'll soon find out that 30-ish years isn't that long from now. We're expected our world population is going to be about 10 billion people. And if you remember that statement from Herbert Hoover, and about bringing homes and jobs to people, elevating the quality of life of people, I ask you, what kind of quality of life do we want to have for the global population for 10 billion people? Right? And that's going to take a lot of engineering power, a lot of fresh new technology, a lot of fresh new minds. That's you I'm talking to, folks. We are also expected probably to increase the Earth's temperature by another 2 degrees or so. And we are needing to find the right balance and combination of energy, whether that's solar or wind or green. I have a little green diesel pump here. Nuclear power, how much of that's going to be coal, how much of it's going to be crude petroleum. So there's going to be a mix. And if we have this mix and we continue with the crude oils that we have today, and just give you a project that I'm working on has to do with what's called carbon capture and storage. If you'll look here at this chemical process here, you see this smoke. It's not really smoke. What you see is steam, and entrained in the steam is the CO2. Now, carbon dioxide is what's believed to be causing the increase in temperature. Now, if we can take a good old-fashioned Texas lasso and capture that CO2, and then we'll have to purify it, and then we can store it deep below the ground. And I'm talking 2 miles below, into depleted oil aquifers, and out of sight, out of mind. And that way it's not harming the environment that we live in. About 6 months ago, we took a trip to South Mississippi and looked at what's called an enhanced oil recovery facility. They take CO2 and pump it deep down below, and because of what's happening below, they're actually to increase the amount of crude oil that they can produce. So that's why it's called enhanced oil recovery. And at the end of the day, most of that CO2, about 2/3 of it, stays capped below the ground. A little bit more about our unit operations laboratory. You see here on the left, these are some of my students who we take a lot of these things that we have to various high schools and community colleges. We're always trying to get to teach people what chemical engineering is about and how we can all play a role in it. But inside the distillation tower, what happens is you have a liquid that boils up, and so you have a vapor stream going up, and I'll go a little bit here and then at the very top of it, I'll go to the industrial one here. We condense some of that back to a liquid, and then we send it back down the tower, so that there's always this intimate mixing of the vapor and liquid phases, and it's in those zones where the separation is occurring. What's happening is that as the more volatile compounds move up the tower, it becomes more and more increased in concentrations of these more volatile compounds. So again, so some of these pictures you'll see, you can kind of see it in the background of me here, because again, that is where I am. It's designed to look and operate just like a real chemical facility. Inside this room right here is the control room, where on the sides of the lab are the processes themselves, and everything gets to be controlled via the computers. You see here I have a flow control valve and a flow meter here, so I can change. What I have is a series of pumps here, and they're all the same except for the impeller diameter. And different diameters will give you different flow regimes, and we can see by changing the valve setting here what the new flow rate is. We have reactors. This is a batch reactor, so are these, and then an industrial one here. Actually, these here, this was an experiment that I was doing when I was a graduate student. We put chicken litter inside these. Yes, we went to a chicken farm, and we told the farmer, hey, we want your chicken poop. That's what we want. We can and so putting them inside these here, we let Mother Nature do what Mother Nature does, and we'll convert that waste into natural gas or methane. And then you can run a modified engine off of it, and you can generate your own electric power. a dairy farm, for example, say if you have 150 milk cows, so you might milk 150 twice a day, the manure that is generated from those cows is more than enough, well, at the end of the day, will produce more electricity than what is needed by the farm. And they can actually add that to the electric grid. Now that's some green energy right there. But there is life outside of class, besides all the homework and all the fun stuff, right? Now, there's life outside of class, and I particularly want to highlight the student organization called American Institute of Chemical Engineers. It's our international professional society, but we have a student-led group, and we have various competitions such as Chemi Car. You want to see something really cool, take a moment and Google AICG Chemi Car, and you can see a lot of the professionally made videos that they have over a number of years. Lamar University hosted 2 weeks ago, we were hosting the regional meeting. Our team didn't do so well in the Chemi Car, but we rocked the Chemi Jeopardy. We got first place in our region, and that means in the fall when we go have the national meeting, our Chemi Jeopardy team will compete at the national meeting. We also do research presentations. I'll talk about research in a moment. Conferences, regional, national conferences, fun activities such as barbecues, crawfish boils, ice cream socials, canoe trips. Man, I told when I first became the advisor about 8-9 years ago, I said, look, I remember doing AICG when I was a student, we did whitewater rafting, we did canoe trips. I want to bring that to here, and by golly, we have. Through AICG and these other student organizations, we also have the professional development, resume workshops, mock interviews. I'm here to tell you that there's nothing more nerve-wracking you think taking a test is. Now, when you're interviewing and there's a person sitting across from you and they're just badgering you with questions, and when the first few times you're having to go through that, your brain really doesn't make those connections so quickly, and you can't always talk about it as quickly as you should be able to, and you're just sitting there in silence. More silence, right? We help you with that, and by providing these mock interviews. In other words, we pair you up with people in the industry who aren't the people you interview with, but they understand the kinds of questions that will be asked. We also have company info sessions where companies will come to campus, excluding this year of COVID, but it looks like in the fall we'll be back to our normal operations. Plant tours, we take a lot of plant tours. We want to make sure that students have a real understanding of what goes on inside of these facilities, all the safety aspects behind it, and then exactly where do you play a role in it. Co-ops and internships, I don't know that I could speak on this for hours, to be honest with you. I co-opt, and it is the quintessential moment that says I am in the right place. Now, these are not minimum wage jobs. Our co-ops and internships are generally somewhere between $25 to $40 an hour. And what you do is you take a semester out of college, you work your 40-hour weeks in these places, and then what you can do is you can save up that money and you can pay for the next 2 to 3 semesters of the university. Recently, and this, when I say recently, we took this picture just this week. Our AICG student chapter won the Outstanding Student Chapter Award. That's only offered to the top 10% of student chapters. There's a list of criteria that it takes to get this, and we finally did it. And here's Miss Caroline Bridges, our current president, and looking forward to next year. I'm still on cloud 9 in case you can't tell. You also have opportunities to work with faculty and doing hands-on laboratory research. Here's just a few of the students that I have worked with, both at in graduate school as well as here at Lamar University. I'm always looking for new and bright talent. So why choose Lamar University? We are certainly competitive in salaries. This is about 6 or 7 years old, but we rank just behind Rice in terms of mid-career salaries, And then in terms of the return on investment, we were just behind UC Berkeley. Now that on the return on investment, that's a matter of how much did you pay to go to college versus what you're having to what you're getting in terms of pay beyond it. So our graduates tend to be very competitive in receiving high-paying jobs. The student to faculty ratio is such that I've never seen a class in here that has hundreds of students in a class. It just doesn't happen here. It is an ideal location for engineering internships and co-ops. And of course, we are ABET accredited. We're located in Beaumont. We have about 15,000 students total, about 10,000 undergraduates, and we're in the Texas State University system. And with that, I will conclude and take any questions that you may have.
Thank you, Dr. Benson. If y'all have any questions, please type them in chat and I'll read them aloud. All right, one of the questions is, what course should you take in high school to prepare you for a career in chemical engineering?
Let's see. Besides the standard chemistry and all your pre-calculus or calculus courses, you know, I would really recommend things that work on soft skills. Engineers, in case you hadn't noticed, we are typically deficient on those communication skills and leadership. So I would recommend getting, whether it's a class specifically or in student organizations that are at your high school.
All right, thank you. Another question is, what is the hardest part of your project? Sorry, part of your job.
Hardest part of my job?
Yeah.
As a faculty member, I have a lot of research, and I would say that the hardest part of research is not working with students, not at all. It is not the going to the lab and collecting data and trying to figure out what that data means. No. The hardest part is always writing proposals. That's the hardest part. You know, in scientific research, for every question that you answer, at least 2 more new ones pop up, and that's the way science always propagates. Now, taking a scientific question, developing a hypothesis, getting enough preliminary information, that data that you need to be successful to write research proposals, that's more difficult.
All right, another question asked is, what was the hardest project that you had to take up?
And I don't know, I'll say it this way. One that we're currently working on is, it's a conversion of waste carbon dioxide. And it's a photocatalytic reaction. It's a low temperature. So in other words, light hits your catalyst particle, and what it does, it creates this oxygen vacancy. Carbon dioxide comes and comes to that vacancy there and causes the reaction. What we see is that we have low conversions. This is no matter what scientist, what chemical engineer you're talking to in this world, photocatalytic conversion of CO2 is just low conversion. And we can add other things to the titanium dioxide, the catalyst itself, and we can see much better responses. You have much higher conversions. Understanding how that mechanism works is troubling. And that is, and just this morning I was writing a new proposal, right? And that's the one thing I'm trying to wrap my head around, so that when the proposal goes out to review, that we're making a valid scientific argument.
All right, thank you. That basically wraps up this session. Thank you once again to Dr. Benson for coming and teaching and educating us on the many aspects of chemical engineering and his job. Please give a digital round of applause to Dr. Benson.
Thank you very much.